Hello, welcome to Module 1, Lesson 1 of our CASP Plus course. In this lesson, we're going to talk about the following, like security services, traffic monitoring, sensors, segmentation, and software-defined networking, or SDN. So first, let me give you an introduction about what a secure network architecture is. So to provide a secure network design for a new or existing network, security experts need to examine security requirements and objectives. They also need to provide proper authentication and authorization controls. Practical and security issues arise while designing a contemporary company network. Information systems can now be accessed from devices outside of the company's network, which is known as deperimeterization. Devices range from a simple smartphone to an IoT gadget or Internet of Things that sends telemetry data to a vital monitoring dashboard. So, if you took the CompTIA Security Plus and Network Plus courses, you should at least be familiar with the security services. I will quickly explain each of these services, then give you a casework so you can further explore these services. You can use this list as a checklist as you compare different security components and services. So the first one is load balancer, right? So I'm sure you have heard what a load balancer is before. So load balancers are quite essential for high availability or HA e-commerce sites and businesses that run server farms. So when hosting a server farm supporting remote desktop application, it's important to monitor each member's load to guarantee new requests are sent to the least loaded servers. As you see here, right? If this is least loaded, right, and this is heavily loaded, already 100%, so the next few requests coming from the client will be forwarded to the least loaded server. So this is how the load balancer works. Next is the IDS and IPS, which is in here and in here, right? So IDS and IPS keeps an eye on your network all the time, looking for possible problems and logging information about them. They can also stop problems from happening and let security administrators know about them. Some networks also use IDS IPS to find problems with security policies and stop people from breaking security policies. IDS and IPSs are very important as they can stop attackers from gathering information about your network while trying to break in. Let's talk about firewalls, UTM, or Unified Threat Management, and next generation firewalls. So regarding firewalls, right? So security measures such as firewalls are designed to prevent undesired traffic from entering and exiting your network. Routing protocols and ports are all controlled by firewall rules. Now, advanced firewalls will have more granular rules. However, it will slow down traffic processing as a result. Now, what's a next-gen firewall? So, because they're designed to perform several security functions, next-generation firewalls have evolved from second-generation firewalls. Additionally, next-gen firewalls often have additional features like, VPN, right? VPN support and antivirus protection. Next-gen firewalls include DPI functionality, which means they can provide DLP or data loss prevention and IPS protection, in addition to their standard security features. Next-gen firewalls may seem similar to UTMs, right, or the Unified Threat Management here. However, next-gen firewalls are built for speed. We put here speed and efficiency. Okay. So this is for the next-gen firewalls. Now there's another word here, or another term here, which is UTM, right, or Unified Threat Management. So UTM appliances combine firewall and other security features into a single unit that may be deployed on premises or in the cloud. All of the features or security features you need are included in this single package, like as you see here. There's a lot. You have spam filter, DLP, it can be a router, it can be a proxy, a firewall, WAF, antivirus, and IPS. So UTM is a very solid solution for small businesses with limited resources, but it does not provide the DID level or the defense in depth necessary for larger clients. Okay, so this one is for smaller businesses. The fourth one is what we call as WAF, right? WAF, or the Web Application Firewall. So a WAF, or Web Application Firewall, works at the level of the web application. It lets HTTP or HTTPS traffic, right, coming here, going here, to be looked at for any strange behavior in the rest of the network traffic. A WAF can be set up as an appliance, a filter, or a plugin that imposes a set of rules to an HTTP connection without slowing it down, right? So for example, here you have a WAF within your DMZ and you have a couple of web servers. A lot of web users, right, is going to try to connect to this web server via HTTP or HTTPS, but it has to be filtered first by the web application firewall, right, before it reaches the web servers. Next is the NAC, or the Network Access Control, right? So NAC, or the Network Access Control, makes sure that devices that connect to our enterprise networks have a strong, secure state or posture. A captive portal is usually used to connect devices to a VLAN for registration. If a device complies with the policy, it could be given access to the network. Devices that didn't follow the rules would be sent to an isolation VLAN where they could use remediation services. So for example, if you have this device here, but this does not comply with the set poster compliance filter, right, or setup, then it will not be allowed to access the corporate network. It will be quarantined or put to an isolated VLAN. So the IT administrator or the user will be able to run like patch updates, right? Download software updates from Windows. So once it's compliant, then it will be allowed access to the network. So that's the purpose of NAC. One of the in Cisco, right, that they have Cisco ISE, or Identity Services Engine, which is being used as a NAC as well, right? Next is the VPN, or the Virtual Private Network. So when you need to connect across networks that you don't trust, VPN gives you a safe and encrypted tunnel. So here, threat actors from the outside can't use the tunnel to get to your business data. A VPN can be used to protect remote workers and connect sites across networks that can't be trusted. So in this illustration, right, a user from, let's say, from working from home, right, and he has to connect to the corporate network. He will use a VPN client to be able to establish a VPN tunnel via the internet going to the corporate network using the VPN gateway. So if there's an attacker here, it will be this guy will not be able to see whatever traffic is being sent on the tunnel, right? Because this is encrypted. So that's the purpose of virtual private network. Next is DNSSEC, or Domain Name System Security Extension. So with DNSSEC, you can add the DS record or digital signature to the DNS records of your domain names, making them more secure. By upgrading to Premium DNS, you'll have access to DNSSEC protection. You can also manually add a DS record to your account if you're using self-managed DNSSEC. Next is NAT Gateway, or Network Address Translation Gateway, which is in here, right? So when a private network is connected to the internet, it doesn't require assigning each host a public IPv4 address. So this is actually known as Network Address Translation, or NAT. So hosts can establish internet connection and get responses, but they will not receive connections established by the internet, right? So if you have users here who wants to connect to the internet, it doesn't mean you have to assign a public IP for each of these, right? What if you have 1,000 users here, right? And this public subnets is quite limited and it's quite expensive to buy. So what you can do is to install a NAT gateway. So if these users want to connect to the internet, then their IP addresses will be translated to this public IP assigned to this company, right? So all of them can use it, but using different ports, right? That's what you call as port address translation, which is a flavor of network address translation. All of this is happening on the NAT gateway. So this can either be a router or this can be a firewall. Next concept is the internet gateway. So a node that joins two networks, right, using different protocols or rules to communicate is known as a gateway, right? Now, if you think of an internet gateway, it is used as a gateway to or from other networks. So thanks to internet gateways, we can communicate and exchange data with each other, right? So let's say you have a server here, server, e-commerce servers, and people from outside. Let's say a user wants to connect to here, right? Of course, the only path is via the internet, right? Because of the internet gateway, this could be a router, this could be a firewall. They will be able to reach out or connect to a specific service on this web servers, which is inside a specific company or hosted at a specific company, right? So that's the internet gateway. So this is also very popular in cloud networking, right? If you have servers within the cloud that needs direct access to the internet for patch updates and etc., they can use an internet gateway directly, right? Now let's talk about forward proxy. Forward proxies are servers, right, that go between a client, this one, on a network and the internet, right? So you have the forward proxy in here. So when these machines want to get information from the internet, the proxy server intercepts those requests, right, and connects to web servers on their behalf. So that's what you call as the forward proxy. Now the next one is the reverse proxy, which is exactly the reverse process of the other one, right, of the forward proxy. So here, what's a reverse proxy? So a server that sits in front of one or more web servers, right, this is your web server, and intercepts requests from clients is called a reverse proxy. So there's your client requesting services on this responding servers. So with the reverse proxy, when a client sends a request to a website's or original server, or origin server, the request is caught by the reverse proxy server at the edge of the network. The reverse proxy server will then send requests to the original server and get answers back from it. Next is DDoS protection, right here. So if a company is targeted by DDoS attacks or distributed denial of service attacks, the consequences can be disastrous with costly outages and dissatisfied customers. Targeted organizations have been subjected to attacks with traffic quantities exceeding 1.5 to 2.5 Tbps. That's terabytes per second, right? That's really huge, right? So if you remember around 5 years ago, or maybe more years ago, an attack on Google resulted in like 180,000 DNS servers receiving faked requests for the domain name system, or DNS. Right, so Google's infrastructure services receive the majority of the traffic. All right. Some familiar word here, router, right? We know this already. Routers are devices that connect networks. They work at layer 3, L3, right, of the OSI model, and they connect networks together. So a switch that supports VLANs may also be able to handle routing, and this is what we call as a layer 3 switch. So this can also be layer 3, right? If you configure SVIs or switch virtual interface, right? And you can enable a routing protocol there, right, on that specific interface, and that can be called as a layer 3 interface. Another component here is the email security. So email security refers to how email accounts and the content and communications shared through them are protected against unauthorized access, data loss, and other types of compromise. It includes tried and tested methods like password protection, email encryption, as well as more advanced features like spam filtering and stopping fraud. So if you have incoming emails, it has to go to a secure email gateway first. Then whatever the policy here, right? Some emails like spam will be dropped, and some allowed emails, right, that complies will be allowed to be sent to the corporate network, right? So that's the function of secure email gateway. For Cisco, they have what we call as ESA, or email security appliance, right? Cisco ESA. So this is their secure email gateway product, and this is from Cisco. The last one is the API gateway or XML gateway. So here, right, for API gateway, request routing, composition, and protocol translation are just some of the functions that an API gateway performs on behalf of clients. Typically, it uses numerous microservices to process a request and then aggregates the information to identify the best course of action. It is able to also translate between web protocols and others that are not. Now, what's an XML gateway? Here. So a web services platform's DMZ tier that is accessible from the outside is known as an XML gateway. DMZ tiers are typically located between corporate units. All right, that's the security services. Now let's move on to the next topic, which is traffic monitoring. So traffic monitoring or traffic mirroring is used to copy network traffic and forward the traffic to an analyzer. And this is mostly helpful if you are troubleshooting a network issue or investigating a potential breach. First, let's talk about span ports, right? I'm sure if you're a network engineer, you might come across what a span port is, right? Especially if you're running a Cisco network in your data center, right? So what is a span port? Port mirroring, right, which is called a span or switchport analyzer, are ports on a network switch that are configured to forward a copy of packets from one port to another where an analyzer is connected. Take note that the span operation does not impact the switch's normal operation. So in this illustration, right, you have a switch, then you configure, so let's say this is a port, right, that is where this device is connected. You have a port where the device B is connected. So whatever traffic, right, depending on what you set, what you configure on the switch, it could be the receiving traffic or the outgoing traffic. All of this can be captured and on this port, forwarded on this port, right? So it will be received by a specific analyzer. So you will have a view on whatever traffic is, being received or forwarded on this specific port from device A or coming from device B, right? So there, this is what a span port is. Next is a network tap. So here, right, it is possible to gain access to and to monitor network traffic through the use of network taps. So network taps are dedicated hardware devices that sit between either a router, a switch, or a firewall. Because they use distinct dedicated channels for sending and receiving data, taps ensures that all data reaches the monitoring or security devices in real time. Okay, so taps, this is typically deployed inline, right? Let's say you have a router in here, you have a firewall, right? You can easily install it in here, in between, right? That's how you use a network tap. And this is actually much more flexible. And I said, right, this is you can get data in real time as compared to span ports. All right. Let's go to the next topic, which is about sensors. Right. So network sensors are critical components of the network to provide insights and trending analytics from the packets captured from the network. There are several mechanisms involved to monitor potential breaches, data leakage, and information sharing within the network. Let's talk about SIEM first, right? So for enterprises, right, SIEM provides a way to consolidate security management events by sending logs from security appliances to an organization's central system. It provides correlation and normalization as well as real-time data inputs for reporting and alarms so that the context can be added and alarms can be set. Okay, so with SIEM, if you have like all of these data sources like a router, switch, firewall, or the PC. All of this can forward specific events or logs going to the SIEM, and the SIEM will forward it to a specific dashboard, right? Or well, at least you will have a view on whatever is happening, and you can do correlation analysis between like the firewall and the user. So this makes the analytics better, right? So you'll be able to pinpoint a specific problem or potential breach in the network. Next is FIM, or File Integrity Monitoring. So the data that an organization has can be very important, right, to allow to how it does business. Some examples of data that is held and processed are sales orders, processing records in a CRM database, right, and financial transactions in a bank. So file integrity monitoring is one of the many ways to make sure that data is guaranteed. Of course, right, you don't want to be doing a transaction or maybe sending money from your bank to another bank. However, when your file was compromised, it may change the value of the amount that you sent or maybe the account number that you put. So it's not gonna be received by the intended recipient, or maybe the amount that you sent will be changed, and that's going to be bad, right? Next is SNMP. So if you're a network engineer, you should, well, at least that's one time, you've configured SNMP, right, on Cisco, on different network devices. So here, network devices can communicate with each other using SNMP, or Simple Network Management Protocol. Using this technology, various hardware and operating system devices can connect with one another. Without SNMP, there's no way network management tools can track and analyze the health of a system's network, identify and monitor devices in real time, or track changes to the system. Let's talk about NetFlow. NetFlow was originally designed to log traffic on Cisco networking devices. An insight into bandwidth consumption and traffic flow can be gained by network engineers using it. NetFlow is not developed to replace SNMP, remember that. In NetFlow, network anomalies can be spotted by establishing a baseline. Okay? So here it's just like span, right? If you have a switch here, you enable it with NetFlow. All traffic coming from the user or from the server to or from, right, can be forwarded to a NetFlow collector, so you can establish a baseline, and you'll be able to see if there's any outlier, right? So let's say you have this baseline, right, on using NetFlow. However, on a specific day, right, it suddenly came up very high, so there could be some kind of anomaly, and this should be investigated because it's outside, it's just too far from the baseline, right? So there must be something happening here. All right. Next is data loss prevention, or DLP. So here, preventing the unintentional exfiltration or leakage of sensitive data begins with properly identifying and securing such data. A variety of methods can manage this requirement. It is possible to assure proper data management and operational procedures by applying policy-based measures. Network egress points can benefit from DLP filtering. Right? So one of the examples of DLP is the one that we discussed earlier, which is secure email gateways. All right, and the last sensor is antivirus, right? So we know if you're using a laptop or your own personal computer, you should have an antivirus, right? So you don't there's a lot of risk now, like people from outside can install can install a ransomware, so they can own or encrypt the data that you have within your hard disk. So if you want to retrieve all of this data, you have to go to a website or to a certain link to pay that, so they can give you the encryption key, and that's going to be expensive, right? So with antivirus, right, cyber criminals can't easily spread harmful software because of this kind of protection in place. This action should be recorded and monitored, even if the antivirus detects nothing wrong, so we know how widespread it is. A centralized reporting dashboards are very ideal for this. Okay, so that's the antivirus. Okay, let's talk about segmentation. So what is segmentation? So segmenting a network into smaller subdomains allows network teams to segment the subdomains and deliver different security policies and services to each subdomains. So here you're creating logical subnetworks from physical networks, right? And this is the goal of network segmentation. Controls are added to each of the network component once it has been broken down into smaller, more manageable units. So what is microsegmentation? So using rules that specify how data and applications are accessible and controlled. Microsegmentation is a method for dividing a network into discrete, logical, and secure pieces. In contrast to network segmentation, which relies on hardware and is geared towards the north-south traffic flow. So when you say north-south, you have like let's say you have a switches here, you have servers, you have a firewall here, firewall. So if traffic goes here, that's what you call as north-south traffic. While microsegmentation, right, is software-based and is geared toward east-west data flow or traffic between server. So this north-south, right? East-west traffic is between servers in here, right? That's east-west traffic. So I think 10 years back, this is a big problem, right? Especially for banks. So let's say you have servers, let's say this one, on this example, you have a web app and database server. And there are instances where third-party providers will need access to a specific server. Let's say to a web server. Before, all of this are just connected via switch, so it means if they're sitting on the same VLAN, then there's a possibility that this guy can access the server, the app server, or here jump to the DB server. Of course, you can implement access lists and etc., right? But these are very these are not strong controls, right, to protect the east-west traffic. With microsegmentation, there's a way for you to ensure that this guy will not be able to easily access or connect to the server that is not intended to be accessed by a specific user, right? There's also some use cases where, let's say you have all of these servers, right, on a VMware environment, and this is compromised. All of the web server using attributes or tags, you can easily microsegment all of these servers, right? So it will not be able to connect to the app or the DB because this is compromised already. So because of those tags, if you have like 10 or 20 web servers, you can easily do it on a VMware environment, right? So as to protect the most important server, which is the database server. Okay? So that's microsegmentation. All right, VLAN, we know this already, right? There are two types of VLAN. Those that use physical location as a mechanism of segmentation and those that do not. Custom networks do not have to be part of the same VLAN, and they can be combined into a single logical network that is viewed as a whole rather than as a collection of subdomains with separate configuration. So here you have users, right? So let's say you have the HR, IT, what else, finance, right? You can put them logically on their own specific VLANs, right? You can, if you don't want these guys to talk to each other, the classical way to do it is to put an ACL, right, on their SVI, right? Because if you don't, then this VLANs can talk to each other by default, right? You can also forward it to a firewall, right? So before reaching it, so let's say you have a firewall here. When this user sends the traffic to the switch, it has to forward it to the firewall first before going down to the other VLANs. Another practical way to do it is by using a NAC, right, or Network Access Control. So this is the one that we discussed earlier. Okay. Next is a jump box, right, or a jump server. So to access and administer devices in another security zone, you need a jump server or what we call as jump host or a jump box. This is, or as a protected and monitored equipment that crosses two different security zones, a jump server provides a regulated method of access between them. So if you're building um, uh, infrastructure in the cloud, right? So they enable a specific server called a bastion host, right? So bastion host is also just like a jump box. So if a third party user or somebody has to access a server, he has to connect to the jump box first before being allowed to connect to the server, right? So you're not going to be allowed to connect directly. So this is what you call as a jump box. All right. Another concept here, a screen subnet. So it refers to an architecture in which logical screening routers operate as firewalls, right? And it's known as a screen subnet. A screen subnet divides a network into three sections, such as the perimeter, right? The perimeter here, or the DMZ, the internal network, and the external network or the internet. The perimeter network should have one exterior router, and the internal network should have one internal router to assist in preventing inbound connections. Let's talk about the data zones. Segmentation of infrastructure services into logical groupings with the same communication security regulations. And security needs is used as zoning to limit the risk of an open network. Okay? So here, you have different zones, right? Management zone, internal zone, DMZ zone, external zone, or going to third party, right? Best practice design, put a firewall there, right? So you have filtering on the layer 3, layer 4. If you are a firewall, right? You can also filter, I don't know, you can put filters here up to the upper layers of the OSI, right? So you have like IPS, IDS detection, because this one is very important, right? The management zone, because this will have access to majority of the services here. So this should be protected at least. Okay. So with this zoning, right, it ensures that any compromise happening on a specific network will not be easily propagated to the other network, right? On a virtual environment, on a data center, this is actually the setup that they do, right? Let's say if you're talking about VMware using NSXT, VMware NSXT, you can easily configure a distributed firewall, right, in front of a web server, so you can easily protect it. It doesn't have to go somewhere else to a centralized firewall to get that specific level of protection. You can put it on the endpoint, in front of the endpoint, and it's much easier. All right. Next is the staging environment, right? So in essence, a staging environment is just like a replica of a live production environment where software engineers are free to test their softwares. So despite their striking resemblances, the staging and production settings are entirely distinct. As soon as a change is made in a production environment, it immediately impacts the end users. On the other hand, all system modifications take place internally in a staging environment. So this provides software developers more leeway to experiment and make changes without affecting the end user experience, which is being provided by the production environment. Right? So that's the staging. And the next one is the guest environment, right? So visitors will be able to connect to the internet via distinct SSIDs, right, for wireless, or networks that are not connected to your private network via the guest network or the guest environment, right? So if you have a wireless LAN guest here, connects to the AP, we will not have access to the corporate network and will just be allowed access going to the internet. Okay? All right, the very last topic is about SDN, or software defined networking, right? So over the past decade, software-defined networking technology has become a well-established approach to network management. So a shift to big centralized data centers and the virtualization of computer systems has been a major factor in their development. The transition to cloud computing has also boosted SDN usage. So what is OpenSDN? It is possible to design and operate a network using SDN because it is built on a set of open standards rather than relying on a variety of vendor-specific devices and protocols. For the first time, a consistent interface for separating the control and data planes of a network has been established. An SDN controller, known as ONOS or Open Network Operating System, was developed. Right? Open Network Operating System. Now, so what's a hybrid of SDN? Networks that use both classical and SDN protocols are known as hybrid SDNs. Using a hybrid SDN, a network engineer can bring new SDN technologies like OpenFlow into the legacy network without having to completely re-architect the architecture. Next is SDN overlay. So overlaying an existing network with a logically independent network or network component is known as an SDN overlay. And it is a deployment strategy for SDN. An example of an SDN overlay is Cisco ACI and VMware NSXT. So as you will see here, right, on the illustration, you can have any devices here, right? Well, for Cisco, it's different because it has to be Cisco Nexus switches, and you're gonna run ACI on top of it, right? And this you cannot use any other devices for Cisco ACI. However, for VMware NSX, if you have data center switches here, whatever data center switch that you want, as long as they have connectivity, supports L3, right? You can put or install VMware NSX on top of it as an SDN overlay. So this is not dependent on the physical switch that you installed. However, Cisco ACI only allows you to use Nexus switches as the physical underlay for the data center. Okay, there you go. So on the next part, it's just a case study, right? So we've discussed a lot of security features and components and etc. But here on the casework, based on what we discussed, I'd like you to research which vendors provide the following security services below. Like for example, you have a load balancer in here. So one of the well-known load balancers are F5, Kemp Load Balancer, A10 Network, and there's actually a lot more. I think it's better. It's good that you at least have a view on what all of these are, but you also have to at least be familiar on what vendors provide these services. Maybe just come up with three, but there's just a lot, right? In Cisco, they can cover the majority of these services, right? But best to check the other vendors. So if you come across like if you have to be solutioning a specific or proposing a specific bill of material to protect your data center, right? So you at least have some idea on what vendors to choose from. Okay. And also this one, Internet Gateway, email security, SIEM, SDN overlay, and etc. Okay, so this is just for your own research. All right, thank you very much. In this lesson, we spoke about security services, traffic monitoring, sensors, segmentation, and software-defined networking. Thank you very much for watching the video. Hello, welcome to Module 1, Lesson 2 of our CompTIA Plus course. On this lesson, we're going to talk about infrastructure architecture principles such as reliability and resiliency, modularity, scalability, fault isolation, hierarchy, responsiveness, holistic design approach, and no gold plating. Excuse me, pen. All right. So network design is the philosophy that tells how different parts protocols, and technology should be put together and used based on certain approaches and principles to make a cohesive network infrastructure environment that can help businesses reach their tactical or long-term goals. This lesson, on the other hand, is about the design principles that network designers must keep in mind when making a network and turning business, functional, or application requirements into technical requirements. It is also important to realize that these ideas are not separate from one another. So, if network designers want to make a good design that meets its goals, they should think about how each of these principles fits into the architecture as a whole. However, not all of these principles may be useful or necessary for every design. By using the top-down method, network designers can figure out what to focus on and what to think about. A reliable network sends most of the packets it accepts to the right place in a reasonable amount of time. Converged networks of today require maintaining a high level of reliability in order to meet the needs of today's enterprises. So even more important for these businesses, especially service providers, right, and modern financial institution, is that their network is seen as a way to make money. So as you will notice here, right, a 5-minute network outage that impacts X number of customers can cost a company hundreds of thousands of dollars. Right? So a key design principle is to have a highly reliable and available network architecture that can keep running even if the network component fails without any help from an operator. This is called resiliency, right? And it is a top priority for most businesses in the modern world. For the network to have the level of resilience that is needed, there must be a redundant part that can take over the whole or a failed part after a failure event. Okay, so that's reliability and resiliency. Let's talk about modularity. So in software development, modular design is often used, right? This is because an application can be built from multiple blocks of code that work together to make the desired applications. These building blocks of modular structure make the application architecture better and easier to use as a whole. Like for instance, if there's a problem in one block, right here, there's a problem in one block, let's say this is the first block or module of that software, it is easy to separate it from the other modules and fix it on its own without affecting the other parts of the network, like this one, right? This is still green. So also it is easier to add new modules or blocks to the structure if new features are needed, which is good for making improvements over time. Okay, that's modularity. Modularity makes the application architecture as a whole more structured and easier to work with. In the same way, modularity is one of the main ideas behind a structured network. In a structured network, the architecture can be broken up into multiple functional modules. So here, right, each module has a specific role in the network and is represented by its own physical network. The places in the network, which includes the enterprise campus, right, which is enterprise campus, the wide area network, and the data center are also part of the individual physical network. So as you will see here, you have, of course, there should be a switch, right? Nobody's using a hub anymore. So you have a server here. So this is one module. You have an internet part here, which is another module. You have the LAN, local area network, right? Where the clients are. You also have wireless services in here, right? So these are different modules as you will see, right? It's easier to change something. Let's say if you want to change this hub to a switch, then it's not going to impact whatever is happening on the server side, on the data center, or on the internet, or on the wireless network. Maybe on the wireless, right? Because the APs are connected to the switches. But yeah, this is still modular. All right. Let's talk about the next concept, which is scalability. So one of the most important things a network designer should think about is how to design for growth. In fact, a successful scalable network is judged not only by its size, but also by how stable and reliable it is and how easy it is to manage and fix problems on. Like for example, a network may be set up so that it can grow to include thousands of routers, right? However, if one link or device fails, it can cause a lot of processing and CPU usage across the network, which could make it unstable. Even though it can grow to a large number of routers, this design cannot be called scalable in a good way. In the same way, a network may be made to grow to a large size, but it may also be hard to manage and troubleshoot, so any problems could take a long time to fix. This network is also not good, a good example of a scalable design. Okay, so let's say here, if this goes down, right, all of this routers reacts in processing, receiving all the changes in routes, which could increase its CPU utilization and impacting the users that is connected to them. So this is not very scalable. So of course, if you know how to properly design routing, right, you know how to properly design what devices or hardware should be put in here, right? So you will be able to at least make a very scalable network. So, a successful, right, scalable design must have a network that is both easy to use and reliable. In other words, the added complexity of configuration and troubleshooting will outweigh any benefit of being able to grow by size alone. All right, now let's talk about fault isolation. So, most fault isolation boundaries are made so that if the fault model fails, the system stops working. The word fail stop means that incorrect behavior doesn't spread past the fault isolation boundary. In other words, when designing a network, you have to think about how to stop a problem in one domain from spreading to the rest of the network. Let me give an example. So this is needed, right? So that the broken link or device in one part of the network doesn't cause extra work and delays across the whole network. For example, you can deal with this problem in routing design by using summarization and logical flooding domains. It is always recommended that complex networks, either physically or on the control plane layer, be logically contained, each in its own fault domain. All right, so here you will have a more stable, reliable, and faster network that is coming together. Also, this idea brings simplicity to the architecture as a whole and reduces operational complexity. In general, fault isolation stops network fault information from spreading across multiple network areas or domains. This makes network design more stable and speeds up the time it takes for the network to recover after a failure. Okay, like for example, in this illustration shown, if any network node or link fails, the effect will be felt by all devices on the campus network. After this failure, a lot of unnecessary work might be done. Right, so let's say, well, this is a router icon, but let's say these are switches, right? If one switch is sending a lot of packets because it's faulty or there's some bugs or field notices, and this might impact all of the switches within the broadcast domain, which could bring down the whole infrastructure, right? So best practice on a campus LAN, ensure that you don't spread the VLAN across a lot of switches. Maybe just limit it into two switches so you have redundancy, right? Let's say you have a VLAN 10 here, right? You can also port channel this if you want. Yeah, just VLAN 10. The other VLANs, put it on another pair of switch. So you have fault isolation. Okay, next is hierarchy. So adding hierarchy to the overall network design and within each domain or block can greatly simplify the design and increase its flexibility, making it easier to add more efficient places to isolate fault domains. This is because the network designer will have more choke points to collect traffic, topology information, and reachability information, which will help with the logical or physical isolation. So this figure shows an example of a common service provider network with two tiers, right? And each POP is also made of more than one tier. The hierarchical structure makes it possible to control and limit the spread of failure across the core and between the different layers within each POP. Because of default isolation and control, like choke points between the several tiers provided by this design, the service provider is better equipped to adjust to future expansion needs, right? Which is being scalable without increasing the complexity of the overall design. Okay? All right. Let's talk about responsiveness. So the term responsiveness refers to the set of design characteristics that a flexible architecture needs to have in order to adapt to changing business applications and functional requirements. For instance, the design should be able to support the rollout of secure mobility for both employees and visitors. In this case, a flexible architecture is needed to meet this new need and allow for quick deployment and integration with other systems without making major changes to the overall design. From the point of view of the network, this goal can be reached with a modular, reliable design and the right architecture for the forwarding and control planes. When the architecture as a whole is very flexible, it will be much easier to adopt and integrate new business and technology needs in the future. This will also make it easier to set up implementations across the network. From a business point of view, this means that the network will be seen as a real service provider. Okay, next is the holistic design approach. Okay, so a holistic design is a common design principle that looks at the system being designed as a connected whole that could also be a part of something bigger. In other words, the holistic design approach focuses on how a system, like an enterprise network, works as a whole. There are many design options and things to think about for different types of networks, such as enterprise network or service provider network. Each type of network can be or can meet different needs or solve different problems. And before applying any of the designs to any part of the network, it is important to always keep the big picture in mind and use the holistic design concept. If you don't, you'll use a siloed approach to the design, which will make the network look like a communication islands, right? Siloed. This could lead to a less than ideal architecture with less performance, higher cost, and less freedom. Most importantly, this plan doesn't have a very big picture, so it's likely that communication between these islands won't work very well, and not to mention the added complexity to manage networks that were not engineered as a single architecture. Okay? That's the holistic design approach. Okay, so this one is important as well. No gold plating. So what does this mean? Okay, so gold plating is actually a term used in software engineering. It's also used in project management, and in general to describe a continuing to work on a project or task well past the point where the extra effort is worth the value it adds, right? So this idea fits perfectly with network design and can be thought of as one of the most important network design principles. Over engineering or adding extra features and capabilities beyond the needs can be risky. In other words, a network designer might think that adding more features to the design will make the customer happier, but these extra features may take longer to implement and cost more. Like, for example, the final product might cost more or you might need more licenses, while the design that doesn't have these features still meet the requirements. So, network designers must have a design that focuses on how to meet the requirements and make the network a business enabler instead of adding extra features that could hurt the business. Okay, that's no gold plating. Now let's go to the case study. So in this case I'd like you to review your company's IT environment. In terms of network security, update the table with the known gaps and pain points of your IT environment. On the next column, right, specify the impact if not addressed. And on the last column, research how it will be addressed. Like for example, in terms of reliability and resiliency, a common gap is the lack of redundant firewall facing the internet on one of the data center. If this fails, internet traffic need to be rerouted to the secondary DC, which makes the architecture complex. To solve this architectural concern, you may want to add a redundant firewall, either on HA or clustered. Okay, so firewalls on HA is much more recommended. So firewalls in DC1 and DC2 are independent of each other, right? As compared to doing a firewall cluster between DC1 and DC2, as they're not going to be, independent of each other if it's clustered. Okay, so this is the casework. All right, that's the end of the lesson. In this lesson, we spoke about reliability and resiliency, modularity, scalability, fault isolation, hierarchy, responsiveness, holistic design approach, and no gold plating. All right, thank you very much for watching the video. All right, hello. Welcome to Module 1, Lesson 3 of our CASP Plus course. On this lesson, we're going to talk about the following topics like baseline and templates, software assurance, consideration of integrating enterprise applications, and integrating security into development lifecycle. All right, just an intro. So when creating or contracting new services or software, we need to be aware of the possibilities available for a repeatable framework. We need to know how these services and systems can be implemented safely and tested. Now, understanding how can we ensure that products achieve the proper trust levels is critical for security professionals. We must demonstrate to prospective clients that our products and services are dependable and up to industry standards. So, when developing new systems or software, it is critical for an organization to adhere to established standards and processes. Now, when developing or evaluating third-party systems, keep compatibility in mind, right? As you may know, UK-based businesses can seek advice from NCSC. We put it here, NCSC, or the National Cybersecurity Center, which is a government entity. There's actually 5 stages in an attack that can be mitigated, so they are grouped each set of principles into 5 categories. Here are the 5 NCSC categories. First is the establishment of the context. So that your defenses have no blind spots and you need to know all of the components of your system. Second is make compromise difficult. So only those components of a system that an attacker can gain access to can be used as a point of attack, increasing the difficulty of breaking into your system. Third is make disruption difficult, right? Here you need to create a system that can withstand spikes in traffic and denial of service attack or DOS attacks. Make compromise detection easier. So here you need to create your system in such a way that you can detect any suspicious activity immediately and take the appropriate action. And lastly is the reduce the impact of compromise. So here, if an attacker manages to acquire a footing, they will then move on to exploiting your computer system. So you have to set the bar extremely high. In addition to pursuing industry best practices and implementing a repeatable security approach, it is necessary to adopt methods that enable validation and compatibility with other vendor solutions. A SaaS application, right? SaaS, here. Application hosted on Amazon Web Services on AWS, or a specific vendor operating system could be used an example for this. An application that will be used internally or commercially should go through a quality assurance procedure, right? Or what we call as QA. The Microsoft Store will only sell universal Windows platform applications that meet a set of tight criteria imposed by Microsoft. As a result, the testing procedure is extremely rigorous. So what are these kinds of requirements, right? First is the security test. So here your app will be scanned for malicious code. The purpose of this test is to confirm that the software complies with all the relevant technical standards. And in order to ensure that developers can verify their code before it is released, Microsoft has provided an app certification kit, which is free to use. Next is the content compliance. This ensures that all features are tested to ensure that they meet the content requirement. Third is the release and publishing. Here, in order to safeguard the application from being tampered with after the release and publishing, the application package will be digitally signed. Right? So this is the application vetting process. Now let's talk about API management. So using APIs, a business can make its assets available to B2B and B2C partners, customers, and other areas of its organization. Services, data, and applications are all examples on how these assets might be available to end users. It is vital that these assets are properly managed and protected. One possible concern is the theft or unauthorized disclosure of confidential information or intellectual property. Provisioning access to these resources will frequently be automated. These vital assets can be managed by a wide range of third-party solutions. Management APIs, as shown, right, illustrates consumers and partners interacting with services. All right, so here are the examples of popular API management platforms, which includes Google, APG, MuleSoft, WSO2, Tyke, API Umbrella, MuleSoft, APG Edge. Okay. Now let's talk about container APIs, right? Many programs will be virtualized and run in containers in the future. It's easy to scale up programs using containers, but deploying them on several hardware platforms can get a little too complicated. So here, large-scale provisioning and deprovisioning of workloads is required. I don't know if you have heard this, right? Kubernetes, or what they call as K8s, right? Kubernetes. Numerous virtual servers may be orchestrated. Pods are containers that can be scaled up or down based on the demand. Now, an ERP system, put it here, ERP, that includes various application modules of code might be purchased by a customer as an example. These services are required by a large number of the SaaS provider's client, and each one must be kept separate from the others. While this might be done by hand, automation is necessary for the following tasks like deployment, monitoring, scaling, and system self-healing in the event of an outage. Here it detects the problem and can restart or replicate failed containers. Okay, so as you will see on the figure, it depicts a high-level perspective of the API administration of containers. Let's talk about software assurance. So here, developing and making available to millions of businesses, organizations, and individuals reliable system and services is a top priority. Standard design concepts and procedures, standard coding techniques and tools, and established methods of validation are all used in the software assurance process. So next, we'll take a look at ways to ensure that bug-free code is put into production. First is unboxing or the development environment. So when designing new systems, it is critical to have clearly defined segments. Testing can be done in a different area from production systems, and generally utilizing a development system or network, and code will be developed in an integrated development environment, or what we call as IDE. Validation of third-party libraries. So third-party libraries are frequently used to expedite the development process because they don't have to create tools or procedures that already exist. Third-party libraries expedite the development process. Third-party libraries used by Android app developers include Retrofit, Picasso, Glide, and acing. Trustworthiness of third-party code is essential. There may be some security problems if third-party libraries are used, as open source libraries have become increasingly attractive targets for hackers. If you use third-party libraries, it's critical to stay up to date on the latest common vulnerability and exposure, or CVEs. If a flaw in the library in your code base is detected, you should think about the remediation that would be required. Third-party code is used in more than 90% of software development. Next is the DevOps pipeline. So defining the DevOps pipeline. Here, in order to ensure that the development and operations teams adhere to a set of best practices, a DevOps pipeline must be implemented. A DevOps pipeline ensures that the development, testing, and deployment of software into the operational environment are all done in a timely manner. So this slide will show you all the parts that make up a DevOps pipeline. So first you have CI, or the continuous integration. Here you compose the code from several teams, right, into a single build repository known as CI, or continuous integration. If the project is large or intricate, this may be done several times a day. Next is continuous delivery. CD is a common component of CI, and the development teams will now be able to roll out new features incrementally into the production environment, right? So you have the CI, CD. And you have the continuous testing, right? And the purpose of continuous testing is to find problems before they can be brought into production environment, which is why it is done at the every stage of the development. Okay, so errors in the code will be discovered during testing, both functional and non-functional. Next is continuous operation. So this is test, right? It's actually in here, first tree, and you have the operation, ops. So constant operations guarantees that systems and services in a company are available at all times. Even though users won't know about new software upgrades, the system will be kept up to date. So when introducing a new code, the goal is to minimize any disruption to the user experience. Automation across a diverse set of servers, operating systems, applications, virtualization, and containers will be critical to ensuring continuous operations. Okay? Next is code signing, right? So digital signatures should be used to verify the integrity of code modules once they have been thoroughly tested and validated. Over 80% of software breaches are caused by flaws in the application layer, and that's according to a recent study. So before the software is released, it is critical to remove these defects from the code. Now let's talk about considerations of integrating enterprise applications. Integration of business applications is vital, right? And major business tools and procedures are dependent on the integration and communication services provided by a company. There are numerous examples of business dependencies in an organizations. Sales and marketing would be a lot more difficult without the CRM tools that are, currently ubiquitous in the industry. If not for ERP systems, human resources department would have to rely on educated guesses when it came to hiring new employees. Without ERP systems, it would be impossible to organize projects in such a way that raw materials in the supply chain would be delivered on time, and these dependencies are numerous. Now let's talk about the following enterprise software. First is ERP, right? Enterprise Resource Planning. ERP is a system that helps companies manage a wide range of business units. The system would be used by manufacturing automobile companies. Integration and management of different processes are both made possible by ERP. An organization can use this software to combine its financial processes with procurement, manufacturing, sales, and reporting. Common databases managed by a database management system are used to integrate ERP's fundamental business activities. IBM, SAP, Oracle, Microsoft are just a few of the well-known names in the field. Now, what's a CRM, or a Customer Relationship Management System? An organization's ability to interact with its customers is enhanced by the usage of a CRM software, which includes a variety of data-driven applications. A CRM system can be used to monitor and maintain client connections, track leads for sales, marketing, and automate necessary tasks. A firm that does not have an integrated CRM solution may be at a danger of losing business to its competitors. Next is a CMDB, or Configuration Management Database. So information about all of your IT environment's major players is housed in a CMDB, which is a single central location. Configuration items, or CIs, right, are the hardware, installed software applications, documents, business services, and people who are part of your IT systems. Microsoft Configuration Manager and Intune can be used to automate the collection of data and characteristics in a CMDB, which is utilized to support a big IT infrastructure. So, for a successful service desk in an organization, this database is very critical. Next is CMS, or Content Management System. Using a web portal, a content management system, CMS, makes it possible to manage and run the day-to-day business of enterprise data. An administrator can give certain tasks to privileged users who can help with resource management. Users must be added so they can access content and, if necessary, create, edit, and delete content. Version control is important because it means that documents can be checked out to be changed, but unauthorized users can still read them. Microsoft Office 365 uses SharePoint to give users an easy to use and intuitive way to interact with a web based portal, which is usually called OneDrive or Microsoft Teams by end users. Okay, let's now talk about integrating security into the development lifecycle. So, when adding new systems to an enterprise environment, it's important to use a strong and repeatable method. Organizations must use the strictest standards taking into account legal and regulatory requirements and make sure that the system can be paid for. It is important to think about security at every step of the software development. Um, the systems development lifecycle, or SDLC, right, is well known and commonly used technique to system development. A typical model has 5 steps, and all the other models have up to 10. It doesn't matter which model you choose, and you need to have a clearly defined path from original concepts to a working product. The SDLC process includes requirements phase, or the initiation phase. You have the development acquisition phase, implementation phase, operations maintenance phase, and the disposal phase. Okay. It is also important to choose a method of development that fits the needs of the project. There are ways to do things that put more emphasis on getting the customer involved throughout the whole project lifecycle. Some approaches give the customer a clear picture of the finished system at the start of the process and allow the development to be done within a strict budget, while other approaches lend themselves to prototyping. No matter what you do, it must meet the needs of the customer. One of those is SecDevOps, right? One of the key terms. So the word software development and ID operations are where the word DevOps comes from. It means continuous integration, automated testing, continuous delivery, and continuous deployment when it is put into action. It is more it's more like a cultural approach, which means that the development and operations will work together. DevOps is not enough to provide security on its own. So there is SecDevOps, right? Which is what we need. And this term emphasizes that security is just as important to an organization as development and running its business. With SecDevOps, the people working on a project need to look at it from a wider perspective. Next concept is a waterfall approach. So for many years, the waterfall has been a mainstay of system development. And after the requirements phase, the customer has little to do with the process. In the early stage, this model needs a lot of detailed documentation. And at the start of the project, the customer is involved and will tell you what they want. The development team will write down what the customer wants, and the customer won't be involved again until the product is done and ready for customer acceptance testing. Software engineers will make the design based on the documentation they get from the customer. The next step is implementation or coding. And at this point, there's no chance for customer feedback, right? And during the verification, we will install, test, and fix bugs, and then we will do customer acceptance testing. If the customer is still not happy at this point, we have to start all over again, right? That's the waterfall approach. Now, what is agile, right? The agile method is based on getting a lot of help from customers. And not only is the customer involved in the requirements phase, it is thought that about 80% of all development programs in use today use this method. When the agile method is used, the whole project is broken up into small steps. And with the agile method, the customer will meet with the development team many times. The customer is involved in the project from the beginning and all the way through, and they can look over changes to software and ask for changes, which makes sure that the end result is just what the customer wants. So here the customer can check on the build's progress as new features are added. And since the customer has been involved in the project from the beginning, they're more likely to be happy with the software when it comes out. If the customer is not happy, we will write down the changes that need to be made and add them to a new development cycle. Next is spiral, right? So when there's already a model, the spiral model can be used. When neither the agile method nor the waterfall method works, we can use a mix of the two. A prototype needs to be made before this model can be used. As we go through several iterations, we're basically making a prototype better. We do a risk analysis at each stage. Here, we have made a prototype as good as it can be, and this will be the last version used to build up the final version. This makes it possible for the customer to be involved as each prototype is improved. And the last concept is versioning. So version control, right, is very important when thinking about CI/CD or continuous integration and continuous delivery. It's important to keep track of build changes and add them to the change management plan. When designing systems or software, it is important to follow a method. A process that can be done over and over again means that security won't be forgotten and we can take a systematic approach. It's also important to choose the right methodology so that the development team can work quickly and the customer is happy during the process and at the end. All right, let's go again to the case study. So here, I'd like you to review and explore the list of DevOps tools which can be found on this link below. Right, so as you will see here, it is actually a very good website, right, where you at least have a view on what tools are being used in DevOps, right? So you have Git, GitHub, and it's, let's say if you click on security, it will just show you whichever tools will be used for security, which is blue, right? For red, serverless pass, and so on and so forth. Okay, so at least after exploring this portal, at least you will have a view on what these DevOps tools are, right? Okay, so that's the end of the lesson. Here we spoke about baseline templates, software assurance, consideration of integrating enterprise applications, integrating security into the development life cycle. Okay, again, thank you very much for watching the video. Hello, welcome to our Module 1 Lesson 4 of our CASP Plus course. On this lesson, we're going to talk about the following topics: data loss prevention, data loss detection, data lifecycle, and data backup. All right, so an organization must store and handle data with care, right? Simple and complicated networks will store and access data. Data includes private information, IP or intellectual property, and trade secrets. Regulatory compliance and legal regulations must be considered when storing and handling data. Important data must be tagged and categorized. Data loss must be prevented using safeguards and gaps must be reported, right? Then we must plan how to handle data at every stage from creation to disposal. We also need to know how storing data with business to business or B2B partners and cloud providers works. and we must protect data addressed in transit and in use. Now let's talk about data loss prevention. Preventative controls must be put in place to avoid the leaking or exfiltration of sensitive information. There are a variety of ways to meet this mandate. Policy can be used to guarantee that the necessary data handling and operational procedures are followed. If we have a next generation firewall or a UTM or Unified Threat Management appliance, we can apply a DLP filters at network egress points. It's possible that your cloud service provider offers Cloud Access Security Broker or CASB, which safeguards your organization's data when users connect to the cloud. Microsoft Office 365 provides this level of security through the use of pre-built rules and templates. All right. Now, there are several ways to avoid data loss, right? First is remote desktop blocking. So this is important, and it requires careful study and adequate security controls due to the extensive use of VDI or virtual desktop infrastructure there. And remote assistance capabilities. We can restrict the use of this technology by implementing robust authentication and authorization. Controls should be developed to restrict session functionality if a remote desktop protocol or RDP, right? Let me put it here, is required to access a desktop for administration or business productivity. The following should be included in these safeguards. Next is the blocking external media. Controls for Windows Workstation, also known as GPO, right, or group policy or local policy, must be in place to prevent the local exfiltration of sensitive data. External storage on mobile devices can be blocked using Mobile Device Management or MDM. Okay? It's not possible to use group policy on non-Windows systems such as Mac OS, Linux, and Unix. Thus, constraints can be addressed using scripting or configuration files. Third one is sprint blocking. It's critical to be aware of alternative methods of stealing data from computer systems. Restrictions on screen captures and printing of private information are also necessary. Try taking a screenshot of the screen in your mobile banking app to see if you can get any useful information. This activity will be inaccessible to you. DRM or digital rights management, right? Can be used on sensitive documents to prevent illegal printing. All right, let's now talk about data loss detection. Data loss prevention solutions or DLP cannot always be implemented in their entirety due to the possibility of a determined inside threat actor finding a workaround. It's possible that the goal here is to locate the potential danger. There's are many ways that we can find out how the data was stolen from our company. First is watermarking, right? So here, documents can be checked out of an information system. However, an automatic watermark utilizing the identity of the user who checked out the document will be applied to the document if an organization wants to detect data theft or exfiltration. If the document is shared or printed, the user's identity will be clearly visible. It is also used to discourage the user from spreading protected content. Next is DRM, or Digital Rights Management. Copyrighted protected digital content is safeguarded via digital rights management. A wide range of digital media can benefit from this technique. Videos, photos, books, music, and software code are all examples. Most of the time, it gives the copyright holder some kind of control over how their work is published and the ability to charge a fee for that work. Next is network traffic decryption and deep packet inspection or DPI. Inspection of encrypted traffic may be necessary in particular situations. A popular implementation is a decryptor for the SSL or secure socket layer. Decrypting the outgoing packets enables a company to apply corporate DLP policies. Because our consumers don't want their employers monitoring their links to their personal bank accounts, we need to use caution while using this technology. One strategy to take into account is the whitelisting of URLs. And next is the network traffic analysis. One of the most common methods for detecting data leakage or exfiltration is to analyze data flows, both in terms of volume and content. Using this data, we can identify unusual user behavior, such as uploading a large amount of research data to cloud data networks or CDNs. Now let's talk about data lifecycle. So here, right, there must be a strategy in place to manage data throughout its life cycle, from the time it is created or captured to the time it is no longer needed. We can't ensure good data governance unless we know what data we have, why it's important, and how to manage it. The stages of the life cycle depicted in this illustration are explained in detail. First is the create, right? So to begin, data must be generated or captured. It can be anything from documents and images to maps and GPS coordinates. Next is a store. The data must be stored in appropriate systems such as file shares, websites, databases, graph stores, and among other things. Third is use. So we must ensure that data governance is applied once the data is stored in our information system. Classifying, safeguarding, and preserving data are all part of this process. Compliance with legal and regulatory requirement is a must. Fourth is archive. So in order to comply with legal and regulatory requirements, data should be preserved. And the last one is destroy. So regulatory and legal requirements dictate when and how data should be deleted. No business benefit can be gained by retaining unnecessary data. In the event of a lawsuit, we may be more vulnerable as a business if we store data for too long. A legal halt necessitates that a company make all relevant records available in connection with the lawsuit. All right, now let's talk about data backups. So due to the modern hybrid computing's complexity, data backups and subsequent restoration can be a difficult task. Is the data located on-premise or in the cloud? Data backup and recovery is the responsibility of whom? Legal and regulatory requirements, as well as operational requirements for the actual routines, we will implement and must be considered when making backup plans. Consider data retention policy, right, or DRP here, and business continuity planning or BCP, right, especially in terms of recovery point objectives, RPOs. To back up a directory to a cloud storage service, you may only pay a few cents a month per gigabyte. So there's actually a couple of types of backups, right? And this is actually very important. So here it can be incremental or differential backups, right? Which should be considered if working with limited time windows to complete daily full backups. So what's the difference between these three, right? First one is full backup. So every time you run a backup, it will create a new copy of everything in the backup set. In this case, the NAS array, NAS, right, or the network attached storage, could store 100 terabytes of information. Daily data backups could take a long time, especially when factoring in storage costs. Next is a differential backup, right here. A full backup and a differential backup are frequently used in tandem. On Friday, like for example, right, a full backup would be carried out as there is a lot of time available. Now, any changes made since Friday's full backup would be backed up differentially every day by the backup system. In other words, the backup on Saturday should be much quicker than the backup that you did from Friday because it's a full backup. Now, the third one is the incremental backup. So, In addition to a full backup, it is common practice to perform an incremental backup as well. It is recommended to run a full backup on days with large amounts of free time, such as Sunday, and any changes that occurred since the previous incremental backup would be backed up each day. In this way, the amount of data stored and the time it takes to perform an incremental backup are roughly equivalent. Okay, that's the end of the lesson. Let's go to the casework. So here, right, I put here a list of DLP vendors, right? So the in our casework, I'd like you to research and review the key differentiators of the following data loss prevention vendors, right? So why this is important, right? So there will come a time that you have to decide, right, which vendor are you going to use. Let's say if you want to put email security, of course you have to put a DLP feature there. So it's best to at least be familiar with the strengths and weaknesses of this DLP vendors if you're proposing one for your company. Okay? All right. That's the end of the lesson here. We spoke about data loss prevention, DLP, data loss detection, data lifecycle, and data backups. Thank you very much for watching the video. Hello, welcome to Module 1, Lesson 5 of our CASP Plus course. On this lesson, we're going to talk about the following topics like credential management, password policies, federation, access controls, protocols, and MFA or multi-factor authentication. Okay, so corporations often have to deal with extremely complicated environments, right? Internal users, internal services, and external service providers all need to be managed. Guest users and B2B relationships must take their customers into account. In hybrid environments, federation services can be used to ensure strong, centralized authentication and access control. The right protocols must be used to ensure secure authentication and authorization for all of these interactions with information systems. Now let's talk about credential management. An organization's credential management is very essential. Password security is an issue that must be taken into account in the daily operations and managing user credentials. Creating, storing, and disposing of passwords must be done securely. In the same way, they need to be handled with care at all times. In credential management, we have three, right? First is a SSO or a single sign-on. SSO aims to make it easier for users to access multiple services with a single login. This necessitates a high level of security, which makes it a good fit for MFA. The vulnerability of SSO is the theft of the account credentials itself. It's also critical to safeguard your account. SSO is a time saver for customers because this means that they only have to keep track of one set of IDs. Next is password repository application. SSO should be used as much as possible to achieve organizational goals. This makes a variety of different programs and services. Some online service providers don't support it, and it's possible to use a single account for SSO and require you to create a local account. So this goal isn't always possible. Using a local secure password repository, users can safely store their additional accounts and passwords. Third is the question between where are we going to put our password repository? Is it on-premise or the cloud, right? So hybrid cloud models pose a challenge to secure credential management as they become the new norm for businesses. It is up to you to decide whether or not to store passwords in the cloud. If you're considering a cloud provider, keep in mind that many of them will include advanced access control, behavioral analytics, and continuous validation. However, federation is often an option when accessing cloud-based services, and it's worth noting. Using Microsoft 365 services, All identities, including passwords, can be managed on premises, and federated access to cloud portals can be gained. All right, let's talk about password policies. Password policies must be enabled in order to ensure that users will change their passwords in accordance with the requirements of the organization. A minimum number of characters or a certain level of complexity can be specified for passwords. Use of different characters like uppercase, lowercase, numbers, special characters like at, sharp, exclamation point, and so on is enforced through password complexity. Additionally, keeping track of previous passwords is critical to prevent them from being reused by users. A lot of things have changed in the last few years. A two-factor authentication or MFA system is the preferred method of securing identities instead of requiring complex passwords. A simple long password has been shown to be far more secure than a long complex one. In the absence of a password policy, users may choose passwords that are too easy to guess. So the following are the password best practices, right? Of course, you have here complexity, password length, password history, password maximum age, password auditing, and reversible encryption. So in terms of password complexity, complexity is often a requirement, right, for passwords. And there are four character classes like uppercase, lowercase, numbers, special characters, or at least three of these will be needed. In terms of password length, the recommended minimum length for a password is 8, right? Any longer than this, and users will resort to bad practices, such as repeating the password. Password history. So password history is critical. Without password history, compromised accounts can be reset to the original password, allowing the attackers to gain access to the account once again. Password maximum and minimum age. A password minimum age is critical, as users may reset their password multiple times in an attempt to reclaim their original password if one is not in place. However, using a password with an age restriction is no longer a good idea. Requiring frequent password changes, it's often done right, like 30 to 60 or 90 days, can lead to users picking a weak password by merely adding a sequential number and at the end of their old password. There are many passwords that can be hacked because of poor choices. It is also important to keep in mind that a compromised password can be exploited right away. Next is password auditing. In order to identify weak passwords, password auditing is critical. When a user resets their password, it is possible to perform password verification. We can generate hashes from a dictionary word list and see if any of the users are using passwords that are too easy to guess. And last is reversible encryption. So a database of passwords should be kept in a safe format, and prior to being entered into the database, they are typically hashed. Passwords can be stored in plain text with encryption that can be broken with the password. Some older programs still make use of this, right? Perhaps a remote access management solution, and this must never be used. So Microsoft RAS or Remote Access Service is an example of this. This enables what we call as CHAP or the Challenge Handshake Authentication Protocol to be used to authenticate users. All right, let's now move on to federation. So what is it? So identity federation is a technology that lets you share your identity with a variety of different organizations. SaaS, or Software as a Service, is a popular choice for many businesses. SSO can now be used both within the user's own organization and to access applications hosted by third parties. One identification is that all the users need to keep in mind, right? Typically, an identity federation service generates a token and securely transmits it to the third party. When an enterprise user logs into a third-party site, they can utilize their credentials from their company's ADFS or Active Directory Federation services. Assertion markup language or SAML, right, is among the protocols supported by these devices. All right. So in terms of federation, we have a couple of types here, right? First is the transitive trust. So transparency is a valuable asset in today's high-stakes business world. Domains and Kerberos realms can be created when utilizing directory services to set security boundaries. It's usual practice to set up geographic barriers to keep the accounts of different departments distinct. Next is OpenID. OpenID is a standard supported by cloud-based identity providers such as Google, Facebook, and Twitter. RPs are relying parties who support this standard commonly used to access third-party services. The OpenID Foundation is a nonprofit organization that oversees the current standard. Version 2.0, and once an OpenID provider has verified an individual's identity, a JavaScript notation web token is generated and sent to the service provider requesting it. Next is SAML. SAML is an open standard that is commonly used to cloud-based business portals and the applications contained inside. An IDP is required. Directory services are often used internally by the IDP, and the service provider is the cloud organization. An IDP-generated secure token is required by the service provider. SSO, or single sign-on, is another benefit that makes the user experience more transparent. Microsoft 365 services can verify identities using SAML. And next is Shibboleth. SAML and Shibboleth are closely related. Colleges and universities, on the other hand, are the primary users. Passing a token to the service provider permits SSO, but an IDP is required. Here, we can grant users access to resources once their identities have been verified. Okay, let's now talk about access controls. So once a user has been authenticated, access control can be used to control the user's permissions. There could be a variety of criteria, such as the necessity for engineers to be able to exchange code. When sensitive papers need to be accessed, rigorous access controls may be necessary. Administrators may need special privileges and rights or fine-grained access based on the account holder's location or country of origin, or may be required. Okay, let's dig into these options in more detail on the next few slides. First is the mandatory access control. From the perspective of others, MAC is the most secure method of managing asset access. It necessitates a certain amount of clearance. It necessitates the classification of labeling of data. Although it is time consuming, it provides the highest level of protection. This method is often used by government agencies such as the Department of Defense. Next is DAC, or the Discretionary Access Control. So DAC signifies that the resource owner is in charge of determining who has access to it. In the Windows NTFS file system, the owner of a file or folder can grant other users or groups access to the file or folder. Decentralization is possible as a result of this. A SharePoint portal would be another excellent illustration. While a team leader has full control over the site, they can then grant access to their coworkers. Next is what we call as RBAC, role-based access control. So here it is possible to apply role-based access control with existing roles, such as administrators, network configuration operators, and backup operators, as well as business units such as sales, marketing, and production. Centralized role-based access control. There must be a single point of contact for all administrative tasks. Next is rule-based access control. Because certain departments may need that all of their employees work only during specific hours or from only specific workstations, rule-based access control is an excellent solution to those situations. And the last one is the attributed based access control. So this access control is based on attributes and allows for even more fine-grained control. Directory services are also a good fit for it. Attributes can be linked to objects such as employees, department, or even a nation's location. For example, using these characteristics, a resource's accessibility could be fine-tuned. All right, now let's talk about security protocols. So here, a company that has a wide variety of protocols for authentication and authorization. Logging onto the domain through directory services is the most popular method. This could use Kerberos as an SSO protocol. When that isn't an option, we'll have to turn elsewhere for solutions. Now, the new zero trust approach for network security could be an example of remote access. We're going to look into these protocols in the next few slides. First is Radius. So routing and remote access protocols such as Radius are pretty much widely supported. There are several uses for this, such as granting remote access to VPN or whatever else is required. A switch that complies with IEEE 802.1x can also be accessed using Radius. You can also use this to get into the wireless access point. Radius clients, right, or the device connected to the network, can use AAA to send authentication requests to the AAA server for processing. As Radius may not really hold the user account database, the server may commonly return this request to a directory services server. Port numbers and networking protocols are supported by Radius. Next is TACACS. So on Unix networks, TACACS is a common authentication method for users. TACACS Plus is the most recent iteration, which it was created by Cisco. This is completely incompatible with previous versions of the app. It is similar to Radius but lacks the widespread support of Radius. In addition to being more secure since it encrypts the entire authentication process, TCP ports for AAA are more dependable, and it uses TCP port number 49. Next is LDAP. LDAP, right? So here, directory services can be accessed via the LDAP standard. Directory Access Protocol was chosen as an alternative since it is simpler. Access to directory services and production of directory services content, such as user and computer accounts, is provided through LDAP. As a directory service administrator, it is most commonly employed. RFC 4511 lays out the details. Here, we also use port 3889 to be used for routine LDAP access. So instead, the transport layer security is an option to consider TLS. TCP port 636 is used to encrypt the connection, right, for LDAP. For this Kerberos, in the United States, export limitations prevent the use of Kerberos, a safe single sign-on system created by the Massachusetts Institute of Technology, or MIT. A number of RFCs have been allocated to this by the IETF to define the implementation. Red Hat, Oracle, and IBM are among the many company or operating system vendors that support Kerberos. Microsoft Active Directory has relied on it for more than 2 decades, I think. And using Kerberos, you can communicate securely and prevent replays. Kerberos is a time-consuming service, and otherwise, Kerberos authentication will fail due to an out-of-sync clock environment. And the fifth one is 802.1x. So that 1x, as it's commonly called, is a standard Ethernet protocol. Port-based access control is described here, right, or PBAC. The switch, the remote access VPN, and the wireless access point protocols all support this method of device or user authentication through a network connection. It's simple to set up with PKI certificates, which are widely available. It is possible to issue certificates to a variety of devices, such as laptops, mobile devices, and Internet of Things, sensors, and printers. Secure connections to networks can be made using many different types of devices without the requirement for actual credentials to be entered. All right, here's the last topic, which is MFA, or multi-factor authentication. So for many businesses, multi-factor authentication is becoming a significant concern because passwords alone are no longer deemed safe enough. MFA has been recommended by the UK's National Cybersecurity Centre, or NCSC, as a defense against hacked passwords. Using Microsoft Cloud Service requires the use of MFA. Smart cards can now be used with Active Directory accounts because Microsoft automatically supports the use of these devices. Apps for mobile authenticators are available from a wide range of third-party sources. Right? After that, we're going to look into a few of these alternatives. All right, first is 2FA. 2FA, two-factor authentication, refers to the practice of authenticating a user by utilizing two different techniques or factors. You need to take into account two separate aspects. An identifier is allocated to each factor, right? And there are actually 5 factors from type 1 to type 5. It's possible that you logged in from a new location or from a device from which you've never checked in before, and this could prompt additional authentication. Right? That's the 2FA. Next is two-step verification. Many online IDPs offer two-step verification. Think about the first time you connected to Google from a new workstation, right? So in the Google app on your smartphone, you'd get the push notification. The usage of a second channel is highly recommended while performing two-step verification. Suppose a scammer obtained a victim's login credentials through phishing, and they have to take over the user's smartphone or some other devices as well. Next is in-band authentication. The term in-band authentication refers to the use of a single channel, such as your internet browser, to perform all of the authentication checks. In comparison to other systems, this could be deemed subpar. A CSRF, XSRF attack, right, or cross-site scripting attack, is a serious threat when authentication is performed in-band. In this scenario, you are logged into your bank's website using your username and password, and this could be done through the use of a malicious script. Next is out-of-band authentication. As an alternative, you would have to utilize a secondary channel, such as your smartphone, to authenticate your identity when logging into your bank account or when logging into a Google account. You'll receive an authorization request from your bank by OOBA, which is designed to prevent fraud. Next is one-time password. OTPs are one-time passwords that are generated for you and require you to input a strong password in order to proceed. One-time passwords can be HMAC-based OTP or time-based OTP. And last one is hardware root of trust. So using a hardware root of trust provides a safe place to store your data. So here we're talking about TPMs, right? TPM, or the Trusted Platform Module, which is an excellent example of a hardware implementation of a security module. These values can be used for secure boot because we can verify the information contained in that container. The encryption keys for BitLocker drive encryption can be kept in this location for safekeeping, allowing us to safely encrypt and decrypt hard drives. Okay, that's the end of the lesson. Here we spoke about credential management, password policies, federation, access control, protocols, and multi-factor authentication. Thank you very much for watching the video. Hello, welcome to our Module 1, Lesson 5 of our CASP Plus course. On this lesson, we're going to talk about the following, such as virtualization strategies, cloud deployment models, hosting models, service models, and storage models. All right, so with virtualization, right, the underlying hardware can be completely abstracted from the program that uses it. So using just a thin layer of code, it controls access to all of the system's resources such as networking, CPU, storage, and memory. It's possible to operate a virtual machine on top of a software layer for almost any type of computing node. It's known as the hypervisor. Virtual machines include user desktops, email servers, directory servers, switches, firewalls, and routers. With virtualization, the data center may be more flexible, faster to deploy, and expandable as workload grows. As an added bonus, a company's data center footprint is minimized, such as less hardware or reduced power, and so on. So in virtualization strategies, we have what we call as a hypervisor. A hypervisor, right? It's actually in here. Is a layer of software or hardware that allows multiple operating systems to run on the same machine without interfering with each other. There are two types of hypervisor. First is type 1, and the other one is type 2. So what's the difference? For type 1 hypervisors, native hypervisors are software that runs on hardware platforms. The guest operating system is layered on top of the hardware on a separate layer. To run non-sensitive instructions at full speed, these hardware-bound virtual machine emulators rely on the real underlying CPU to run at full speed. Guest operating systems can be run on virtual servers or virtual hardware that looks and feels almost identical to the physical hardware that they're actually running on, and that's thanks to a hardware virtualization. Because the virtualized operating system has no idea it is being virtualized, no changes are necessary. Operating systems instructions are related and cached on the fly by the hypervisor, while user-level instructions run at their original speed. As an example for Type 1 hypervisor, we have VMware ESXi and Citrix Send Server. Now, what is a Type 2 hypervisor? A Type 2 hypervisor, also known as a hosted hypervisor, here, right, is a software that runs in an operating system environment, here, where the guest operating system runs at the third level above the hardware. An operating system that is already running can be used to run a Type 2 hypervisor. As a result, operating systems running on the hypervisor are referred to as guest or virtual machines. Rather than using hardware, this type of virtual machine is entirely software-based. A virtual machine emulator will be one of the applications that can be launched by the host after it has booted to completion. Examples of Type 2 hypervisors are VirtualBox and Microsoft Virtual PC. So what are the security considerations for virtualization? When an attacker bypasses the hypervisor by means of a guest operating system, this exploit is known as VM escape. This threat is so serious that vendors such as VMware and Microsoft are willing to pay a lot of or hundreds of thousands of dollars to bounty hunters if they can come up with a viable model. Although compromised hypervisor exploits have occurred in the past, this is not a common type of attack. There's a specific CVE 2008-0923. It was released in 2008, and VMware Workstation 6.02 and 5.5.4 are vulnerable to VM escape from the virtual machines. Now let's talk about the following VMware technologies, right, as you see here. The first are containers. Come on. Hold on. Yep. Okay. First are containers, right? So here, workloads can be deployed in the data center more efficiently using containers. All of the application's binary files and library dependencies are contained in a single package called a container. A container-based application's bugs or errors won't affect any other applications because it is isolated from the host operating system. Containers provide a means of separating and encapsulating different programs. So container security must be taken into account. We must ensure that our containers are isolated from those of other customers if we're utilizing a cloud platform. Deployment and migration are simplified and thanks to containers, right? Which can run to a variety of operating systems and hardware. Because they don't need to run on a virtual machine, they have very low overhead. Now is emulation. So it is possible to run programs, right, and services that would not otherwise be supported on a given platform by means of emulation. Using an emulator to run old arcade games on a modern computer is one example, like this one, right? Instead of connecting a serial cable directly from a terminal to a network appliance, terminal emulators can be used to remotely access another device. If you have a desktop computer, you can run Linux commands by emulating the shell of the Linux command line in the Windows. Next is application virtualization. So using application virtualization, you can support multiple platforms with a single line of business or LOB or legacy application. It is possible to host multiple RDP sessions to a single application that is published on Microsoft RDP services or Microsoft servers. Using a server farm, we could expand to an enterprise, and using this model, we could, for example, run Windows applications on a Linux host. The application can also be streamed across the network and run locally. AppV is the Microsoft name for this technology, while CNAP is the Citrix name for a similar one. Fourth one is VDI, or Virtual Desktop Infrastructure, and it enables the control of compute resources from within a data center or cloud. This is a typical scenario, like an employee logs on to the company desktop via a basic 10 client and runs all of the necessary applications. Now, any device that can run the remote software can be used by the user to access their desktop. Most operating systems can run the Microsoft RDP client. The advantages of this approach include stability, security, and speed of deployment. All right, now let's talk about cloud deployment models. Um, so here, right, cloud computing can be further divided into types as based on service models deployed. Cloud technology is deployed and consumed in a variety of ways, including private, right, public, hybrid, and community cloud. So what are these and what are the differences? So let's focus first on the private cloud. This refers to a hosted infrastructure in a private platform and is referred to as a private cloud. Internal, corporate, or enterprise cloud are some of the terms used to describe it. A private cloud allows organizations to have more control over their infrastructure and is typically only available to employees and business partners. A private cloud or a public cloud provides the ability to add new applications and services on demand. So here, an organization can better manage its data with the private cloud design because the flexibility in the design specifications, better performance, and easier access to compliance data that come with a private cloud, right? And here, building capacity limitations and higher infrastructure, maintenance, and administration costs are some of the drawbacks of a private cloud. Private clouds are ideal for companies that need to maintain strict control over sensitive data, such as those in the financial sector. Right? So that's the private cloud. Now, what are public clouds? So here, right? For a monthly or yearly fee, users can access services and infrastructure hosted at an offsite facility of a service provider via the internet. It is common for multiple organizations to share a common infrastructure, but their data is logically separated from that of other organizations. Lower infrastructure, maintenance, and administrative costs, greater hardware efficiency, faster implementation, and the availability of short-term use are all advantages of using a public cloud. Now, reduced bandwidth and less control over data and the environment are all the drawbacks of a public cloud. The downsides of a public cloud include increased vulnerability, right? Because the data transfer capability is limited to that of the internet service provider. When an organization needs scalability and wants to cut costs, and they doesn't have any in-house administrative staff or has high maintenance distributed network, a public cloud is the best option. All right, so we covered public and private. Now we talk about community cloud. So in order to meet the needs of a specific group of businesses, a community cloud was created. It is common for community clouds to be industry specific, such as in healthcare, energy, or government. Using a hybrid cloud, community clouds allow businesses to collaborate in a cloud environment while ensuring a high level of security. To increase across organizational or collaborative processes in the event that in-house implementation is not possible due to conditions such as geographically distributed participants or fluctuating resource requirements, organizations should use the community cloud. Google's use of Google Apps for government agencies is an example of a community cloud. All right, and the fourth one is hybrid cloud. A hybrid cloud is made up of both public and private on-premises infrastructure that is managed by the end users themselves. Data is kept safe in a private cloud while public clouds handle the rest. This strategy enables a company to take advantage of the positive aspects of both work environments. So when a company services needs to be tailored to different vertical markets or have varying needs, a hybrid cloud environment is the best option. Public cloud migrations benefit greatly from the interoperability and scalability that hybrid clouds provide as well. Gateway services make it simple to implement a hybrid cloud approach. Okay, now let's move on to the next topic, which is about hosting models. So as you may know, right, wealthy individuals can afford to live in a gated community with their own personal security team. A gated community might be an option if you don't have that kind of money, right? So think about community cloud. To save money on housing, consider renting an apartment within a building where you can use the common stairwells and elevators. And there are, however, other choices. So in public cloud, if you pay the cheapest price possible, you're more than likely going to use a multi-tenant model. So on the same hypervisor as other customers, your web servers will be running as a virtual machine. Now, if your database is hosted on the same server as other customers using the same schema, you may be able to share resources, right? And even though single-tenant cloud services are widely available, they're often expensive. Customers can use their own hardware to host their own services on top of the provider's public cloud, and because of this, you can bet they're going to raise the price. Okay, now let's talk about the service models. So the concept of cloud computing can be traced back to the concept of mainframe computing, where multiple users were given a small slices of computers' time to run whatever program they need at the time. In today's world, cloud computing providers typically provide computing resources like computing power, storage, and common applications to customers via the internet, via a web browser or portal. It is a combination of virtualization, distributed computing, and widespread high-speed bandwidth and makes cloud computing what it is. So when it comes to cloud computing, right, the deployment and service models are both used in the layered architecture of the cloud infrastructure. So there's what we call as the, of course, traditional. This is what we know. Then we have IaaS, PaaS, and SaaS, right? These are the three well-known types of cloud-hosted services. So what's the difference, right? So for first one is IaaS. So ID infrastructure as a service is delivered via the internet as part of the cloud-based hosting model. This cloud computing method allows the customers to outsource everything normally found in a typical IT environment. This includes software, servers, DC space, and network equipment. And IaaS is billed based on how much you use, just like electricity and water. As a result, it falls into the utility computing category. Hardware virtualization and internet connectivity are common features of an IaaS or an infrastructure as a service. If you'll see here, right, this means that the cloud service provider will manage this area, the hypervisor, the server, storage, and physical network. However, on top, this will be on the responsibility of the customer. Now, let's move on to the next one, okay, which is PaaS, Platform as a Service. So here, no software must be downloaded or installed in order to use the platform as a service. PaaS systems are often cloud-based development platforms, so developers don't have to worry about servers when using them. PaaS has a distinct advantage in that it enables rapid application development for a large audience. An integrated environment, interface creation tools, and web and database integration are all common features in PaaS solutions that are commonly used. Facebook is a good example of a PaaS because developers can create applications for Facebook using the APIs and tools provided by Facebook. If you look at this illustration, right, so we're actually increasing the scope of the CSP or the cloud service provider up to this portion, up to the middleware. But the data, application, the runtime, this will be still on the responsibility of the customer. Third is SaaS, right? SaaS is a subscription model for software. Clients can access licensed software via the internet and pay as they go for it as a service. To use the online service, all that is required is a web browser and an internet connection. IaaS is used to build the majority of SaaS solutions. A SaaS provider hosts an application and makes it available to customers for a predetermined period of time, after which the application becomes inactive unless a subscription is renewed. Using the SaaS model, individuals and organizations can access a certain application without having to purchase a full license. There are no upfront costs or ongoing maintenance costs associated with this on-demand licensing environment, unlike traditional software purchases. So if you look at this illustration, right, okay, there's more responsibility with the CSP up to the application, but still the data, of course, will be provided or managed by the customer. All right, let's go to the last topic, which is the storage model. Right? Storage models. So the amount of heterogeneous data that an enterprise generates and manages is expected to grow over time. A variety of data will be needed by the finance, marketing, and transportation departments, as well as the company's board of directors, in order to make informed decisions. Because of the wide variety of data types, relying on a single data store is the best choice. So a more efficient way to store data is by spreading or separating it into separate databases tailored to different workloads or usage patterns. As a result, it's important to know the main storage models and their advantages and disadvantages. First one are the file-based storage. So in the traditional client-server model, these files are used to store data. So user map drives can access shared folders on a NAS device or a file server, for example. A hypervisor platform could host VMs of other file types. Next is database storage. So here, two-dimensional tables with rows and columns make up a database, which is referred to as relational database. In order to retrieve and manage data, many vendors make use of SQL, or structured query language. That way, no record is added or updated until it has been verified, ensuring the integrity of the data, right? Now, RDBMS, Relational Database Management Systems, require a schema, which is a list of permitted objects and attributes that can be used in the system. The schema must be used for all read and write operations. Examples of our relational databases include Microsoft SQL, MySQL, and PostgreSQL. Next are block storage. So using block storage, you can organize your data into blocks of a specific size. There will only be a sliver of the data stored in each block. On a SAN iSCSI or fiber channel, this is typically used. Requests are made to find the correct location of the blocks, and the blocks are assembled to form the complete file. Metadata is not stored with the blocks in block storage. Its primary advantage is speed, but this can only be achieved if the application and storage are both locally installed, ideally on a SAN. If the application and the blocks are too far apart, the performance will be negatively impacted. Database applications commonly make use of this type of storage. Next is blob storage. So large binary objects are well suited to objects storage strengths like image files, video, audio streams, large application data, objects and documents, and virtual machine disk images. Metadata tags can be linked to a file in order to improve searching through these repositories. Now, it's possible that this can be customized by the user, like searching through the raw data of a video image would be difficult. It is ideal for large files and data stores because they are very, very scalable. And last one is the key value pairs, right? So in order to store identifiers and values, the use of key value pairs is highly recommended. A rainbow table or any other kind of lookup table can benefit from the storage type. If you're doing a compliance scan, this could come in handy. The database could have a series of identifiers and the actual value that it is expecting to be set in the database. Okay, that's the end of the lesson. Here we spoke about the following: virtualization strategies, cloud deployment models, hosting models, service models, and storage models. Again, thank you very much for watching the video. Hello, welcome to Module 1, Lesson 7 of our CASP Plus course. On this lesson, we're going to cover the following, such as cryptography and PKI. So, DID, right, or defense in depth, is a method for securing corporate networks. Defense in depth includes safeguarding data in all three of its lifecycle stages, like in memory, in transit, and in use. To maintain data confidentiality, we can encrypt it using a variety of methods. We need to be able to use hashing and signing to check the data's integrity in some situation. It can be difficult for IT professionals to grasp the complexity of our cryptography, which relies on mathematical ciphers. IT professionals and management have the responsibility to ensure that the proper standards and protocols are enabled by asking the right questions. The use of cryptographic ciphers to protect data stored, processed, and transmitted by an enterprise may be subject to stringent regulatory requirement. It is the responsibility of security professionals to ensure that the appropriate technology is configured and deployed. So the first topic is a hashing algorithm. Data integrity validation is the primary use of hashing algorithms, but they can also be used to prove that you know a secret, right? Such as a password. Password A hash cannot be reversed and does not provide data confidentiality. Hashing is actually a one-way process. That the original data has not been altered in any way is critical. Hashing is the process of creating a unique digital checksum for each document, file, or data payload that is sent over the internet. If a protected operating system file has been altered, we can use hashing, right, to um, find about it, right, or FIM, the file integrity monitoring. In digital forensics, a copy images checksum can be hashed to create a unique checksum that can be compared to the original, right? And this is useful to do before analysts begin the forensic investigation. For security professionals, it is critical to know the difference between strong and weak hashing algorithms. So there's actually three, right? The first one is SHA, or the secure hashing algorithm. Most businesses and government agencies adhere to the SHA standard. In cryptography, the SHA-1 hash function produces a 40-byte output with a fixed key length of 160 bits or characters. When most cryptographic packages stopped supporting SHA-1 around 2010, it was considered obsolete. SHA covers the following hash functions like SHA-224, 256, 384, and 512. Next one is HMAC, or hash-based message authentication code. An authentication and integrity check can be performed on a packet using HMAC. A hash function and a secret key known only to the sender and the recipient will be used. An HMAC can be generated and verified on the receiving host. It is important to note that an HMAC does not encrypt the payload, instead it authenticates the packets. For non-repudiation, you need a digital signature, and this does not. Third one is MD, or the message digest. Ronald Rivest developed the MD2 hash function in 1989, which was originally published as MD2. MD5 was the culmination of a series of updates. It was widely used up until about 2008 before it fell out of favor. Hash collisions are now included in the list of possible exploits, and this happens when two distinct inputs provide the same hash value. Like, for example, an attacker could replace a legitimate document with a modified version that has the same output hash. Now let's talk about symmetric encryption algorithms. Symmetric encryption gives privacy by encrypting large amounts of data at once. It is very good at encrypting both data at rest and data that is moving. Because the key sizes are not too big, it is very fast, right, compared to asymmetric encryption. Symmetric encryption uses the same key to lock and unlock the data. The block ciphers and stream ciphers are two main types of symmetric algorithms. So for block ciphers, right, with this kind of ciphers, data is encrypted in 64-bit or 128-bit blocks. Stream ciphers are faster, but they don't offer the same level of security as block ciphers. So what are the types of block ciphers? So we have 3DES. We also have AES. Okay, there you go. Now, what about stream ciphers? Stream ciphers works best for traffic that happens in real time. They are fast and they make fewer mistakes because they handle data as stream of bits. RC4 used to be the standard for stream ciphers, but it is no longer thought to be safe and has been taken out from widespread use since 2015. The well-known stream ciphers of the 21st centuries are ChaCha, so CHA, Salsa 20, and Salsa 20. Okay, there, two. Now let's talk about asymmetric encryption algorithms. Asymmetric encryption is designed to support secure key exchange and agreement, as well as non-repudiation through digital signature. It is not used to encrypt large amounts of data because compared to symmetric encryption, the key sizes are just too big. This would mean that encrypting a lot of data could take thousands of times longer. Now, in asymmetric encryption, there is a public key and a private key that are related mathematically. The public key is like your bank account, right? That you can give to a customer who wants to make a payment. Then your private key is used to get to your money in a safe way. In this case, the private key could be your bank card, the PIN, or the CVC code, right? And you wouldn't give anyone your private key, okay? So there's a couple of types of asymmetric encryption algorithms. The first one is RSA, the Rivest, Shamir, and Adelman. RSA is used to exchange keys and make digital signatures in a safe way. It was made and published in the 70s and making it one of the oldest asymmetric algorithms. It comprises of a public key and a private key that are related mathematically. You can share your public key, but you must protect your private key. The typical size of an RSA key is between 2048 and 4096 bits, but more stringent security standards call for keys within the 3072 bits. Next is the DSA, or the Digital Signature Algorithm. So DSA is a standard for digital signatures set by the government. Digital signatures are used to prove that you are the owner of a document when you send it by email or to verify a certificate that is hosted on a website. Third is DH, or Diffie-Hellman. DH is a protocol for agreeing on a key that is usually used to trade a secret or session key for IPsec or SSL TLS. It's not used to trade keys, but it does let two people make their own secret session keys. This is helpful because it means that the session key was never sent, and this means that any MITM attack would fail. ECC, or the elliptic curve cryptography. So using algebraic equations to draw an eclipse or an ellipse, ECC makes it possible to make key pairs. Keys can be made by, putting points on this ellipse, and this is a simple description of a complex mathematical process. The key agreements and digital signatures both use ECC. ECC's strength is that it works well with low power devices. With ECC, a key size of 256 bits is the same as a key size of about 2048 bits with RSA. All right, let's now talk about encryption protocols. So hashing, symmetric encryption, and asymmetric encryption are all building blocks that help applications and protocols that need to store and send data securely. Using the strengths of the different types of encryption, a cipher suite is used in many processes, right? And we rely on these protocols to keep users safe when they use online banking or work from home. They also keep information systems safe when they need to be managed across the network and make sure the emails sent and received can be trusted. So in the next few slides, we'll look at some of these common protocols. First is SSL TLS, right? And it's used to encrypt many application layer protocols like HTTP, SMTP, IMAP, LDAP, and many more. It gives privacy, right, through encryption, and reliability through HMAC. It uses a set of protocols that make use of a hybrid cryptography. As you may know, SSL isn't used anymore because it isn't safe. However, TLS 1.2 and TLS 1.3 are now the standards. Next is S/MIME, right? This is the standard for email and lets people use the same protocol. This lets users choose an email client so the enterprise can run an SMTP server from any vendor. We can protect emails from one inbox to the next by encrypting the payload with the public key of the recipient and the session key. The message can be read by anyone who has the recipient's private key. Next is IPsec, right? So for VPN or virtual private networks, IPsec is a mechanism for encrypting data in transit. Site-to-site links can be protected with this, as can mobile users access to the corporate network. Hashing, such as HMAC, will be used for bulk encryption, while symmetric and asymmetric encryption will be used for secure key exchange. Next is SSH. SSH is secure shell for administering servers and equipment. As a result, SSH uses a type of encryption known as hybrid encryption. PuTTY is a popular tool for securely connecting to a remote computer. In order to connect to an SSH server, PuTTY must be configured, right? PuTTY must be configured. Next is password salting. A password can be protected against offline attacks using tables and brute force techniques by using this method. It is possible to generate a pseudo-random sequence of characters when the password string and salt are hashed together, and the salt is added in. All right, now let's talk about PKI, specifically PKI hierarchy. So PKI, or public key infrastructure, is very important for any company size. PKI gives an organization the tools it needs to check the keys that will be used to secure the data and prove who they are. So without PKI, we cannot use encryption keys because we can't be sure that the keys are real. When the key pair is made, we need to give the unique public key a trustworthy certificate that has been signed, just like a passport is made for a trustworthy citizen. Without PKI, we can't be sure that we can use online banking, e-commerce, smart cards, or virtual private networks. It is important to know how the whole process works and where the problems might arise that may need to be dealt with using problem-solving skills. So what's a certificate authority? A CA, or a certificate authority, is made up of an application server that runs a service called certificate services, which is just like a daemon on Linux or Unix. So CAs can have more than one level, but there will always be a root CA. Most of the time, there will be at least one more layer. This is called the intermediate or subordinate CA. Most of the time, the root CA will be kept in a safe place, often by itself or air-gapped, and the root CA only needs to be turned on and ready to sign requests from intermediate CAs. For safety, a business may have more than one issuing CA. The issuing CA must be powered on and ready to sign the client CSR, and it will need to be highly available. A standard is used to make certificates, right? And the current standard is the X509.v3, which says how a digital certificate should look and what information it should have. Okay, that's the CA, the Certificate Authority. Next is a registration authority. So when a request comes in from a client entity, it is checked against policies to see if it will be approved. Verification checks must be done before a certificate that verifies a domain name or other identities can be given out. The registration authority's job is similar to that of an auditor. So if you wanted to get a passport, you would have to prove who you are. If you didn't, someone could steal your identity. In the PKI hierarchy, the passport would be the digital certificate, and the RA would be the government agency or department that issues the passports. Next is the certification revocation list or CRL, right? It refers to a list of certificates that should no longer be used for or trusted. It is made public by the CA or the Certificate Authority. If a certificate is given a 1-year expiration date and a key is stolen during that time, the CA can revoke the certificate and put the status on the list that anyone can see. Certificates can be taken away for a number of reasons, such as the end of a business, a change in affiliation, or the loss of a key, and there are more options here. Next is what we call as OCSP, or the Online Certificate Standard Protocol, and it has become the standard way to respond quickly to a client's request for revoked certificates. This is so that clients can get answer faster. If a client only has a CRL, it needs to connect to the CA CRL server and get the most recent CRL entries. If the CRL network isn't available or if it goes down for a short time, a client can check the status of a public key certificate. With OCSP, however, the OCSP service can cache results and answer clients' requests even when the CRL is temporarily offline. The OCSP is also much easier to use because it only needs to check the serial number of the public key certificate. Once the PKI hierarchy is set up, we will need to give certificates for many different purposes. Okay, here's the last lesson here, right? We're going to talk about certificates. So when signing up for certificates, large businesses have very specific needs. Sometimes the goal is to make it easy to manage or to be able to add more sites to an e-commerce operation. Customers may sometimes need a peace of mind that comes with highly trusted certificates. Here are a few types of certificates that are often used. Wildcard certificate, right? So with this, an organization can use a single pair to host multiple websites with a single certificate. Depending on how many sites you host, there may be restrictions or extra cost. All of the sites here, or all of the sites that the wildcard certificate covers, must use the same DNS or domain name, right? Only the host name can be different for each site. Next is extended validation. An extended validation certificate is a type of certificate that gives a high level of assurance. It is mostly used by banks and other financial institutions. Customers will be able to tell that a site has an extended validation certificate by looking for a sign on their web browser. Sites that sign up for extended validation certificates get extra security services and help from the CA, like vulnerability scans. Next is a multi-domain. A multi-domain certificate is right for an organization that needs to support more than one domain within a single certificate or with a single certificate. This certificate is different from a wildcard certificate because it lets a site have multiple subdomains, domains, and host names. Next are general purpose certificates. So here, a user could be given a certificate that could be used more than one case. A user may need to sign and encrypt email, log into their AD or Active Directory services account, and use secure VPN access. We could cut down on administrative work by giving each user a single certificate. And the last one is the certificate usage and templates. So it is important to make sure that the CA has the right templates enabled so that the user request can be met for all the applications that are being used or planned. The following are common types of templates like client authentication, server authentication, digital signatures, code signing, and general purpose. Okay? All right. That's the end of the lesson. Here we spoke about cryptography. We spoke about hashing algorithms, encryption protocol. And we also spoke about PKI, public key infrastructure, covering PKI hierarchy and certificates. Okay? Thank you very much for watching the video. Hello, welcome to lesson module 1, lesson 8 of our CASP Plus course. In this lesson, we're going to talk about the following, such as artificial intelligence and machine learning, quantum computing, blockchain, big data, 3D printing, homomorphic encryption, and biometric impersonation. So let me provide you like a quick intro about this lesson. So here, right, organizations that want to maintain a strong security posture must be open to implementing new technologies and have a thorough understanding of the threats these technologies pose. Increasing computational power may allow hackers to access data secured by inadequate encryption techniques. Innovations in cybersecurity will be possible because of advances in technology. Now, we're going to talk about these emerging technologies in the next few slides. All right, regarding AI and ML, right? Machine learning. So humans have been captivated by AI and machine learning for decades. In anticipation of the day when intelligent robots can perform the dirty job and learn alongside humans, we've been thinking of ways to communicate with computers from the first time we saw the concept in comic books. Robots are now capable of doing ever increasingly specialized tasks. Intelligent network security, or the intelligent network, is one of the interesting areas where AI and machine learning are paying benefits. To prevent attacks, these networks look for their own vulnerabilities before attackers do. The first end-to-end system for fully automatic exploit generation is called Automatic Exploit Generation, or AEG. AEG can find a problem and determine if it can be exploited in off-the-shelf and enterprise software widely utilized in smart devices and appliances. Now let's talk about quantum computing. So in the future, quantum computers will be able to handle complicated problems more quickly than current supercomputers, well, according to its creators. The typical processing power of compute nodes with thousands of CPUs and GPU cores is harnessed by supercomputers. Quantum computing may be able to solve a problem hundreds of times quicker than current computer models. Zeros and ones are processed and generated by a conventional computer, which is a sound approach that may be used to tackle a wide range of computational issues. Now, consider the case of a freight firm tasked with delivering items to 10 distinct clients. A total of 10 trucks and 10 routes are available, and each customer has a set payload to be delivered to the location. Optimizing the usage of vehicles, fuel, and routes may have more than 3 million solutions. Quantum computing and effective methods for harnessing this technology pose a significant cybersecurity risk. Currently, Google has a quantum computer, as you see here, with the 50 qubits of processing power. So qubits is described as a quantum bits. A single qubit can represent multiple states. Cryptographic keys currently in use are anticipated to require roughly 20 million qubits to break. Okay, now let's talk about blockchain. So a public peer-to-peer network underpins a secure digital ledger known as a blockchain. To ensure the integrity and authenticity of data, a blockchain is utilized. The hash of a new block is calculated and added to the chain of blocks. Hash calculations for the first block are known to as the genesis block because there's no preceding block. A majority of nodes in a peer-to-peer network must agree to the new transactions before they may be acknowledged. Transactions can now be added to the public record. Blockchain transactions can only be tampered with by changing the hashes for all the blocks and gaining control of more than 50% of P2P network nodes, right? Which is extremely difficult. Beyond cryptocurrencies, there are numerous practical uses for blockchains in industries such as health, voting machines, financial ledgers, and many more. And to keep track of artists, recordings, and licensing agreements, Spotify, right, uses a blockchain decentralized database. Now let's talk about big data. So big data refers to sets of information that are so large or complicated that they can't be analyzed with traditional data processing software. Now, to help organizations deal with their big data, specialized applications have been made. There may be problems with data analysis, data collection, data search, data sharing, data storage, and data privacy. Big data is used to figure out what went wrong, make coupons at the register, recalculate risk portfolios, and find fraudulent activity because before it has a chance to hurt an organization, right? However, it also creates security problems. The first problem is that it is not organized. Traditional data warehouses can handle and store a lot of structured data, but it still needs to be organized. An example is Hadoop, right? Which is usually used for big data, which doesn't need a structure. Hadoop is a free framework and can be used to run applications and store data. With the Hadoop distributed file system, individual servers in a cluster can fail without stopping the whole process of the computing. This system has no limits on how much data it can store. Okay, that's HDFS or Hadoop distributed file system. Now let's talk about 3D printing. So this technology is widely used in many different fields, from making cars to making airplanes. So computer-aided design, or what we call a CAD, right, is used in 3D printing to make a plan for the printer to follow. The printer can put down several layers of materials to make prototypes and parts for mass production. Since many people use this technology, it is easy for a competitor to copy an enterprise intellectual property like a specific design. Another risk is that a hacker could get into a 3D printer that is connected to a network and make mistakes in the printing process. But it could be a good way to improve security when we would normally rely on third-party manufacturers to make prototypes and early design models. The blueprints and manufacturing data that are used in this process must be kept safe at all costs. Some companies that make 3D printers use technology that allows for digital fingerprinting. This makes it possible to find out where a printed part came from. Now let's talk about homomorphic encryption. So this kind of encryption is used to keep data safe while it is being used. When an app or service needs to access sensitive data, homomorphic encryption should be considered. There are three parts here, right? When we speak about homomorphic encryption, and the first one is PIR, right? private information retrieval. So with this protocol, you can get information from a database without letting the receiver see any private information in the database. Like for example, a researcher who works for a, let's say, a medical company has to figure out how well drug trials work. Instead of sending the researcher the whole database of information with any sensitive information encrypted, PIR, right, will run the query against the secured encrypted database and only send back the results that the researcher is allowed to see. Next is SFE, or the Secure Function Evaluation. This protocol makes it possible to run a function on two different inputs without telling anyone what those inputs are. Let's say, for example, that company A, right, wants to do a statistical analysis of how customer buy things. However, company and B and C, right, hold the values that will be looked at. Company B and C, however, does not want to give company A, right, or each other sensitive PII or intellectual property. Company A sends the query or function to the two organizations and can get useful statistical information without accessing any protected data from either party. Okay, that's the SFE. And the third one is a PFE, the Private Function Evaluation. So this is also known as multi-party computation, or MPC, which lets multiple parties send data or inputs to a secure enclave where the function or recalculation will be done. In this case, the function will be kept hidden and the encrypted results will be sent to the people who own the media. This protects everyone's intellectual property, including that of the person who owns the program. All right, now let's move on to the last topic, which is about biometric impersonation. Okay, so when considering security in large complex businesses, it is important to use strong authentication schemes to protect identities. Biometrics such as facial recognition, right? Gait analysis and voice patterns have been very helpful in making MFA, or multi-factor authentication, possible. Adopting very powerful compute nodes has also made it possible to use deep fakes to fool biometrics, right? To call it deep fake. In 2020, a company director called a bank manager in the UAE and told him to make a big transfer of like $35 million. Later, it turned out that criminals had used deep learning computing techniques to make speech patterns that sounded just like the company's director. Deep learning uses AI, right, or artificial intelligence, and neural networks to pull out different traits or features from raw data. Deep fakes can be made with this technology. Deep fakes has been used many times to steal people's identities who fell for them. It's actually hard to tell the difference between computer-made deepfake audio and video and the real thing. Synthetic media is another name for deep fakes. Deep fakes can be dangerous, so there needs to be a powerful way to check if the digital media, images, or voices are real. Blockchains could be a good way to check if the media is original. All right, that's the end of the lesson. Here we spoke about artificial intelligence and machine learning, quantum computing, blockchain, big data, 3D printing, homomorphic encryption, and biometric impersonation. Okay, thank you very much for watching the video. Hello, welcome to Module 2, Lesson 1 of our CASP Plus course. On this lesson, we will talk about threat management concepts such as intelligence types, actor types, threat actor properties, intelligence collection methods, and frameworks. Let me give you an introduction first. So in this lesson, we're going to primarily deal with Security Operations Center activities. So security professionals need to identify different types of threats, right? Insider threats and APTs, or advanced persistent threats, right? And put it here, APTs, are two of the biggest threats currently targeting government departments and commercial organizations. It is important to understand the threat actor skills and motivation, and also the resources that they have available to them, like how much time can they afford to spend planning the attacks, what is their level of financial support, how sophisticated are the attackers, or is the money an objective of the attack, right? So we need to use threat frameworks to understand how to organize or reorganize or recognize threats and respond. It is important for security professionals to be able to identify indicators of compromise, or what we call as IOCs, right? And within our Security Operations Center, or SOC, we also need to respond using various techniques. All right, so intelligence types, right? As a result of gathering threat intelligence, security professionals, we have the ability to be proactive and prepared for cyber attacks. Intelligence in all three of these areas, such as strategic, tactical, and operational intelligence, will be examined. Understanding what tools are available for obtaining this information is important from a practical standpoint. First, let's talk about tactical intelligence. So, in order to gather tactical threat intelligence, security experts and analysts would be the primary players. Here, short term goals are the primary focus. So, we have what we call as SIEM, right, which means security information and event management systems, as well as other tools in the SOC or security operation centers, would be used to gather and analyze this data. So threat feeds, open source, and closed source proprietary feeds can all be used depending on the business to gather tactical intelligence. Now, real-time events and technical analysis will be used by tactical intelligence to better understand adversaries, their tools, and their tactics. Now, to find zero-day vulnerabilities, right? So zero-day vulnerabilities, we require the most up-to-date equipment and threats that have no known patches or mitigation. In short term, the focus will be on utilizing technology and automation to identify current and emerging threats. The next one is strategic intelligence. So here, senior executives and business leaders need to be informed about potential security threats. As an example, what risks do we face as an industry, right? And this is going to be a long-term strategy. Another question, are we being targeted by a specific group of criminals or terrorists? So in order to spot patterns, an organization will compile and analyze previously collected data. Alternatively, you could refer to this as strategic. So because the who, right, and the why are the two most important aspects of intelligence. A certain country may target a military defense contractor to steal their IP, right, or intellectual property. So assuming this assumption is correct, we must take the necessary steps to mitigate this threat. Third is the operational intelligence. So when it comes to gathering operational threat intelligence, forensics or first responders are often involved. Understanding an attacker's methods and techniques is essential, and there's a way to search through previous data logs for signatures of known threat actors' specific activities. We can actually deploy this method to look for previously undetected attacks. The well-known group APT30, right here, um, is one place to look for evidence of nation-state threat actors. Their mode of operation is well documented as well, and the first step in previous attacks has been a spear phishing. Right? So here, APT activities can be found at this specific link. So let's connect to this link. Should be do I do it? Okay, yeah. Sorry about that. All right, so when you click that, you're gonna go here on this specific website which is as you see here, we're seeing MITRE, right? MITRE attack, and this is for APT30. It's a threat group suspected to be associated with the Chinese government. While Nikon shares some characteristics with APT30, the true groups do not appear to be exact matches. So on and so forth. You can actually go to the other links here, right? If you just want to read all of this links here on the left side, right? Go back to the pen. All right. Next is commodity malware, right? So the use of commodity malware is a common method of attack. There are actually multiple uses of this malware, which can be found on a variety of platforms. A remote access Trojan is a good example of a commodity malware. Many different operating systems can be targeted with this technique, and the end goal can be very different. Patching systems is one of the most effective defenses against this kind of malware. And the last one are targeted attacks, right? So the tools in targeted attacks may be very specific. The following are some examples of targeted attacks. First is supply chains, right? Where third-party software or hardware that your organization relies on can be a target of cyber attacks. Next are botnets, and this will cause a distributed DDoS or distributed denial of service attack on your organization or DDoS, right? And spear phishing attack. So your company's employees may be sent a couple of malicious links via email. Okay, that's a spear phishing. All right. On the next topic, let's talk about actor types. So here, right, government-sponsored attacks involving nation-state actors are just one type of threat that must be taken into account by organizations. Cybercriminals must also be taken into account as organized crime is currently the most dangerous adversary. Insiders are responsible for more than half of all major data breaches reported in the media. All right, on the following slides, I will go over some of the people who pose a threat. First is nation states. Consistent in nature, right? APTs have a strong desire to compromise your systems and typically employing advanced techniques and frequently have access to high level resources. So detection of APTs, right, or advanced persistent threats is difficult and highly sophisticated, so they may go undetected for months or worse, or even years, right? So all known adversaries have been identified, and evidence of their tools and activities have been gathered by cybersecurity experts. Currently, there are over like 30 active APT groups that are known to exist. If you wanna see the most recent version of the list, you can go to this specific link. So let's connect to this one. Right? So this is in mandiant.com, advanced persistent threats, and have a read on all of these APTs. Okay? Or all of these articles here. Next are insider threats. So here, an increasing number of cybersecurity breaches can be traced back to insider threats, right? So more than half of all breaches are attributed to insiders, according to estimates. If it's a user who has a grudge against the organization, it could be accidental, such as a disgruntled employee. Third is a competitor, right? If you're in the same industry as your competition, you're a competitor. Suppose you're the creator of a highly specialized and highly sought after goods or service, and as a result, it's critical that you protect your assets. In fact, there is evidence that foreign governments are behind attacks that have resulted in data breaches, allowing these countries to increase their military production at the expense of US defense companies. Now, to gain access to intellectual property or IP, many commercial enterprises have used, very shady methods. So some best practices to mitigate these threats would include the following, like robust screening, of new employees, signing of NDAs or non-disclosure agreements, use of UBA, user behavior analysis, and a DLP, data loss prevention. Next is hacktivist, right? So politics is at the heart of the hacktivists' motivations. Like banks, governments, and other well-known targets may be, all of these are targets of maybe because of vengeance, right? Oil and gas companies may be the target of environmentalists. So one good example is Anonymous, right? If you have heard about this group, a number of high-profile companies have been the target of successful cyber attacks from Anonymous, right, over the years. Also, as a response to Elon Musk's activities in the cryptocurrency industry, the group recently targeted this Elon Musk, right, because it's actually a billionaire. Next, Script Kiddie. Script kiddies frequently lack sophistication and training, but despite this, they're still capable of doing significant harm. They get their hands on tools and scripts that they can use to attack your company. In some cases, vandalism or demonstration of their ability to gain entry are the only goals. To get that rush and high that comes with being an attacker, they just try to do it, right? It's a source of satisfaction for these guys. And the last one is organized crime, right? So cyber criminals from organized crime pose a very serious threat. They want to get access to money, and they can use a variety of methods such as phishing, spear phishing, and farming sites to attack both small and large businesses. And are frequently sophisticated as well. Usually the intention is to steal money, right? Money or your valuable information, which they will sell to the highest bidder on the dark web. So using ransomware, cybercriminals and members of organized crime launch attacks against your organization. These groups are now referred to as BGH or Big Game Hunters, BGH by security experts. People may also be the target of ransomware attacks in which the victim suspects they have committed a crime and is prepared to pay to prevent further legal action. We must comprehend the motivations behind and methods used by the threats or organization if are better to better understand them. Now let's talk about threat actor properties, right? So understanding an attacker's motivation, resources, and potential strategies are crucial when developing a big understanding of them. First are resources. So a threat actor's ability to carry out an attack can be greatly influenced by the resources at their disposal. Large teams of government-sponsored threat actors will have a wealth of resources at their disposal, including cutting-edge hardware and software. So they just have a lot of resources at their disposal, right? Like money, time, expertise, and so on. And they have the ability to send people out on reconnaissance missions in the real world. This will also include information gathered by other government departments. Next is time, right? So those who pose a national security or organized crime threat are full-time professional hackers. This isn't something they're doing for fun. The length of time they have access to your systems is also an important factor to bear in mind. For months or years, an organization may be unaware of APTs or advanced persistent threats. As a result, it may be difficult to estimate the total amount of data that has been compromised. Excess money, right? So how much money do the attackers have? The majority of the time, this means a substantial amount of money. For cyber criminals, the rewards are just enormous, and ransomware is thought to be responsible for majority of the attacks. Next is supply chain, right? So any involvement of a third party must always be viewed as a risk. Your supply chain could be the target of a cyber attack. When working with B2B partners or business to business partners, right? Or subcontracting services to third party suppliers, this could include third party supplied software. A supply chain attack could include anything that you don't have direct control over. Malware could be contained in the firmware or embedded service or embedded devices or in firmware updates for smartphones. A supply chain threat may arise when you upgrade your network infrastructure, such as by deploying a new firewall. Next is capabilities and sophistication. So despite the fact that mainstream attacks occur more frequently, the attacker's abilities are usually limited. Cybercriminals who employ widely available tools and techniques such as script kiddies use these types of attacks. There will be fewer attacks if we're dealing with a more capable and sophisticated foe. A lot more thought and planning goes into these attacks. Nation-state launched APTs are one such example of these. And the last one is the identification of techniques. Many tools and techniques such as advanced analytics, machine learning, and AI or artificial intelligence must be used in order to identify attacks. Just some of the tools we can use to detect these kinds of attacks are listed here. It is critical that security professionals have a thorough understanding of the tools and techniques available to them so that they can better protect their organization from cyber attacks in the future. Okay, now let's talk about intelligence collection methods. So intelligence collection methods, right? There are actually a variety of places to look for intelligence, right, or intel. Some tasks can be automated, but in many cases, the available intelligence resources must be thoroughly researched, necessitating a time commitment. Intelligence feeds. So here it refers to a dashboard that can display from a wide variety of sources. We might be interested in seeing threat maps that are updated in real time, showing the current global activity of things like botnets and C2 servers is a good example. So if you look at this specific website, right, it actually provides an example of a threat map. That's so this is how it looks like if you go to that website. Okay, there you go. So as you can see here, the blue ones are the CNC server, and the yellow ones are the botnets, right? You can actually filter this. Where's the filter? Uh, yeah, here, right? You just want to see the botnet activity. As you'll notice, there's just a lot of botnet here on this area in Asia, here in Europe and India, and you have some in US. And if you look at the top talkers, right? Top botnets, top countries with botnets, we have China, India, USA, Indonesia, and so on. Top 10 worst botnet ISPs: Amazon, Airtel, I know what this is, Jaweb, ChinaNet Telecom, and so on. Okay? There's just a lot of activities happening here. This is a live botnet threats dashboard from Spam House Technology. Okay? There's also many good commercial options, right? And that are available from security companies such as Fortinet, FireEye, Symantec, and many others, as well as many good source, open source options. There's also a free threat feed from the National Cybersecurity Center (NCSC) in the United Kingdom, but only for government departments affiliated with the NCSC. If we look at this one, right, so this link will provide an excellent example of an all-encompassing cyber threat feed. Let's click on that. Right. So, well, here, well, you gotta you have to sign up. So at least you have the link, right? So okay. So I would suggest that you explore how this works, right? And just go to the specific link. Okay. Next is deep web. So as an alternative to the mainstream internet, there's a deep web, right? It's also referred to as the dark web. Sometimes it's referred to as the surface web. On the deep web, no content is being indexed. In countries where personal freedoms are restricted and censorship is placed, people turn to the deep web for assistance. Criminal activity generates a significant portion of the content on the deep web. The highest bidders will get their hands on stolen credentials and zero-day exploits. Keeping track of criminal activities and data on the deep web is critical for law enforcement and cybersecurity professionals. Because the dark web is not indexed, gaining access to a site's URL is required. Now, to complete the setup, you'll want to use a secure browser like Tor, right? Let me put it here. Tor. Um, let's probably go to Google and search for that. Where is it? Yep, Tor. When you click Tor, you can go ahead and install it, right? Just install it and use it as your browser if you want to go to the deep web. Okay. Next is proprietary intelligence. So here, subscribers will be the only ones to have access to this type of threat intelligence. Certain government threat intelligence, for example, will only be able um, to get access, right, to 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 these proprietary intelligence websites. There's only a limited number of law enforcement departments and agencies that are allowed to receive information from law enforcement. Data from the military and federal agencies will be kept strictly confidential and should not be divulged. Next is open source intelligence. There's no charge for this one, the OSINT, right? OSINT. So, it has a wide range of applications as well. It helps to think about it from the. Oh, it will help you to think from the attacker's point of view, right? And just a few examples of publicly accessible information include email addresses, company information on a website, and DNS records. Last is human intelligence. So it is a form of intelligence gathered by humans, not machines. In a military sense, this entails setting up camp on the ground. This could include a physical search of a potential target location and perhaps a factory or military site. A certain amount of tradecraft will be required by the intelligence officer to master the skill set. This means they will be able to read signs and body language as well as use profiling to learn about the attacker's motives and objectives. We can use an industry framework to help security professionals understand how to use threat intelligence. Okay, so these are the five um, intelligence collection methods. Now let's talk about frameworks. All right. So in order to know what tools, tactics, and techniques an attacker will use to launch a successful attack, we need an attack framework. There must be a thorough understanding of a hacker's planning process from reconnaissance to attack completion for security professionals. So in the next few slides, we'll go over some of the generally accepted methods in the industry. First is the MITRE attack framework. So the MITRE Institute is a non-profit institution. So it was, since its inception in 1958, it has served primarily as a support group for government and businesses. Today's members come from a variety of backgrounds, including the industry, like for example, Microsoft and Fujitsu. MITRE receives government funding to conduct research and is well known for its published attack frameworks and techniques. An attacker's methods and techniques against operating systems, cloud network mobility, and industrial method systems are mapped out in matrices. This figure right here shows a breakdown of the enterprise MITRE attack framework. The MITRE Corporation has granted permission for this work to be reproduced and distributed. So let's talk about attack for industrial control systems, or ICS. So here, government agencies in the US provide assistance to industries that rely on ICSs, right, or industrial control systems. CISA's mission is to provide cybersecurity services to the nation's critical infrastructure sectors. Among the critical infrastructure identified by CISA, right, are the sectors of energy, food and agriculture, and manufacturing. As part of its efforts to help cybersecurity professionals, MITRE has also published an attack framework for this industrial control systems, or ICS. So if we look at this link, let's visit this one. It's actually just the same, right? But at least it gives you, um, let's say you want to click on this one. So you'll be able to get more information on a specific entry, right? On this specific illustration. So just go to this link, and if you're curious enough, then just read on this clickable links. Okay. Um, as an example, we have here the Sandworm team, which has been identified as a military intelligence unit sponsored by a nation state. So here, attacks on the Ukrainian national power grid and the non-PKI malware attacks in 2017 have been linked to this group. If you want to look at it, just go to this specific link. Let's open it. Okay, Sandworm team. Yep, it's just a lot of events here. Okay, next is the diamond model, right? So when it comes to identifying potential dangers, the diamond model comes in handy. Identifying their capabilities and the intended victims is possible. Using this model, forensic analysts can search historical logs for signs of compromise. A better understanding of how the adversary works or operates can speed up the process of detecting a breach. It's critical to know your opponent's strengths and weaknesses, and it is extremely helpful for threat hunting, as it enables an organization to understand the motivations and tools and techniques that will be deployed in an attack. The diamond model can be seen in this figure right here. So when investigating a single attack, this is an excellent strategy. Next is a cyber kill chain. It's actually a method developed by Lockheed Martin. It is a seven-stage model, and it is helpful to list each of the model steps. An attack can be stopped if we can bypass even one of the steps. So the seven stages documented by Lockheed Martin are shown on this specific figure. So if we click on this link, if you want to get more details, you can go to that link. As you will see, this is the seven-stage model, right? And you can get more information here, right? You get access to white papers and different documents that is published by Lockheed Martin. Okay? So as you will see, frameworks are quite very important asset and can be useful for creating incident response playbooks or giving additional context during investigation. Next is threat hunting, right? So operational intelligence can benefit from the use of threat hunting techniques. One of the threat frameworks is needed to better understand our adversaries, tools, and methods and search for IOCs or indicators of compromise. Detecting APTs is easier with this method. And the last one is threat emulation. So here, using a variety of tools, techniques, and procedures, security professionals can fine-tune their approach to threats. There are many ways to conduct team security exercises, including the use of the attacker's TTP and the blue team's protection of the network. The first step in responding to a threat is to figure out exactly what the threat is. All right, that's the end of the lesson. Here we spoke about intelligence types, actor types, threat actor properties, intelligence collection methods, and frameworks. Okay, thank you very much for watching the video. Hello, welcome to Module 2, Lesson 2 of our CASP Plus course. On this lesson, we're going to focus on security operations, covering indicators of compromise such as logs, notification, notification severity and priorities, and what's going to be the responses needed. So, just an introduction, right? So, a busy network would experience a lot of different events. When an event is unusual, it may be noted in logs or combined with another event that also seems unusual. This might be a sign of an indicators of compromise or IOC. Okay. Another illustration of an IOC is a series of failed attempts to connect via SSH to a core network appliance, followed by a successful authentication attempt from an odd or gray listed IP address, right, or block listed IP address. The Security Operations Center must be able to recognize the threats or attacks. So here we require inputs in the form of logs and recorded network traffic in order to identify IOCs. First is packet capture. So PCAP files, right, this one, are stored in a standard log format. They enable us to collect data in real time. Wireshark, TCP dump, and Tshark can be used to analyze captured data. So here, the PCAP format in this figure allows logs to be analyzed using various vendor tools and platforms. So as you will see here, right? So it's talking about an SSH attempt. So the file name is SSH attempt .pcap file, and you can see the timestamp in here and what's the source of that request and what's going to be the destination and what are the protocols. Okay. Now let's talk about logs. Okay, so many different appliances and services will keep track of activity, and this could range from desktop applications and services to server-based services. All of this log data can help you see the big picture. Syslog is a Linux or Unix-based operating system standard, and this enables event facility codes to be assigned. Network logs, vulnerability logs, operating logs, access logs, and netflow logs, right, are all examples of logs. Let's go over each of this log type briefly. First is the network logs. Network logs enable us to record network traffic, activity on switches, routers, firewalls, IDS or intrusion detection systems, and a variety of other network applications or appliance. As you will see here, this illustration depicts an example of a firewall log. Okay, so network logs can be sent to an SIEM for further analysis. Next are vulnerability logs. Vulnerability scanning tools such as Nasus, OpenVAS, and Nmap will generate vulnerability logs. It can be beneficial to consolidate and present all of this collected data through a simple or a single pane of glass. Vulnerability logs can be sent to an SIEM as well, okay, for automated detection and alerting. As you will see, this image, this depicts a vulnerability scan log. Okay, so it is critical to log the results of the vulnerability scan. Next are operating system logs. So because many services may be hosted on an OS platform, this can be useful. These logs can be uploaded to EDRs or Endpoint Detection and Response, right? EDR, and allowing more granular data control and visibility. Application events, security events, and service logs such as DNS or DHCPs are example of logs. And as you will see, this image depicts a portion of a security log from a Windows client. Okay, here. Accountability and regulatory compliance rely heavily on security logs. Next are access logs. So when accountability must be established, access logs provide an audit trail. A security audit can be performed to determine who used remote access services to access an information system or who changed permissions on a user's mailbox. We may want to keep track of who has physical access to a specific location, such as who has physical access to the data center at the time of a security breach. Access logs will be useful for accountability and may be required for regulatory compliance. Next are NetFlow logs. So network switches, routers, and other network appliances can forward NetFlow logs. A collector collects different logs which can be used to baseline the network and visualize the flows and data types. So as you will see here, this shows us, right, a Cisco NetFlow log. Okay. We can also figure out where the majority of the network traffic is coming from. So this one, it shows pink. So if this is visible, maybe you have to expand it from the tool so you'll be able to see what is the IPv4 source address of this specific traffic, which consumes a lot of, which probably is one of the top contributors on this specific diagram. Now let's talk about notification. An operator console can receive notifications, right? This could be in the form of an alert or any email message indicating that the threshold value has been reached or that a specific event requires the attention of an administrator. First one is file integrity alerts or file integrity monitoring alerts. File integrity monitoring systems, right? So FIM will notify you if any key system files or other files that have been identified as important are modified. So tripwire, right? For example, so I'll put here tripwire is a specialized product designed for this purpose. Windows also includes its own system file checker to detect attempts to modify critical Windows operating system files. Reporting and alerting are critical for real-time security and may be required for regulatory compliance. Next are SIEM alerts. SIEM alerts will aggregate events from multiple sources of logged data. On the logged data, we can then apply smart analytics, machine learning, and behavioral analysis. SIEM enables automated alerts for unusual or suspicious activity or events. All right. Next are DLP alerts, data loss prevention, right? If you would remember. So DLP systems prevent the exfiltration of sensitive data, IP or intellectual property, and sensitive customer records such as PII or personally identifiable information, sorry, or and PHI, like protected health information. Typically, this is accomplished through the use of labeling techniques in which users label their files with specific classifications in order for the DLP system to understand what level of classification the data is. It is critical to monitor this activity because while the DLP may prevent unwanted exfiltration, we must be aware of these events. So as you will see here, this illustration depicts a Microsoft DLP detected event, right? So DLP is actually concerned with threats to data leaving the network. We must also examine network traffic as it enters the network, okay? The fourth one is IDS and IPS alerts. So IDS and IPSs take either a passive or active approach. IDSs detect threats but take no action, right? IPSs detect and prevent threats from occurring. So here we need to monitor this activity and we must be notified when there are a large number of events or events of high importance. Even if the tool is doing its job, we must remain aware of this activity. Threats or malicious events should be reported via monitoring alerts or automated emails. Next are antivirus alerts, right? So here, antivirus alerts or software is in place to keep malicious code and programs from spreading. This activity should be recorded and monitored even if antivirus is successful. It's best if this is done from a single dashboard. Now let's talk about notification severity and priorities. So when it comes to reporting, it is important to focus on the most serious events or incidents. If the logs can be filtered to highlight serious events, then a quick response can be activated after the background noise in the system has been removed. Security experts should investigate immediately any unusual process activity that is automatically remedied. Prioritizing via CVSS, right, or impact score is essential because it will never be possible to fix all of the vulnerabilities. Controls must be put in place to stop or prevent unwanted activity once it has been identified within the company. All right, now let's talk about response. Okay, so the use of automation for event detection and response is critical, and when we have a plethora of security tools to keep our network safe. As a result, the SOC's staff, right, is free to work on the other important security project. When it comes to dealing with threats and alerts, SOAR, right, or S, or Security Orchestration Automation Response, is the modern approach, right? The creation or provisioning of an automated response can be accomplished through the use of playbooks. You can have a simple set of rules in your playbook, or you can have a more, elaborate or sophisticated one. Um, in terms of response, here's what we can do. First is a firewall rules, right? So to ensure the safety of your DMZ or demilitarized zone network services, firewall rules are critical to be implemented on a DMZ. When firewall rules are deployed as host-based firewalls, they will also protect your internal resources. Changes in the threat landscape and the appearance of new attackers may necessitate modifying firewall rules. Firewalls may require updates to bad actor IP address ranges. Next are IPS IDS rules. It is critical to have IPSs and IDSs in place to protect against threats that originate outside of your network. When new threats are discovered, these rules must be updated on a regular basis in order to keep pace. Third are ACLs, or access control lists. An ACL is quite a generic term, right? And ACLs can comprise permissions on the security tab on a file or a folder. Firewall rules are often referred to as ACLs. Other examples could be rules created for network devices, or example, layer 2 devices, such as a wireless access point or a network switch could restrict access based on your MAC address. So in response to threats to layer 2 devices, we can create a whitelist of authorized devices. So in this figure, this will show you an example of what we call as MAC filtering. Other rules could be based on known signature or checksum. Next are signature rules. So signature rules are typically configured based on what is known, such as definition file, which can be updated as new threats are discovered and evolve. It is critical to keep signatures up to date, as an antivirus engine is heavily reliant on signatures and updates. A signature could be a hash match, right, for a previously identified malicious file. The European Institute of Computer Antivirus Research, or ACAR, right? ACAR. It's actually this one. So an ACAR test file, for example, was created to allow security personnel to determine whether antivirus software is operational. It employs the well-known string of characters depicted right in this figure. Also, this would be the signature for this specific string. Okay. Now our behavior rules. The rules. So when we store so much important data in the modern enterprise, behavior rules are critical. We require systems that detect anomalies through behavioral analysis. The system would create rule sets for normal activity using AI and machine learning. However, if an anomaly occurs, such as a user starting to transfer a large amount of data to a cloud-based data repository, or a user starting to delete an unusual number of files in a short period of time, the system will generate alerts and notify an administrator. So typically, this is accomplished by modeling normal user behavior and then comparing the abnormal behavior to what is normal. Okay? Next is DLP rules. So DLP rules must be kept up to date at all times. Regulatory compliance requirements may shift, necessitating tighter controls. The search strings used to detect PII, PHI, IP, and financial information may need to be modified, and new rule sets may need to be added to your DLP solution. As you will see, this illustration depicts a sample of a DLP rule set, which has this one credit card number, debit card, SWIFT code, and with the confidence value here. Many of the implemented rules look for specific words or character sets. And the last one are scripts and regular expressions. Scripting could be included in automation. Regular expressions could be used to create scripts that search for keywords. This may provide security by scanning captured log data or searching incoming web server requests. DLP is an excellent example of searching incoming network traffic. Now, based on these search patterns, we can create rules. It is critical that an organization has identified potential IOCs and has implemented mitigation to effectively respond to these attacks. All right, that's the end of the lesson. On this lesson, we spoke about IOCs or indicators of compromise and how to detect those using logs, notification, and notification severity and priorities, and what's going to be the responses to address these IOCs. Okay? Again, thank you very much for watching the video. Hello, welcome to our Module 2, Lesson 3 of our CASP Plus course. This lesson focuses on vulnerability management, focusing on the following: vulnerability scans, SCAP or Security Content Automation Protocols, and information sources. So some introduction. So security professionals must always evaluate the security of operating systems, networks, industrial control systems, end user devices, and user behaviors. We need to use vulnerability scanning to check how safe our systems are all the time. We should use tools and protocols that are standard in the industry to make sure that everything works well across the enterprise. Professionals in security should know where to find information about current threats and security holes. We might need a third party to check on our security, which means we'll have to ask them to look at our systems. Independent audits may be needed to comply with rules, laws, or industry standards. Let's talk about vulnerability scans. Security experts must be able to recognize when systems lack critical security configuration or critical patches, which is why vulnerability scans are very crucial. Security experts in the company will perform vulnerability scanning to find systems that need to be fixed. Malicious actors may also use vulnerability scanning to find systems that are missing important security updates and configuration. They will then try to take advantage of this flaws. So there's actually four different components here, or four types, right? For vulnerability scanning. First is the credential versus non-credentialed scans. So understanding the capabilities of the assessment tool is important when carrying out vulnerability assessments. To provide accurate data, useful information on the systems that are being scanned, credentials may be occasionally be required. Some tools allow for anonymous scans and don't require login information. It is actually crucial that we provide privileged credentials if we want to obtain an accurate security assessment of an operating system. As a result, settings like the following will be listed in the vulnerability report, such as installed software version, local services, vulnerabilities in registry files, local file system information, and the patch levels. Next are agent-based, server-based scan. Some vulnerability assessment solutions call for the installation of an agent on the endpoint. The scan can be performed on the end device, and the results can be pushed back to the server-based management console, enabling the pull technology. There are alternatives as well, where no agents are used, or we call it agentless scanning. This implies that in order to obtain data from the end devices, the server must push out requests. Most of the time, agent-based evaluations will reduce network traffic and relieve some of the server's workload. Next is criticality ranking. So when we conduct a vulnerability assessment and review the output report, it is crucial to present the reports in a clear manner that enable us to identify the most important vulnerabilities and take the appropriate action. Two vulnerability scans are depicted on this specific figure, right? First one, first two. First, the Wireshark installation related vulnerabilities are of very high priority, right? As you will see. According to a report, a software update can fix them. These vulnerabilities have been fixed according to the second scan. Other correction calls for application, service removal, and configuration workarounds. And the fourth one is active and passive scans, right? There. So the reporting and management station and the endpoints must communicate during active scanning. Passive scanning has the ability to gather log data and analyze it. We might not want to overburden the network or endpoints with additional reporting and subsequent network traffic on some networks like, operational technology networks or OT. Passive scanning aims to perform network traffic analysis without data injection by connecting to a read-only port. So that's why it's saying here it's non-intrusive. While active scanning is quite a different strategy that can be used to produce reporting that is more accurate. So as you will see, active scanning says it's intrusive, the information is quite detailed, momentary scan more complex, and suited for specific queries. So also SCAP, right, which will be our next topic, is a prime illustration of active scanning. Now let's go to SCAP, Security Content Automation Protocol. So many vendors in the sector use SCAP, right, here, which is an open standard that supports a standard security reporting language. It is supported by the National Vulnerability Database, or NVD, which is an organization that receives funding from the US government and creates content that can be accessed by SCAP scanners. It meets the requirements of the FISMA, or Federal Information Security Management Act, and is widely used by the US government agencies such as the DoD, or Department of Defense. So there's a couple of components here. First one is XCCDF, or the Extensible Configuration Checklist Description Format. It's quite a long name, XCCDF. So a format for configurations files is specified in XCCDF. The SCAP scanner, a tool for assessing vulnerabilities, will deploy this checklist. They have been written in XML, okay? And these documents are more commonly referred to as a secure technical implementation guide within the US government and DoD. If you want to know about, if you want additional information, you can go to this specific website. So let's click that. Just take some time. Okay, there you go. All right, so this is the Security Technical Implementation Guidelines, and you can go to the document library. All right, so you can see a couple of files in here that you can actually download. Okay, so for you to be able to get at least some information about um, how to protect these specific devices. It's just a lot. All of these are multi-vendors. You have Riverbed, familiar with Riverbed. You have VMware, NSX, Trend Micro, SUSE, right? And so on and so forth. Okay? Next is OVAL, or Open Vulnerability and Assessment Language. OVAL is actually free and in an open international standard. Vendors can produce output that is consistent thanks to it. So when I view a report generated by the Nessus tool, the output produced by a tool from a different vendor that is OVAL compliant will match it. Right? Let's go to the next one. CPE, or Common Platform Enumeration. So CPE is used to categorize various operating system varieties, hardware and software. The vulnerability scanning tool can then use this information to automatically decide which vulnerabilities to look for. As an illustration, if the system is recognized as running Linux and a common web application service, only those installed products need to be checked for these vulnerabilities. Right? Next is CVE, or Common Vulnerability and Exposures. So the NVD and MITRE both release CVEs, right? They provide information on the vulnerability, such as seriousness or significance of the vulnerability and the steps to take to address it. This will frequently be a link to a vendor site where you can download a patch or fix. Next is CVSS. So by employing a qualitative risk scoring, CVSS, right, or Common Vulnerability Scoring System, is used to determine the severity of vulnerabilities. So version 3.1 of the scoring formula is currently in use. So to view the metrics used, security professionals can access a CVSS calculator at this specific URL. So this is an example, but we can go to the website. Let's click that. All right, so it's just a matter of so once you have a CVE, you can check, you can actually choose which one to applies, right, to your specific case. Let's say it's a network, high complexity, privilege required high, user interaction required change. Let's say it's high. So worst case, right, if you do this high, then you get a very high calculations here. So which means that this could be very critical. All right. You can also choose some here, but high. So it gives you a view, right, about the severity of a specific vulnerability. Okay. Next is CCE. Sorry about that. One, or Common Configuration Enumeration. So this group of identifiers makes it possible to quickly verify configuration items. So only software configurable items are currently covered by this specific standard. This standard enables the creation of templates using a common structure. So for the Microsoft Windows operating system, a standard set of identifiers is published. And as a result, template files that can be used with SCAP scanners can be created. Next are ARF, or Asset Reporting Format. ARF is a common report format that is built in XML templates. It makes it possible to format scan result in SCAP compliant manner. We should think about who will be in charge of the security assessment now that we are aware of the standards and tools available. Next is self-assessment versus third-party assessment. So in some circumstances where internal reporting is crucial, self-assessments may be acceptable. However, there are times when we may need third-party verification. For instance, in order to operate a certificate of authority, right, or CA, you would need third-party auditing reports. Governance and risk compliance should always be a continuous assessment. As your customers might only be able to work with suppliers who have accreditation, you would typically need third-party verification to operate as a cloud data center. Also, an annual penetration test, which would probably include a vulnerability scan, is required for a PCI DSS compliance. This annual examination cannot be carried out internally. And the last one is patch management. So here, appliances, right, servers, and end devices also all need to be updated frequently. OS or operating systems are used to run services, programs, and embedded firmware. Patches enhance system functionality while also, and more importantly, reducing security risks. System flaws may ultimately result in problems and operations availability. Now, before being made available to the customer, patches are first tested by the vendor. Patches occasionally break functioning systems, in which case the benefit of the patch is significantly outweighed by the necessity of maintaining the system's functionality. Therefore, before deploying patches into a production environment, an enterprise should test them thoroughly in a non-production environment, and there are actually numerous additional resources for information on security. All right, now let's talk about information sources. First, our advisor. So here, right, sorry. So automating the generation of reports and dashboards is quite critical, but it is equally important to consider other resources in order to maintain strong security posture. Additional vendor and industry-specific information is available through these sources. So let's talk about this five. First one is the advisories, right? So company security advisory, whether issued by vendor and third party, should be closely monitored. When new vulnerability is discovered, such as a zero-day exploit, the information will be posted as an update. In order to keep security professionals up to date on the latest threats, this would be a very vital tool. We can use advisories to get information on potential threats, both new and old. So as a starting point, here are some of the useful URLs as a reference. So here we have one for Cisco, VMware, and Microsoft. So let's click each of them one by one. Loading. Okay. So this one is for Cisco, and we can see a lot of security advisors here for different products. And the highest one here shows for telepresence. For VMware, let's look at critical. So these are the critical security advisories affecting all of these products of VMware, and also for Microsoft. Okay. Next are bulletins. Right. Bulletins, right? Vendors can also use bulletins to inform their customers about potential security issues and vulnerabilities. Subscriptions via RSS feeds are supported by a large number of vendors. So here are the following examples of vendor security bulletins. So let's click this one. AWS, and this is for Google Cloud. Okay, there you go. Security bulletins from AWS. Security bulletins for Google Cloud. Okay. Next is vendor websites. So here, security information can be found right on different vendor websites. Additional security related information, tools like, and also white papers and configuration guides may be available in addition to the previously mentioned websites like advisories and bulletins. Access to extensive security guidance and best practices is provided by a number of vendors, including Microsoft. So let's click this link, let's see what it has. All right, so it shows security documentation. You can download some documents here. What else? Yep, there's just a lot of things you can get here, right, depending on what you need. This one is for network, IAM, storage, privileged access, and so on. Okay, it's pretty much a very good reference from Microsoft. Next is information sharing and analysis, or it's actually ISACs, right? So you have to put an I here. So ISACs allow organizations that provide critical infrastructure to share security information or cyber threats, and this is a global initiative. Information can be exchanged between public and private organizations with the help of this program. You can learn more about this initiative by visiting this website below. Let's go to the website, So National Council of ISACs. You can go to, look at the publication. Yep, and you can see a couple of documents here. Okay. Last one is news reports. So people's awareness of current threats and their perpetrators can be heightened with the help of news reports. So crypto malware and ransomware outbreaks were widely publicized in 2021. So in order to protect an organization's information system from ransomware, it is essential to be aware of this specific threat. Okay, that's the end of the lesson. On this lesson, we spoke about the following: vulnerability scans, security content automation protocols, and information sources. Okay, that's the end of the lesson. Thank you very much for watching the video. Hello, welcome to Module 2, Lesson 4 of our CASP Plus course. This lesson is going to focus on vulnerability assessment and penetration testing methods, which will cover the following: testing methods, penetration testing, and security tools. So testing methods, right? So depending on the scope of the tasks, different methods can be used to identify potential security holes in an organization. Attackers and security professionals both conduct vulnerability assessments in order to find any weak points in our network's defenses and searching for the same vulnerabilities. Now, let's talk about the following testing methods. The first one is static analysis. Typically, source code or uncompiled program code is subjected to static analysis. It makes it more difficult for an attacker to gain access because it requires access to the source code. The source code could be provided to the tester during a penetration test so they could perform this kind of analysis. An essential step in reducing the risks associated with vulnerable code is static application security testing, or SAST. Static application security testing, or SAST. Next is dynamic analysis. So systems that are currently in use can be the subject of dynamic analysis. If it's software, then the code has already been compiled and is being evaluated with dynamic tools. Next is side channel analysis. So here, measurable outputs are the focus of side channel analysis. The code itself or the actual encryption technology are not under attack. It necessitates the observation of network signals like CPU cycles, power spikes, and noise. Artificial intelligence and powerful computing technologies can be used to analyze the electromagnetic signals. It would also be possible to create the encryption key that is being used in the transmission using these methods. Next is a wireless vulnerability scan. Given that many organizations have wireless capabilities, wireless vulnerability scanning is crucial. Depending on the signal strength, vulnerabilities may be present outside the network boundary. Wireless networks must be protected by security experts if we are to avoid being vulnerable to unauthorized intrusions. We must avoid using unsecured protocols on our wireless networks so that login credentials cannot be seen in plain text. We must make sure that the administration is not taking place in an unsecured manner over wireless networks. Hackers search for web systems in order to decrypt the key because older networks may have been set up with web encryption, which is very simple to break. Next is SCA, or Software Composition Analysis. It is estimated that open source software makes up about 90% of all developed software, and this was around 10% in the year 2000. By reusing code, open source software can be incorporated into developed software. It can also incorporate it when a business buys a commercial off-the-shelf products or COTS. Other sources of open source software could include third-party development, third-party libraries, and developers using code repositories. All open source code used in your environment can be analyzed by SCA. Any third-party code that is incorporated into your production systems must be visible. So all third-party code usage can be found using SCA tools. And the last one is fuzz testing. So here, input validation error handling will be tested on the compiled software using fuzz testing. In an effort to introduce errors into the running code, fuzzing will send the application seemingly random inputs. To program and interpret the potential errors that are generated, a fuzzer needs a certain level of expertise. Now, automated fuzz testing is now frequently incorporated into the DevOps pipeline to maintain automated testing of its infrastructure and to record errors. Google used a program called Cluster Fuzz. We put it here. Cluster Fuzz. Okay. In addition to obtaining independent confirmation of the security posture of networks, systems, software, and users, it will be important to perform regular vulnerability assessments against enterprise networks and systems. Now let's go to the next topic, which is about penetration testing. So although internal teams can carry out penetration testing, regulatory compliance may require obtaining independent verification. It's critical that you select a pen testing team that is knowledgeable and reliable. Government agencies in the UK are advised to hire a pen tester who has once the following credentials by the NCSC, or the National Cybersecurity Center. Okay, so the use of an industry recognized framework by penetration testers is very important. There are numerous options available, like Open Web Application Security Project, or OWASP. These are all very, helpful tool. And they provide direction, enabling organizations to choose testing standards to satisfy regulatory compliance. So here's a website that provides more information about pen testing. The penetration testing execution standard is one of the widely used standards. Okay. So what's needed here, right? So what are the flow? The first one is at least get the requirements, right? Understand the requirements. So it's very crucial to comprehend or have a clear understanding and the precise purposes of the engagement when an organization is getting ready for security testing, so that the report will be very valuable. So some questions like, are we trying to get ready for compliance with the law? Maybe we're checking to see if our staff members understand security. So getting a clear picture of the goal or the requirements is very important. Next is box testing. It is important to think about how realistic the assessment will be when simulating an attack from an attacker who is highly skilled and motivated when analyzing the assessment requirements. So there's a couple of types of box testing called the white box, gray box, and the black box. So what's the difference? So in the white box testing, so when the attackers have access to all pertinent data for the engagement, this is what you call as white box testing. Therefore, they would provide the source code and the system design documentation if the penetration testers are testing a web application and the customer wants quick results. Also, a full knowledge test is another name for this, right? So this is white box. Now, what's a gray box? When we don't have a lot of time, right, gray box testing, which lies between white and black, might be a good option. By making physical and logical network diagrams available, we could do away with reconnaissance and footprinting. Another name for gray box is partial knowledge test. And the third one is a gray box. Third one is black box. So in black box testing, the testers will only be provided with information that was already available to the public. A zero knowledge test, right, is also another name for black box. So with a test that simulates an actual external attacker, the customer's objective might be to learn more about how secure the business is. Third is a post-exploitation. So here, collecting as much data as you can from infected systems will be part of post-exploitation. Persistence is necessary during this stage as well. It's crucial to abide by the engagement guidelines that have already been established with the client. Privilege escalation, data exfiltration, and DOS or denial of service are examples of frequent activities. You can also visit this link for a complete list of activities. So let's try that. Okay, all right, there's just a lot in here, right? So post exploitation. Okay, so please take time to explore this specific website, right? Now is persistence. So long-lasting attacks like APTs or advanced persistent threats, which permanently compromise networks of organization, aim to persist. The attack matrix for enterprise by MITRE includes a list of 19 persistence-related techniques. So if you want to look at that, you can just go to this website. Okay, click that. There, right? So these are the names, those. Okay. So there's also several methods that is listed, right? Like account manipulations, you can also see it here, right? Account manipulation, background intelligence, transfer services, boot or logon auto start execution, boot or logon initialization scripts, browser extensions, compromise client software binary, and creation of accounts. Next is pivoting. In order to move laterally through the network to larger and more significant areas, an attacker must first get a foothold on a compromised system. Usually, a known built-in account will be used as a backdoor to accomplish this. There are 9 lateral movement techniques listed in the MITRE attack matrix for enterprise. So here's the list of typical pivoting strategies, right? Like exploitation of remote services, spear phishing, lateral tool transfer, remote service session hijacking, remote services, replication through removable data, media, software deployment tools, taint shared content, and use alternate authentication materials. So again, right, the pivoting process is important for learning about systems on different network segments because it enables a tester to move laterally through networks. And the last one is rescanning for corrections and changes. So action on the findings of pen testing is crucial for management and security professionals. The most critical risks should be given priority when implementing controls to fix problems. Now, to evaluate the controls, we can perform additional tests. And to evaluate the security posture of networks, systems, and users, security experts and pen testers will employ a variety of different tools. Okay, now let's go to the list of security tools. So there's actually a numerous number of tools available to find and gather security flaws or to conduct a more thorough analysis of how systems and services interact. The scope of the test during penetration test may leave the team with no prior knowledge of the network. Black box testing would be used to describe this. Reverse engineering methods would need to be applied to applications, and the team would need to deploy tools to enumerate networks and services. All right, so on the next few slides, we're going to examine all of these tools. First is the SCAP scanner. So using input files like STIGs, that's what we discussed from the other lessons, and other XML-based configuration files, a SCAP scanner will be used to report on deviations from baseline. By identifying the operating system and software installed using CPE standard, the SCAP scan will also look for any vulnerabilities. The SCAP scan can now look for known vulnerabilities associated with CVEs after the information about installed product has been gathered. So as you will see here, OpenVAS CAPS scan, right? Here's a view of that. So OpenVAS is an oval compliance CAP scanner, and this figure displays the findings of a scan with critical vulnerabilities listed first. This is the severity level here. So a vendor fixed in the form of a software update is available to address one of the vulnerabilities with a critical rating. So as you will see, this is the vendor fix, right? And this is the recommended solution as well. So it means you might probably need to upgrade your Wireshark version, right? And you will see the impact here if you don't upgrade. So of course here, there will always be a course of action. Like what I've said, you just need to download a patch. It could be changes in the configuration. There could be a workaround or an installation for each vulnerability found. Next is a network traffic analyzer. So the gathering of baseline traffic is also important. This enables experts to understand typical traffic patterns and recognize anomalies. As we can identify trends, these tools can be helpful for capacity planning. So as you will see, the breakdown of network traffic flow is shown on this specific graph, right? So it's important to take into the account that the security posture of the network's connected devices, in addition to understanding network traffic patterns. Vulnerability scanner. So open listening ports, improperly configured software, and the lack of security updates, some shady or malicious web application security, and many other types of vulnerabilities can all be found using a vulnerability scanner. As you will see, this illustration depicts a website vulnerability scan. Although a vulnerability scan is crucial, it may not find additional data in the protocols and payloads of network traffic. That's why we're going to talk next about the protocol analyzer. So when we need to perform DPI or deep packet inspection on network traffic, a protocol analyzer is helpful. Common applications of this technology include TCP dump, Tshark, and Wireshark. Utilizing a common file format, network traffic can be captured for later analysis using the tool. This tool could be used to verify the use of insecure protocols or data espionage. As you will see, this image depicts Wireshark in action while capturing unencrypted FTP traffic. A protocol analyzer won't be the most effective tool when the network needs to be enumerated or mapped, and the best option might be an active scan. Next is a port scanner. So to find all the active network hosts on the network, a port scanner will typically start by performing a ping sweep. The TCP and UDP listening ports on each host will then be determined by conducting a probe. To find unnecessary applications on the network, port scans can be carried out. Additionally, hackers can use them to list the services on the network segment. As you will see, this figure displays the port scan that Nmap has conducted. This one is these are the ports. Next is an HTTP interceptor. Here, security professionals and experts and pen testers use HTTP interceptors as well. This tool is helpful when we need to evaluate a web application security posture without having access to the source code. Burp Suite, which is a well-known HTTP interceptor, here, is depicted on this specific illustration. On Kali Linux, it is offered as the default application. Directly on the host workstation, the HTTP interceptor is set up as a proxy. The tester can view the raw HTML of all browser requests and web server responses to learn important details about the application. For the interceptor traffic flow, please see the this one, right? Then to interpret the captured payloads when using this tool, some developer or coding experience is required. Next is the exploit framework. An exploitation framework can be used by penetration testers to send payloads to network hosts. Usually identified vulnerabilities are used to accomplish this. So Sniper, Core Impact, Canvas, and Metasploit are examples of well-known frameworks. So to ensure that all vulnerabilities are found and tested, exploit frameworks must be kept up to date. The attack can start after a scan has located hosts on the network and identified the operating systems. The Linux host in this figure, right, as you will see, is about to undergo a Metasploit test. Exploitation frameworks may be extremely complicated, necessitating knowledge of a pen testing environment. And the last one is a password cracker. So to find out if the company is using weak password crackers are helpful. So some examples like Offcrack, John the Ripper, and Brutus are popular password crackers. There are also a ton of resources available online, such as dictionaries and rainbow tables. So as you will see on this illustration, it shows how John the Ripper was applied to a Linux password database. Here, the user account is listed in the first column, okay? And the output of this figure and the cracked password is listed on the second column. Okay, so therefore, so you will see here, user tech02 has chosen a strong password, which is actually just a plain text dictionary. Okay, all right. So that's the end of the lesson. In this lesson, we spoke about the following: testing methods, penetration testing, and the security tools. Again, thank you very much for watching the video. Hello, welcome to Module 2, Lesson 5 of our CASP Plus course. This lesson focuses on analyzing vulnerabilities and recommend risk mitigations, covering the following: what are application vulnerabilities, vulnerable systems and applications, and recognizing common attacks. Application vulnerabilities. So, information systems provide a variety of ways to communicate with clients and business users. We need connectivity, right, for B2B APIs or business to business APIs, public facing web application servers, and mobile devices, to name a few. Now, when implementing new systems and services, it is quite important to get rid of vulnerabilities during the design and development phase. The security of legacy applications that the company may still need to use must also be taken into account. When thinking about application vulnerabilities, it is helpful to consult industry best practices and the Open Web Application Security Project, or OWASP, right? Which is actually is a suggested resource to look at. So I provided a link here, right, just for your reference. Let's try to access this website. All right, so this is the OWASP portal, OWASP Tab 10. Here you can see all of this vulnerabilities documented in top vulnerabilities documented in OWASP. Okay, so this is the link. Now, we have a couple of slides on this one that will describe each of these application vulnerabilities, from race conditions, buffer overflows, so on and so forth, up to regression issues. So what are race conditions? So here, a stored value and its use are typically related to a race condition, also referred to as a time of check time to use, or TOC/TOU. It is a temporal vulnerability that might have unintended or undesirable effects. For instance, you said like you have like a $900 shopping cart with items in it stored by an application. the total is committed as a sales transaction by another thread or within the code module and charged to the customer account. Now, before reading in the total value, this process takes around 800 milliseconds. The customer has the ability to convert the $900 stored value to $1 in the interim. So testing of this specific flow, right, is quite challenging as well. Next are buffer overflows. So as we know, right, a value is kept in a memory buffer. By entering too many characters, an attacker can cause unwanted outcomes by targeting the memory location. The result will be an overflow where the extra byte may have access to a memory location for unauthorized processing. Like for example, if the buffer has like a 16-byte limit, but the actual data sent is for 17 bytes. A buffer overflow can also cause denial of service condition or DOS, right? Or have the intention of executing any command. Validating input within the code is a crucial task for developers. There's also what we call as integer overflows. So here, an area of memory holding a numeric value is the target of integer overflows. A value that is outside the declared range for the memory location may be accepted if the appropriate input validation checks are missing from the code. So here, errors and undesirable outcomes may result from these. Next is broken authentication. So the OWASP top 10 risks include broken authentication. So here, attackers will use a variety of techniques to target applications, including brute force password attacks, unexpired session cookies, and credential stuffing. Now, eliminating weak passwords and utilizing multi-factor authentication are two measures that could be taken to protect against these types of attacks. You can visit this specific website, right, to learn more about broken authentication. So let's try to access this one. Okay, there you go. All right, so it shows you the threat agent, security weakness, and impacts. Is it vulnerable, and how to prevent this specific vulnerability? It also shows you some samples of the attack scenarios. Okay, so this can also be found in OWASP.org. Okay, now next is insecure references. So this vulnerability, which is currently ranked number 5 in the list of web at risk categories, falls under the OWASP category of broken access control. It indicates that the user may gain access to a section of a system for which they're not authorized. It is made possible by what we call as privilege escalation and getting around access control verification or using a session ID belonging to another user. So let's visit this link. Yep, broken access control. The other one is broken authentication. This one is broken access control. Right? Just to get my pen. There. Next is poor exception handling. So here, ineffective exception handling may lead to system failures or reveal more information about the system to attackers. Imagine that an attacker attempts to log into a web portal, and after entering incorrect information in the password field, it receives the typical MySQL error message along with notification that the user's password string is incorrect. Now that they have a valid user ID, the attacker is aware of the version of the backend database application. Let's move on to the next one, security misconfiguration. So a system that offers customer-focused web application could be negatively impacted by security misconfiguration in many areas. A firewall that is improperly configured may let access through an insecure port, or the network environment may be poorly configured. When evaluating organizational security, it is important to take into account the operating system, libraries, applications, storage, and HTTP improper headers. Next is information disclosure. So here, an attacker might be able to view data that is protected by law, regulations, IP, or intellectual property, and more information is disclosed. There's just a lot of things such as unencrypted data storage, insecure protocols, weak encryption algorithms, and no encryption, to name a few, can contribute to this vulnerability. If you want to learn more about this, you can go to this specific link. Let's click on that. Okay, so that's A3 2017 sensitive data exposure. Okay, so it's the same format. Next is certificate errors. So here, it gives the ability to transport Internet Application Protocol securely is also important, right? Now, for the client-side application to trust a certificate, it must satisfy a number of requirements. So as you will see here, this illustration displays the typical fields of an X.509 certificate, right? X.509 certificate, this one. Now, for the application server to be trusted, the following conditions must be satisfied. Like the client must trust the CA or the certificate authority. The certificate subject name must be valid. The validity date must be valid. The certificate enhanced key usage field must be present, and the certificate is not on the CRL or the certificate revocation list. Right? So the certificate must also support wildcards or subject alternate names. It will be used for multiple sites. A vulnerability assessment tool will also look for all of the common vulnerabilities connected with certificates in order to evaluate the security posture of a hosted application access over SSL TLS. Okay, as you will see here, this illustration shows a website. Maybe it's an unreliable website because it doesn't have its own certificate. So that's why it's saying your connection is not private. But you can, again, if you still want to go through or access the website, you can just go to advanced and just accept that, okay, you're going to accept the risk on accessing this website. Okay. Yep. This is because the CA does not trust this specific website, or maybe they haven't, requested to be certified yet. Okay. Next is use of unsafe functions. Some development languages are just susceptible to the use of out-of-date risk function. This includes assembly, C, right? And some functions actually increase the risk of buffer overflow or other similar processes. Okay. If you want to learn more about this vulnerability, you can just go to this specific website. Oops, sorry. Click on that. There you go. Use of potentially dangerous function. You have all the associated CVEs. You're talking about some specific functions here, like strcat, string copy. I think this is string concatenate and string copy, something like that. Okay. Next are third-party libraries. So we must ensure that there are no vulnerabilities and that we are not violating any licensing restrictions when using third-party libraries. Next is dependencies. So to enable software development or deployment and error-free reliable operation, it is important to make sure that the dependencies are in place. Like for instance, a Java program depends on the availability of a Java virtual machine, and it cannot function without it. Another illustration would be a program that makes use of Google Maps, API's location services. Now that many applications rely on online services, your code will stop working if those services are discontinued. End of support or end of life, right? So when the original creator or manufacturer stops creating patches or providing support for their product, many systems will eventually reach this point. Now, you run the risk of continuing to support a weak system that hackers will know cannot be patched at this point. So one of the biggest risks to cybersecurity is EOL or end of life. Segmentation and controlled access are the mitigation strategies for these systems. And lastly are regression issues. So here a software regression bug occurs when a software component that was previously fast and responsive now appears to be slow or unresponsive. Whenever other components of the system are changed, it is important that we test every software module to make sure it is still operating. Regression testing is the name of this specific test. Okay, now let's move on to vulnerable systems and applications. Um, it's quite possible that many power plants, right, and other similar industries still use technology that was created and put in place decades ago. Not security, but availability and dependability were the primary criteria. This has been demonstrated by the weekly occurrence of new attacks on critical infrastructure. Since reliability is the primary objective, applications used in these industries may not have the necessary security controls. There are always inherent risks when thinking about web application servers because they host public facing applications and services. Okay, now let's talk about each of these in here, right, on the next few slides. First is client side and server side processing. So processing is carried out on the client side and the server side, right? Now, dynamic runtime code rather than binary files is used to carry out client-side processing. So languages like C++, Rust, and Microsoft C Sharp will be used to compile and write server-side code. Uncompiled code that is being run on a client browser should not be trusted because it is more susceptible to manipulation and can be target of code injections that send malicious changes to the web application server. Bytecode is the name for uncompiled code, whereas machine code is the name for compiled code. Interpreted code is another common term for the code that will run on the client browser and requires an interpreter to process it, such as Python and Perl. Next is JSON and REST. So APIs are actually used by web applications, right, to provide services to other devices and software over networks. The use of representational state transfer or REST architecture, which support secure TLS, which is using the HTTPS protocol, and common message formats like XML and JSON, is a well-defined standard-based strategy. JSON is a JavaScript extension. It is a compact, low-overhead mechanism that enables data transmission and archiving. It is built on key value pairs, right, where each pair consists of a field name and a value. A JSON key pair might appear something like this. So let's say you have like F name, you put Joe, right? You can also put L name, oh, Joe Black, something like that. Okay, so that's a key value pair. It's the key, there's the value. Key, value, right? Next is browser extensions. So a browser extension gives a web browser extra features. Adobe Flash is a helpful addition that enables playing media-rich content. However, once installed, it is important to keep this up to date with patches because there are numerous instances where older versions of Flash are vulnerable. The Microsoft Internet Explorer browser supports the browser extension ActiveX. Spell checkers, language translators, and location services can all be accessed within the browser, and that thank you to ActiveX, right? Now, any downloaded browser extension should have their sources verified in order to make sure that they're current and patched. Only browser extensions purchased from the Windows Store will work with the Microsoft Edge browser. As you will see, right, this illustration shows a few Microsoft Edge extensions, right? There's also policy limitations which may limit access to these extensions. Next is HTML5, the most recent version of a format that specifies how to display web document is called HTML5. To enable the rich display of web pages, it uses tags and semantics. It also permits dynamic content such as streaming media and as a result provides Adobe Flash with a rival. AJAX or asynchronous JavaScript and XML. So here, requests can be sent from the client browser to the web application server using AJAX. It can send XML requests over HTTP and use JavaScript and HTML direct object model to display the response. So when you do not need to refresh the entire page, it is helpful, right? And this technology is actually being used in Google Maps. Okay, that's AJAX. Let's go to SOAP. SOAP here, a client and a server-based web application can change information using the Simple Object Access Protocol, or SOAP, which is a standard message format based on XML. Okay. Now let's talk about recognizing the attacks. So, because systems must be accessible to customers and business users, attacks against systems and software pose a real threat. A customer-facing application server behind a firewall that can communicate with internet-based services is the typical setup for web application. So as you will see, this figure right here is a typical deployment where inputs are made. So as you will see on this illustration here, right? It depicts a typical deployment where inputs are made using a web-based forms that are run on the client browser and the outcomes are sent to the web application server. When we use secure firewalls to protect our networks, it is difficult to directly attack the internet services. Instead, the web application server is attacked. The attacker will focus his or her attacks here, and and we will concentrate on attacks that employ the model depicted in this image, right, on this section. So here's the first common attack, which is called directory traversal. So when an attacker can enter syntax that enables them to navigate the target web server's file system, this is what we call as directory traversal. This is done in order to gain access to restricted directories and files. The example string in this figure, right, this one, demonstrate an attempt to navigate through a root directory or switch to the etc folder and display the password file. Although there are no passwords saved in the example, right, we were still able to access the user account, which is in here. Cross-site scripting. So in an XSS attack or a cross-site scripting, the hacker inserts a script into a web page, which causes the script to be loaded each time the page is displayed in a user's web browser. A travel website where you can post reviews might be the target. We can see a script on this figure, right, that has been added to a website, and this will execute a script from the attacker's website. It's in here. The attacker script will steal the session cookie in the XSS example when the page is rendered in the victim's browser. Next is a cross-site request forgery, or CSRF. So when a user already has a secure HTTPS authenticated connection to a website, a CSRF or a cross-site request forgery can occur. The attacker's objective is to execute a script that would authorize a specific type of transaction. So here on this illustration, right, we're showing how to use an online banking to make a payment. So here, the victim will open the website on this image, right, and the script will deposit money into the account of another user. So if you look at the bottom right, this will show you an excerpt from the bank's customer's message that illustrates an example script at the bottom here. However, it is extremely unlikely that such an attack would be successful on a banking website though. Next are injection attacks. So the web application server that serves customers will be used as a middleman in injection attacks. The web application will route the request to the backend server after the commands have been directed at the application input fields. Now, so if we speak about XML, right? So this language is used to exchange data and facilitate communication between web application. So this is what XML does. So accessing content or changing transaction is the aim of this one. Now in LDAP, Directory services accounts can be searched for, created, or modified using LDAP command verbs. Next is Sandbox Escape. So Chrome and Edge browsers are just two examples of this technology, which allows code to run in a secure sandbox without being permitted to interact insecurely with a local operating system or file system. A flaw that allowed Chrome to run code outside of the sandbox was discovered in around 2020, November 2020. Attackers were able to use this to their advantage. In order to lessen the threat, Google updated Chrome, and security researchers who discovered the flaw were paid $20,000. Next is VM hopping. So it is possible for an attacker to access a different virtual host when VMs are hosted on the same hypervisor or are reachable through the same virtual network. If security is not properly addressed, this attack may succeed. Though the switch attacks, though through the switch, right, attacks can be started, the switch might forward packets to all ports as a result of a denial of service attack or DOS attack. VM escape. So here the attacker has exited their VM when access to underlying hypervisor is possible. The attacker may change networking device configuration, reroute traffic, or gain access to the file system. The same thing would happen if all the cabinets and racks in your physical data center were left unlocked. So with this exploit, more than 50 vulnerabilities have been identified. A vulnerability in VMware products is listed as a CVE, which enables VM escape. So the CVE number is CVE-2020-3962. Okay, the CVE-2020-3962. Next is a BGP and route hijacking. So exchange of routing data between external routers is made possible by BGP. So using IP address prefixes in AS numbers or autonomous system numbers, also using internet exchange points, which make up the majority of the ISPs exchanging routing data. IBM has like 20 IPv4 prefixes and has been given the ASN 17390. Other BGP peers will receive this information from them. Attackers might gain access to a BGP router on the internet and publish bogus routes. A DOS, or denial of service, which causes internet blackouts in some areas, is the most common result. Now, when Vodafone was attacked in April 2021, hackers were able to take control of 30,000 IP prefixes and seriously disrupting Google, Microsoft, and Cloudflare. You may visit the following URL if you want to learn more about this specific attack. So let's go to that link. Okay, so this was published by Appnik, and if you want to read through all of this details here, right, at least you will be able to understand what's the root cause and what happened here. Okay. Interception attacks. So this kind of attacks give a third-party access to our confidential information, customer records, and intellectual property. So man-in-the-middle attacks are frequently used to access the data. The user's browser is seen in this figure, right? Accessing an e-commerce application, right? So here. So before the data is sent to the router, and also before it is returned to the client browser, the attacker will have access to all of the data that is transferred between the server or between the browser and the website, because you have an attacker here in the middle. Next is the DOS and DDoS, right? So DOS attacks are directed at a service or resource where the resources are completely consumed, preventing authorized users from accessing it. A single host system is capable of launching this kind of attack. The volume of traffic can quickly increase when the attack is launched from numerous systems or endpoints. A distributed denial of service attack is a kind of attack of is a kind of a DOS attack. The attackers frequently are not aware that they are taking part in the attack. It is also possible to use compromised computers or Internet of Things or IoT devices as part of botnets. Next is social engineering. Um, so this is still a very effective attack strategy that targets different people. These actions have a good chance of being successful because many of them seem real and plausible. There's actually a couple of examples like email-based phishing, instant messaging or smishing, vishing, dumpster diving, shoulder surfing, or RFID card scheming, right? So when we have not hardened our network appliances, networks can still be targeted by these. And the last one is VLAN hopping, right? So a protected network segment or VLAN that should be securely segmented can be accessed through this exploit. Um, there are two well-known attack vectors are frequently deployed. One of them is what we call as double tagging. So here, a valid VLAN tag and a protected segment tag are both present in the attacker's two tagging VLAN frame. The receiving switch will remove the original tag from the frame before revealing a VLAN ID that corresponds to one of the supported VLANs on the switch when the frame is passed between switches across a trunk port. This is possible when ports are allowed to belong to the default VLAN because the sending switch does not check the VLAN ID. So in the face of an increase in security incident, it is very important to be watchful and be very proactive. All right, that's the end of the lesson. On this lesson, we spoke about application vulnerabilities, vulnerable systems and applications, and recognizing common attacks. Again, thank you very much for watching the videos. Hello, welcome to Module 2, Lesson 6 of our CASP Plus course. In this lesson, we're going to talk about risk mitigation, covering proactive detection, security data analytics, and preventive risk reduction. So first is proactive and detective risk reduction. So it is important to have advanced tools, methodologies, and skilled staff to secure our information systems when a company faces a large number of possible attackers and advanced threats. Because of advanced persistent threats or APTs, it's possible that we missed the earlier signs of compromised, right? And are still under attack. We must locate the sources of attacks, determine which systems may have been compromised, and formulate the best possible defenses. Teams of security experts are frequently deployed to defend against the rising quantity and complexity of assaults, both external and internal. Automation is also frequently used to assist forensic investigators. Raw log data is now routinely processed using big data approaches and machine learning. In the next slides, we're gonna look at these approaches or technologies. First is hunts, right, or threat hunting. IOC and the APT detection will be the responsibility of a hunt team. By accumulating threat intelligence, it will be possible to identify current and recent attacks as well as attacks that may have already been occurred. It is possible to apply forensics methods and have access to previously logged data. Developing measures. So we may use this knowledge to create better defenses once security specialists have identified tactics, methods, and procedures. Blocking known uh, malicious IP addresses, updating network intrusion prevention rules, creating remote triggered black hole rules, and taking several more remedies are all examples of countermeasures. Next is deceptive technologies. Technologies and methods are available that can be utilized to obtain insightful threat information while delaying or diverting attackers. The following methods are included in this, like honeynet, honeypot, and decoy files. So what are these? Honeynet, right, is a group of programs and services that have been set up to mimic a weak network. The objective will be to identify the attackers, their tools, and strategies while diverting them away from the real network. The honeynet's objective is to replicate an actual network. We can also take advantage of the capability of dynamic network settings to support changing configuration and responses to activity, since honeynets are typically deployed as virtual instances running on hypervisors. Next are honeypots. So it's a single machine, such as a weak web application server, that serves as a honeypot and has the same objective as a honeynet. And third is a decoy file. So the location of attackers and both internal and external threats can be determined using the decoy file. The creation of a file such as password.doc, right, would be the interest to the attacker. When the file is opened, a secret image that was contained in it will be accessible via the web server. All access, including the IP address of the machine that opened the file, will be recorded, and the beacon would result from these. Okay, now let's talk about security data analytics. So it's also important to have the ability to gather intelligence through the examination of logs and other forms of data. We can eliminate the irrelevant data and focus on the pertinent data by studying data flows and data contents. Processing pipeline. So here, raw data is read or captured, processed, and output is stored in data lakes or warehouses for later analysis. We may employ AI or artificial intelligence and machine learning to better defend information systems when we use this technology to integrate automation into our security. At the beginning of the process, the data is unstructured and raw. The processing pipeline steps are depicted on this specific illustration. So this image describes the following steps. Like first is the data capture or capturing of data. So here, raw data can be obtained from historical records or real-time data streams. Next is processing of data. So here, formatting a variety of data, types of data into a format that may be used, store data, So a data lake is a common form of storage and it remains unprocessed data. And next is analyze data. At this point, we try to interpret all of the collected data, and the last one is use data, right? So which makes use of the data to create security appliance rules. On the next subsections, we covered the methods for maximizing the utilization of enormous data sets. So that one is about indexing and search, right? So when storing vast amounts of data, it is crucial to have quick access to the necessary information regardless of the file type. Similar to an index in a book, right, or a table of contents in a report, we may add keywords to an index that provides fast search capabilities in order to expedite the process. Microsoft operating systems have an indexing service for rapid file system searches. As you will see, on this illustration shows the Microsoft indexing service. Here, large data repositories can be indexed for efficient searches. Okay. Next is log collection and curation. So raw logs serve as the foundation for thorough audits and additional analysis. It's critical to remove the background noise and highlight the most pertinent data for additional investigation. Like in a museum, right? A curator will do something similar to make sure that the audience or visitors are shown engaging items to view. To ensure that the analysis is concentrated on the important events, log curation is crucial. Next is database activity monitoring. So here, your database applications are protected by the Database Activity Monitoring, or DAM, which is an additional security measure. To safeguard crucial data kept in transaction-based databases, this can offer more granular rules and enforcement policies. DAM may watch over traffic passed to the database application, memory-based operations, and database logs. Now, when thinking about regulatory compliance, these tools added reporting and protection can be very helpful. Now, let's talk about preventative risk reduction. So, we shall try to employ preventative measures, right, whenever possible, to safeguard our data and information systems. We may build on a strong foundation provided by preventative technologies. A standard operating environment will typically provide various security advantages. We're able to release operating system images with the help of SOE, which can then be further improved with new security add-ons after being compared to a baseline. Now, we shall examine several preventative technologies on this specific lesson. First is antivirus, right? So tools for antivirus protection are crucial preventative measures. They can be installed on network gateways as well as end devices. Like for example, we can include next-gen firewalls and the unified threat management devices. The most recent antivirus solutions will employ centralized control and monitoring, heuristic analysis, and smart detection approaches. Next are immutable systems. Immutable systems make it simple to deploy systems from a verified image. There's a strict version control that is required, and updates and patches can be approved after being tested in a non-production environment if a change is necessary. Production images can then be changed after the build image has been developed and given a specific version number. It is less likely that we will have systems that do not conform to a tight security posture when we use this kind of procedure. Next is hardening. So there should be like a checklist or a baseline to guarantee that just the necessary apps and services are available in order to ensure that systems and services are protected when in use. We can reduce our security footprint by using this strategy. We can reduce the danger of service or listening port compromise by turning off or uninstalling new services and programs. Tools for baseline configuration compliance and vendor hardening can be quite helpful. As you will see, this illustration displays a Red Hat Linux 7 configuration compliance check, and this will enable remediation to enforce the specific configuration. Sandbox detonation. So the safest technique to determine an unknown file's purpose or logic, if it cannot be verified as real, is to watch the behaviors in a safe environment where there won't be any negative effects on other systems. The study will make it possible to identify the behaviors of file scripts, macros, and URLs. The sandbox will separate access to the hardware whilst simulating the operating system. As you will see, as seen here, right, we have Microsoft Windows 10 features as a secure sandbox. Other example here, right, includes cloud-based programs that automatically scan dangerous data. Next is application control or application management. Now, by making sure we limit the programs that are installed to a set that is considered safe and vulnerability free, we can protect networks and information systems. Any apps utilized by the company must have appropriate software licensing. So, in terms of technology licenses, right, so in large firms with numerous facilities, business units, and devices, licensing might become very complicated. The availability and usage of licenses should be subject to international regulation. It is important to avoid unforeseen licensing fees or legal measures. To guarantee that we're compliant, a variety of technologies are available to give the right information and reporting. There's also another one here, like comparing allowed list versus block lists. So using application whitelisting or application block listing, we may manage the code that can be downloaded and run. Microsoft Group Policy, third-party solutions, and mobile application management can all be used to accomplish this. So in terms of the options, right? If you look at this illustration here, this shows you the options for the Microsoft Application Control Policy. Okay. Next is a security automation. So it might be difficult to handle a diversified, heterogeneous environment with large, complex companies while yet maintaining a solid security posture. It is usual for a business to support a variety of operating systems, including Windows, Linux, Unix, and specialized ones. And we must consider automating security activities in order to maintain a secure, reliable environment. So, as an example, right, in on Linux systems, cron is a commonly used tool for task automation. The internal job scheduler is what it is, right? And this illustration shows the default cron tab file located in the etc directory, which contains the setup for the jobs. And last is physical security. Of course, we must ensure that we have defense in depth if we want to guarantee that our firm is completely secured from all, risks and dangers, including actual physical threat actors. Information systems may be hosted by other parties, our own managed data centers, or cloud service provider. There are audits that can be carried out to make sure we adhere to the expected legislative and industry requirements for security. There are acknowledged international standards for data center security planning, such as ANSI TIA 942, which is developed by American National Standards Institute and the Telecommunication Industry Association, or TIA. Physical security measures are the main emphasis of this standard. Physical security measures must meet the particular specifications under the regulatory compliance standards such as Sarbanes-Oxley Act and the PCI DSS standard. A compliance audit that focuses on the controls used by the service firms is known as SSAE 16, or the Statement on Standards for Attestation Engagement number 16. So of course, right, the following must be considered, like you have to review the lighting, review of visitor logs, and also the camera views if you have CCTVs, right? There. Okay, that's the end of the lesson. Here we spoke about the proactive detection, security data analytics, and preventative risk reduction. Thank you very much for watching the video. Hello, welcome to Modules 2, Lesson 7 of our CASP Plus course. This lesson is going to focus on incident response, covering the following topics, like incident response planning, incident response processes, and the response methods. So any size of firm needs to have an efficient incident response plan for cybersecurity. It can be a legal necessity for regulated sectors to have adequate strategies and procedures in place to lessen the harm brought on by any security related incidents. For government agencies and contractors, FISMA, or the Federal Information Security Management Act, places very rigorous requirements on the existence of suitable strategies. These specifications giving the U.S. Computer Emergency Readiness Team, or USCRT, at least 2 points of contact for reporting needs. Effective incident response planning is provided for federal agencies and commercial companies in the NIST SP 861 Publication Computer Security Incident Handling Guide. It's critical to identify team members, team leaders, and an escalation mechanism while creating a strategy. Since we cannot forecast when an incident will happen, it is important to make sure that the staff is ready around the clock. Participation of stakeholders is crucial during plan development. Working with business units like human resources and consuming with legal counsel will be crucial since they may provide advice on the viability of the plan for disciplining employees. The NIST SP 800-61 documentation, which is accessible at this specific website, right, provides extensive recommendations on these. So let's access this link. Okay, right. So you can just download this PDF file on that specific website. So another thing to consider is event classification. So there's actually numerous techniques for locating suspicious or harmful events, and we can benefit from automated tools such as SIEM or IDSs. In order to spot threats early, we can also rely on manual detection and effective security awareness training of our workers. First responders and service desk technician can both be proficient at spotting harmful activity. The U.S. Department of Homeland Security created the Common Attack Pattern Enumeration and Classification, or CAPAC, CAPEC, right? So this means Common Attack Pattern Enumeration and Classification. It is used to offer the public a database of known attack patterns. There are numerous references for various attack vectors and can be found through this specific database. So let's access this link just to show you what it has. Okay, latest version, reports, archive. There you go. Yep, you can just download all of this, right? Okay. Next, triage event. It's also important to evaluate the nature and gravity of the occurrence that has taken place. The effort that has been done to determine what has transpired can be viewed as triage. This phrase is taken from a triage process used in ERs, or emergency rooms, to decide what has to be corrected for a patient. This makes it possible to decide on the team members who must respond as well as the suitable response to the urgency. Understanding the systems that are essential to business operations is vital because they must be given priority. If a business impact analysis, or BIA, right, has been conducted, this information is typically available. Mission critical services and their significance to the organization will be identified by BIA. It is crucial to avoid focusing on the first come first serve principle because there will only be a limited amount of resources available to handle the problem. Okay? Now let's talk about the incident response processes. So there's actually six unique phases that make up the incident response procedure. Each of these steps is critical and needs to be finished before continuing. These separate phases are depicted on this image, right, which contains preparation, detection, analysis, containment, eradication, and recovery, and the lessons learned documentation. All right. Now let's talk about each of these phases. on the next few slides. First one is preparation, right? So to ensure a solid security posture is in place while preparing for an IRP or incident response planning, it is a good practice to harden systems and remediate security vulnerabilities. It is difficult to strengthen the enterprise's resilience during the planning stage by concentrating on all the likely attack vectors. The following are some of the things that should be completed to get your business ready for attacks, like perform risk assessments, harden host systems, secure networks, deploy anti-malwares, and implement user awareness training. It is crucial to recognize typical attack vectors, even though it is nearly difficult to anticipate every potential attack vector. Common ones can be listed and included in playbooks. Some such attack paths are shown. Um, so we must have the tools to identify security issues, even though the preparatory phase will improve our security posture. Next is detection. So here, we need to find abnormal activity in order to respond to a security problem. Unauthorized software, external media email attachment, and denial of service attacks, equipment theft, and impersonation are just few examples of the different attack vectors that can be employed. So we need to be able to recognize fresh and developing threats. IDP, SIEM, antivirus, anti-spam, FIM software or file integrity monitoring software, DLP technologies, data loss prevention technologies, and third-party monitoring services are examples of common techniques. So unusual activity can also be found using logs from important services and network flows like NetFlow and SFlow. And when responding to user calls, first responders like service desk technicians might also be able to confirm IOCs or indicators of compromise. When such security-related incidents are discovered, we must investigate the situation to formulate a reaction. Next is analysis. Of course, right? Not all security events or automatic alerts that are reported are malicious. Unexpected user behavior or mistakes could lead to erroneous reporting. And at this point, it's important to rule out typical or malevolent events. When a security-related event is reported erroneously, it may lead to false positives, where this is where an event is treated as malicious or threatening activity but turns out it's benign, and also false negatives, and this is when a malicious event is considered non-threatening and no subsequent action is taken when there's really a threat, right? So this false false positive and false negative. So the right diagnosis should be reached when the proper instruments and investigative procedures are used, leading to the following, like true positives. This one. So this means that an event has been identified as malicious and the appropriate action can be taken. And the true negatives. So this means that an event has been correctly identified as non-threatening and no remedial action needs to be taken. All right, so issue tracking systems, which should be easily accessible to IRT members, should be used to record the incident response procedure. Information that should be included in this application database is depicted in this specific image. Right? Next is containment. So for various incidents, right, containment techniques must be developed. When a crypto malware assault or attack or quickly propagating worm occurs, the appropriate course of action is often to quickly isolate the compromised systems or network section. The strategy may involve establishing a remote triggered black hole or RTBH or collaborating with an ISP that provides DDoS mitigation services if the attack is a DOS or DDoS conducted against internet facing application servers. So in this figure, right, it illustrates the factors to take into account when formulating containment strategies. Some containment tactics may entail conducting more investigation of an attack while keeping activity contained within a sandbox. Next is eradication and recovery. So before the recovery procedure can start after the incident has been contained, it might be required to remove harmful software or accounts. Hardware replacement, software configuration, and backup restoration may all be necessary for recovery. Access to documentation such as implementation manuals, configuration manuals, and hardening checklist is crucial. Usually, the disaster recovery plan contains this information, or the DRP. And the last one is lessons learned. So after the after action report, which enables process involvement, is a crucial component of the incident response procedure. At this point, it's important to discuss what went well or poorly. Within days of the incident, the team should complete this portion of the exercise. As you will see here, right, this figure, right, that allows outline some of the problems that could result from an exercise in lessons learned. So lessons learned will help us determine what IRP enhancements is going to be required. All right. And next is our response methods. So it's also critical to prepare for as many potential outcomes as you can. Ransomware, data exfiltration, social engineering, and DDoS are just a few examples of typical scenarios. An organization can use a variety of resources to get ready for common circumstances. NIST, for instance, documents various incident handling scenarios in an appendix of to NIST SP 800-61. Okay, so here we will need to develop both human and automatic answers when thinking about reaction actions. So there's actually two types, by the way, of response method, right? The non-automated and the automated. So let's talk about the non-automated first. So clear documentation including CMDB, network diagrams, escalation procedures, and contact list should be included if manual intervention is necessary. All the activities must be recorded and documented if the incident type has never been seen before in order to establish a playbook for the future. So in terms of playbooks, by providing security experts with a set of tests and procedures to go through common security situations, playbooks can be utilized to respond to an event. This can greatly speed up reaction times and help keep the crisis under control. A playbook designed to assist in handling a malware issue is depicted in this specific illustration. Playbooks are highly helpful since they offer a step-by-step list of procedures for dealing with common incident scenarios. Now let's talk about an automated method called SOAR, or Security Orchestration and Response. So an organization can discover dangers, right, or risk using advanced detection techniques with the help of SOAR and then employ orchestration to counter them. We can quickly find IOCs or indicators of compromise and set up a reaction or response using tools like SIEM. Runbooks may be used for semi-automation in the response, or it may be entirely automated. Using visual tools and scripts, orchestration enables the definition of complicated activities. As you will see here on this diagram, right, it shows the workflow of an SOAR. So currently a variety of vendor solutions are available to coordinate security responses. Let's talk about the last topic, which is communication plan. So effective stakeholder management requires a communication plan. Numerous external entities may need to interface with the incident response team, so it's crucial to list them all in the IRP. So in this image displays a few instances of this gathering, of what we gathered, right? It is crucial to think through an organization's public relations strategy before the necessity to deal with reporting to news outlets occurs. Rules of engagement should be set. Investigative tools are required for incident response in order to determine whether an incident is actually occurring and to gather data for legal response. Computer forensics will be utilized in the methods and tools that are employed. Okay, so this is our communication plan. All right, that's the end of the lesson. In this lesson, we spoke about IRP, or incident response planning, incident response processes, and the response methods. Okay, Again, thank you very much for watching the video. Hello, welcome to Module 2, Lesson 8 of our CASP Plus course. This lesson is going to focus on forensic concepts covering the following: forensic process, chain of custody, order volatility, memory snapshots, images, evidence preservation, crypt analysis, and steg analysis. So just to give you some background, right? So an organization needs to be ready to use computer forensics for both internal corporate goals and legal inquiries. Understanding whether outside agencies or law enforcement are required will be crucial when taking various scenarios into account. Internal workers should have the necessary trainings and equipment if the investigation is to be carried out by the system. So NIST, let me put it here, NIST SP 800-86. How about that? Yeah. It provides the instructions for incorporating forensic methods into incident response. So you can go to Google and search for this NIST to get more information about it. So the first concept is the forensic process. So it's important to follow the proper forensic procedure. So as you will see, this illustration, right, or this diagram illustrates 4 steps that can be taken to accomplish this. The list that follows includes these 4 steps, and later in the lesson we'll go into greater depth into the tools that needs to be deployed. Number 1 is collection or data gathering. So this entails determining the data sources and the viability of the data access. So, for example, a court order could be necessary to obtain access to data that is kept outside of the organization. If the result is going to be a legal process, it is important to apply validated forensic tools and methods. Number 2 is examination. So here, we can review the raw data after we have collected the data. We may filter out the logs and messages that are not important from such data, which may include large log files or thousands of emails from messaging services. Number 3 is analysis. So data analysis can be used to correlate events and patterns in the data. The log data can be searched through, and IOCs can be found using automated methods. And number 4 is reporting. So here, decisions regarding the appropriate course of action will be determined at the reporting phase. To build a case in court, law enforcement will require specific proof. To create a business response, senior management will need reports in a format that is more business-oriented. So to avoid missing key evidence, it is crucial to follow stringent forensic processes, such as the sequence of volatility. As evidence is gathered, a chain of custody should also be established. Next concept is chain of custody. So when the evidence is gathered, a chain of custody form needs to be filled out. The location and method of the evidence acquisition should be properly documented. Documentary evidence that outlines the transaction must be made when the evidence changed hands. A common chain of custody form is shown in this specific illustration, right? So a legal or disciplinary procedure could be challenging without these important documents. Next concept is the order of volatility. So it's crucial to adhere to guidelines and best practices when doing computer forensics. Failure to do so could lead to insufficient or inadmissible evidence. The Internet Engineering Task Force or IETF standard for gathering information that will be utilized to look into data breaches or present proof of IOCs is RFC 3227. RFC 3227. So while archived media is long term and is kept on paper, like a backup tape or storage. Volatile data is kept in a CPU cache that contains data that is continuously rewritten. Some of the storage areas that require attention are shown in this specific screenshot, right? So to collect this data, specialized forensic tools will be needed. It's also important to consider the order in which precautions are taken to protect the evidence. The nature of the memory will change if hibernation or sleep mode is allowed, and forensic artifacts may disappear as a result. Now, this illustration here on the right side is what we call as the order of the volatility, right? So this order must be followed because failing to do so will probably result in missing evidence. The order of the list is top down, so starting from here down, right? With archived media being the least volatile, and registers and caches in here being the most volatile, right? So let's examine several popular methods that we might employ to gather this information. So for that, we need to talk about memory snapshots. Forensic investigators can look for artifacts loaded into by using memory snapshots. It is crucial to take into account volatile memory as a possible abnormal behavior that may be discovered but it's not recorded in storage or logs. Next is the images. So the original image or disk cannot be used by investigators to examine information systems while searching for forensic artifacts, as it will be stored securely as the control copy. Allocated space, unallocated space, free, and slack space must all be identically copied bit by bit in the picture or in the image, sorry. Next is the evidence preservation. So once the evidence has been gathered, it is important to keep the chain of custody intact and store the evidence in a secure area. It is necessary for us to show that the evidence hasn't been tampered with. Now, to generate a reliable checksum, the files or images are hashed. To preserve the evidence, logs can be stored on what we call as warm media, or the write once, read many media. Next is script analysis. So it's possible that cryptography was used to conceal evidence or to make ransomware attack file systems unreadable. So in this situation, cryptanalysis may be performed to identify the methods utilized as well as the most likely attacker. And the last one is steg analysis. So here, information can be concealed using a technique called steganography, which is inside another file and sometimes known as the carrier file. The technology that is utilized to find hidden payloads in carrier files is called steg analysis. So digital pictures or digital picture files like JPEGs are frequently utilized to conceal text-based data. The pixels in an image can get distorted when text is concealed within a compressed digital image file. The steg analysis tool then finds these distortions. Okay? All right, that's the end of the lesson. It's a short one. So here we cover the following: forensic process, chain of custody, order of volatility, memory snapshots, images, evidence preservation, crypt analysis, and steg analysis. All right, thank you very much for watching the video. Hello, welcome to Module 2, Lesson 9 of our CASP Plus course. On this lesson, we're going to talk about forensic analysis tools covering the following topics, like file carving tools, binary analysis tools, imaging tools, hashing utilities, and live collection versus post-mortem tools. So, just an introduction, we must put together a forensic toolkit now that we have solid understanding of many types of evidence that can be gathered and the analysis that can be carried out. We must make sure that the instruments we employ are acknowledged as legitimate tools and that they are applied properly. Like, for instance, a bit by bit copying program is required to take a forensic picture of a storage device. When preparing images or templates for an operating system distribution, we wouldn't utilize the same tool. So, in this lesson, we're going to talk about some typical forensic analysis tools. So first is a file carving tool. So these tools allow a forensic investigator to search a live system or forensic image or hidden or deleted files while fragments and their with uh, with file fragments and their contents. Their two tools are suitable for this process, which is shown as follows: the foremost and the strings. So for the foremost, so the ability to recover certain file types from the file system after they have been erased is provided by first file fragments in a wide range of forms, such as documents, graphic formats, and binary files, will all be searched for. It can recover deleted files from a forensic image or the live file system. So as you will see on the screenshot, right, it shows, um, so the following screenshot here shows the help for the foremost command. Okay, so now here's also an example using the foremost command. So in this example, we're searching the fixed drive for the .pdf and the PNG file types. Let's talk about the strings. So this is also a helpful forensics tool for looking for ASCII or Unicode strings in picture files or memory dumps. Most Linux distribution comes with this built-in tool. The following screenshot shows the options for the strings command right here. Now, in this example, we're searching with a binary file where we need to see if there are any embedded copyright strings. We are using the strings command to search for all the strings within Python 3 and piping the output to the grep command to only display strings containing copyright characters. Now let's talk about binary analysis tools. So the information and the logic employed in binary files can be found using a variety of tools in the forensic toolset. Since the source code for these files has been compiled, we're unable to study them. Instead, we must utilize analysis tools to look for references to other code modules and libraries. We can also dissect the logic of binary files using reverse engineering methods. There are numerous binary analysis tools, for example, some of which we'll explore right away. So here is a hex dump. So in here, we can access and examine the data kept in flash memory by using the hex dump. When we need to extract data from a smartphone or other mobile devices, it is frequently used. A link between the mobile device and the forensics workstation will be necessary. A hex dump may potentially show previously deleted information, including an overwritten SMS messages contacts and saved photographs. Next is a binwalk, because it will search binary images for embedded files and executable code. Binwalk is a helpful tool in computer forensics. The tool's output can be saved in a folder or for later analysis after use. Additionally, it can be used to compare files for shared components. So, in a recently found suspicious file, we might be able to find signatures from a known malicious file. The payload's contents and offsets in decimal and hex will be shown in the output. So here, right, in this screenshot, it shows the output of a binwalk command. Okay. Next is a GIDRA. The National Security Agency created GIDRA as a tool for reverse engineering. It consists of software analysis tools with reverse engineering capabilities for compiled code. It is a strong tool that supports numerous widely used operating system platforms and may be automated. It is made to look for harmful processes hidden within the binary files. Next is GDB, or the GNU Project Debugger. So when running compiled code, developers can identify incorrect errors and thanks to debugging tools. Information about programming errors that lead to unexpected results or make code unresponsive can be useful. Other running code modules that can compromise the stability of your code can also be displayed by debuggers. GDB is compatible with several popular operating systems and supports popular programming languages. Next is OllyDBG. So OllyDBG is yet another well-liked reverse engineering tool. It can be used for virus analysis as well as troubleshooting built code for developers. By breaking the software code, attackers may potentially utilize OllyDBG to steal intellectual property or IP. Now let's look at more analysis tools. So forensic toolkits are comprised of tools that can analyze file systems, metadata, running operating systems, and file systems. And we need advanced tools to detect the APTs and IOCs that are hidden within our information systems. Let's look at some of the examples. So first one is the XIF tool. So we will require a particular analysis tool in order to see or update a file's metadata. JPEG, MPEG, MP4, and many other well-known image and media formats are among the many image formats that XIF tool supports. To extract metadata from a picture that has been downloaded from a website, you can use a specific command called like this one, XIF tool nasa.jpg, right? So if you run that, this will be the output, right? So this information is actually very interesting as it displays details of the photographer, swan, right? And their location and many other details, right here. Nmap, operating system and services can be fingerprinted during analysis using Nmap. This will make it easier for security experts to identify the specific versions of the hosted services, such as DNS, SMTP, SQL, and others, as well as the operating system's build version. Next is AirCrackNG. So we can use AirCrackNG to evaluate the wireless network security. So with this program, you may attack using packet injection and decrypt WEP and WPA pre-shared keys while also keeping an eye on wireless traffic. Volatility to locate memory resident artifacts during forensic examination. The volatility tool is deployed. The majority of popular 32-bit and 64-bit operating systems, including Windows, Linux, and macOS and Android, are supported. So if the information is in the form of a Windows crash dump, a hibernation file, or a virtual machine snapshot, it is very helpful. Next is SleuthKit. So this utility is a suite of applications used to examine forensic photos via the command line. Typically, it is included in graphical forensic toolkits like Autopsy. Imaging tools like DD will be used for the forensic capture. SleuthKit may be used with both static images and live operating systems because it supports dynamically linked storage. It can be helpful as a real-time tool when dynamically coupled to operating system disks, such as when responding to issues. Now let's talk about imaging tools. One of the main objectives when choosing imaging tools for forensic investigation is to select a tool that will be accepted when presenting evidence to a court. Additional tools such as hardware write blocker are essential because not all imaging techniques ensure that the original will be fully unharmed during the imaging process. When there comes time to present the evidence in a court of law, the following tools are frequently used. First is the FTK, or the Forensic Toolkit Imager. So Windows operating systems provide a simple-to-use graphical utility called the FTK Imager. It has the ability to produce photos in common formats as EO1, SMART, and DD RAW. It enables hashing of image files, which is crucial for integrity, and also keeps a log of the entire imaging procedure. Next is the DD command. Numerous Linux distributions provide the DD command as a built-in feature. It is sometimes referred to as a disk dump or a data duplicator. Although the utility allowed for the acquisition of memory dumps on earlier versions of Linux, it is not possible to capture a full dump of memory on a contemporary distribution. So as you will see here, the command is formatted as follows, right? Like Now let's talk about hashing utilities. So it is also important to utilize hashing tools when working with files and images so that we can recognize files or images that have been modified from the original. A hash is a data piece checksum. So before cloning, we can use a hash value to record the present state of an image, and then we can hash the cloned image to confirm that it is the same. A database of well-known hashes for our operating system and application software can be used in forensic analysis to find any anomalies. Operating systems come with a variety of hashing tools as well. Most Linux distribution contains um, shaky length sum, which enables the checksum of a file to be recalculated using SHA-160, 224, 256, 384, and 512. Then for the Linux rep command, a SHA-256 is calculated in the sample below. Let's talk about live collections versus post-mortem tools. So to capture information that will be lost or overwritten, we must strictly adhere to the order of volatility criteria during forensic analysis, right? Now, after the data has been logged or recorded, we can use a variety of tools to evaluate and investigate it. So for both local and remote network interfaces, NetStat enables enables the creation of live report on listening ports, connected ports, and the status of connection. There's also a NetStat option, like options, then file name syntax can be used to pipe this output to a file if we need to save it for later examination. The output of the netstat command is displayed. So here are some popular utilities, right? Um, First is a netcat. So installing netcat will allow us to run commands on a distant machine, right, or remote machine. To grant attackers remote access, netcat can be started as a listener or on a compromised computer. Additionally, it can be used in forensics to collect data with a negligible impact on the systems under scrutiny. On the machine under examination, we can enter the following command to set up a listening port. Next is Wireshark. Wireshark is one of the most well-known protocol analyzer. It has a wide range of operating system platforms and offers a graphical user interface to security professionals. Wireshark allows us to record data in real time so that we may learn about typical traffic patterns and protocols. Additionally, we can load packet capture files for in-depth investigation. It also has a T-Shark command line counterpart. Using Wireshark, the following screenshot displays a packet capture. It's in here. So the exhibited packets in the sample has been filtered to only include DNS specific or DNS protocol activity. Okay. All right. I think that's the end of the lesson. In this lesson, we spoke about the following: file carving tools, binary analysis tools, imaging tools, hashing utilities, live collection versus post-mortem tools. Okay. Again, thank you very much for watching the video, and this is the end of Module 2. Hello, welcome to Module 3, Lesson 1 of our CASP Plus course. This lesson in Security Engineering and Cryptography covers the following topics such as managed configurations, deployment scenarios, and security considerations for mobility management. So, implementing enterprise mobility management. There's no longer a defined enterprise boundary because the traditional network perimeter has changed. Users now access information systems from outside the company, and information systems are frequently handled by cloud providers. Deperimeterization occurs here. Mobile device security compliance is ensured via enterprise mobility management. An organization must support remote and home working environments, mobile users, and personal computers that are not subject to on-premises security measures. We must accept that the company will require this hybrid approach, but we must also comprehend the controls required to protect it from data exfiltration, theft, and loss. We should select vendor solutions that enable management of both corporate-owned and personal devices using a single enterprise toolset in order to streamline the administration of security controls. The security characteristics that need to be managed will be discussed further on this lesson. So manage configurations, right? So regardless of the vendor, the standard operating system has a wide range of configuration options. Devices that access company data will pose a security risks if these settings are not properly managed. As shown here, there are different features and setup options available for mobile device management, right? So we have a couple here like application control, password, MFA, patch repository, Bluetooth, NFC, tethering, airplane mode, and so on and so forth. So we're gonna talk about each of these right on a high level on the succeeding slides. So first, application control. Okay. So applications installed in the enterprise workspace must be under our control, right? And each one must be supported by a legitimate business need. Users have the option to download hundreds of applications when they have access to Google Play Store or the, Apple App Store or Microsoft Store. Applications frequently offer a variety of configuration options such as contacts information, access, or location data access. Now, Microsoft Group Policy Objects, right, or GPO deployment, scripts and mobile application management, or MAM, put it here, MAM tools can also be used to modify the GPOs. Okay, we can enable containerization for enterprise applications and data to provide some flexibility in our application control. Numerous vendors provide services that let a company host a specialized or constrained list of applications on a company branded portal. Now, hundreds of applications are typically available for Windows users to install on their devices. However, this can be managed with the constraint view. We can lessen our security footprint if we restrict device access to only a pre-approved subset of application store programs. Next are passwords, right? So we should enable screen locks and minimum password length at the very least, right, based on the company standards. And this is done to make sure that if the device is lost or stolen, the data on it won't be accessible. Next is MFA, or what we call as the multi-factor authentication. So passwords by themselves are not always regarded as providing sufficient security for business mobile devices. Now, using hardware tokens or mobile authenticator apps, we might decide to enable extra authentication factors like one-time passwords or what we call as OTP, right? So utilizing the built-in biometric readers on mobile devices is another helpful authentication option. Now, voice authentication, iris scanning, facial recognition, and fingerprint reading are all examples of biometric authentication. It is simpler to use smart cards for MFA because many devices have card reader functionalities. Microsoft also supports secure USB keys, which function similarly to smart cards and are another form of security token. Token-based authentication is used with USB keys and smart cards. MFA also adds an additional layer of security in situations where a password might be compromised. Next is a patch repository. So accessing the most recent patches for supported end devices and making sure they are deployed on time are crucial for providing the highest level of protection. Patch implementation issues lead to vulnerabilities that could have been avoided. A device may become non-compliant if the most recent patches are not installed, and the user might not have access to company resources until the device is updated and made compliant. Next is firmware over the air, or what we call as FOTA, right? So here, firmware updates for mobile operating systems like Apple iOS and Android should be downloaded and installed as soon as they become available. In addition to enhancing functionality, these updates also include security updates and features. It's also important to regulate this process by only allowing updates over recognized cellular networks. Next is our remote wipe option. So when a device has been reported lost or stolen, right, it is crucial to start a remote wipe process to make enterprise data unrecoverable. Due to a weak cellular or network signal, it's possible that the mobile device management agent won't receive this instruction. We might only require the corporate remote wipe option for personal devices. Next is a Wi-Fi. The majority of mobile devices connect to the internet primarily via Wi-Fi, but it is also common to use high-speed, unlimited data plans to access 4G plus and 5G cellular networks. So we should try to secure these links in both cases. Next is a device profile. So a profile containing a collection of configuration objects can be distributed to the devices to automate common settings on mobile devices. Wi-Fi, VPN, and many other settings can be found in the common profiles. Next is Bluetooth. So Bluetooth is a radio frequency that doesn't go very far. Class 2 Bluetooth, which is most common in consumer devices, sends at least 2.5 milliwatt, um, milliwatt, and has a range of about 10 meters, right? 10 meters. It lets data be sent without encryption over the air. So this means that users could join a secure web conference with a wireless headset, but a wireless listening device could be used to listen in on the conference room. In this kinds of situation, it's common to put limits on how Bluetooth can be used. Next is NFC, or what we call as near field communication. So NFC works slowly and only over short distances up to 4 cm or 4 centimeters. It can be used to send data to an NFC-enabled printer, such as configuration data or print objects. It is often used in systems like Apple Pay and Google Pay that let you pay with your phone. Once a user has unlocked a mobile device, NFC-enabled apps can send data without further confirmation from the user. This feature could lead to fraudulent payments, and it could also make it possible to send private information. Next are peripherals. So by using SD and micro SD, right, as you see here, or USB on the go or OTG, mobile devices can support specific extensibility. So due to this, USB devices can connect and transfer data. This one is actually interesting, right? Which is called as geofencing. So using GPS tracking to locate devices and restrict functionality based on the device's proximity to a site of interest is an efficient way to manage the functionality of mobile devices. Therefore, we could plot the location of a secure site and set up a geofence. We can turn off cameras and any recording features on devices when they're inside the geofence, and we can enable them again when they're outside it. If a company device is stolen, we can set up conditions so that when it leaves the geofence, all enterprise data is erased from the device. So as you will see on this figure, right, the store sends a text message to the visitor for special prices or discounts when the visitor enters the store, right? Here. Next is VPN settings. So by deploying a VPN profile to a mobile device, VPN settings can be set up. When company employees are offsite, it is important to protect the confidentiality of business information. The device will always connect through the secure VPN and thanks to an always-on profile.
By implementing a full tunnel configuration, you can make sure that all browser and application traffic is forwarded through the corporate network. All security protocols will be able to be used and thanks to this configuration. Next is geotagging. A company should think about the security of geotagging using applications. For instance, users could download a fitness app for their smartphone that automatically uploads their activity to social media along with the maps. When you look at the programs like Strava, right, or Map My Run, this is quite typical. But here you run the risk of disclosing private information about your movements or details about private places if you let other users watch your activity. Next is certificate management. So, for a number of users or for a number of uses, security certificates are frequently given to users and devices. Using what we call as 802.1x security, right? We can use certificates to get trusted across access to the network. There are actually numerous security applications, including S/MIME, um, and IPsec-based VPNs demand the use of certificates. We can use the simple certificate enrollment protocol to automate the deployment of certificate. The majority of MDM solutions support this. Users are less likely to be able to install certificates from dubious certificate authorities if we manage certificate deployment. Next is full device encryption, or FDE. So securing enterprise data kept on mobile devices is crucial, and we ought to, at the very least, make screen lock and storage encryption mandatory, including for SD cards. The data may still be accessible if the device is lost or stolen, um, or or if a password-enabled screen lock is not required. The removable storage on the mobile device should be encrypted because it might otherwise be readable when mounted on other hardware. The device must be protected from tampering so that any attempt to alter the boot process will render the data unrecoverable. Next is tethering. So users frequently use their mobile phones as a hotspot for their laptops due to the low cost of mobile data plans on cellular networks. Because the laptop can now connect to networks, there is a security risk when it is plugged into an enterprise local area network. Next is airplane mode. So here, a setting on mobile devices frequently disables all radio frequency channels, like for example, you use airplane mode. Invoking this configuration option might be beneficial when location-based security is a top concern. Radio frequency channels can be disabled to shield the device from network-based risks. Additionally, it implies that mobile device management and downloading security updates are not possible for the device. Next is location services. Location services and privacy settings are frequently linked in mobile operating systems. Content providers can offer users more personalized information if location services are enabled. Microsoft has added a feature called News and Interests to its Windows operating systems that allows devices to receive traffic updates, weather forecasts, and local news based on their location. And it's possible that you don't want this location data to be accessible to all applications. In the privacy settings of Microsoft, right, or we can limit these features. Location-based authentication can be forced with the help of location services. Now, the user and entity behavior analytics, or what we call as UEBA, right? The UEBA tool can stop erroneous attempts at authentication coming from strange places. When separate login attempts are not feasible, given the time frame and location of the attempts, impossible time travel can also be detected. And the last one on this section is the DNS over HTTPS, or DOH. So traditional domain name services, right, or traditional DNS, send requests to a designated DNS server without any security. And as a result, each request and response are sent in plain text. This could give an individual listening in on a network segment with useful information. It is possible to update configuration settings in many web browsers, including Edge and Chrome, and enabling secure TLS connections to public DOH servers. So as you will see here, right? So this figure shows the Microsoft Edge browser security options. Another option is to return the enterprise network using a secure VPN connection so that we can safely send DNS requests to enterprise DNS servers. All right, now let's talk about deployment scenarios. So when implementing mobility management, an organization may take into account a wide range of test scenarios. Costs, for instance, may be a motivating factor, and support issues may be significant. However, when implementing MDM, security and management will always take precedence. So first is bring your own device challenges. So there are a variety of issues that can arise for the organization when user access enterprise data on a personal device. The issue of which devices the organization will support is also present. In addition, there are various hardware platforms and operating system versions to support. For the purpose of storing business applications and data on the device, it is crucial to determine a secure encrypted container. In order to secure any sensitive company data, we will need to define policies. Finding MDM tools that will make it possible to manage all supported personal device types is also important. Next is our corporate-owned devices. So the operating systems and devices that best meet the needs of the organization's business can be chosen when the organization is in charge of buying the mobile devices that will be used by employees. Next is the corporate-owned personally enabled devices. It's crucial to keep business data and applications separate from personal data when a business permits users to access personal data via its devices. It must employ the same strategy to safeguard corporate-owned personally enabled devices as we do with bring your own or BYOD policies. This necessitates a division between personal and business data. MDM will be used to make sure containerization is put into practice. And the fourth one is called CYOD, or choose your own device. So enterprise users frequently have experience with a particular technology, and they will be more interested in it if the device or operating system is simple to use. The challenge for the enterprise is to give users some discretion over the devices they use while keeping the number of options on the list manageable. As a result, we will only need to provide support for a limited set of hardware and operating systems. The proliferation of devices running numerous different Android operating system versions is referred to as Android fragmentation. There have been many releases of Android operating system, right? And currently, that's version 19, or there's already 19 version at the end of 2021. The organization wants to limit the phones and operating systems that are permitted to connect to the corporate network. This will lessen the complexity of support and the security footprint. Given that most organizations place a high priority on mobility, it is important to be aware of any potential security repercussions when supporting end devices, operating systems, and applications. All right, now let's talk about security considerations for mobility management. So, when a company wants to support a mobile workforce, there are many security issues to take into account too. The variety of features and functions that devices offer could pose a risk to the organization. Right? Now let's talk about each of this one here. No? So first is the unauthorized remote activation and deactivation of devices or features. So here the user may unintentionally disable or deactivate a security feature such as a daemon supporting an anti-malware application, right? So even though many devices support a variety of security features, utilizing secure operating systems like Security Enhanced Linux or SE Linux or Security Enhanced Android, right? And MDM will help to reduce these risks. Next is encrypted and unencrypted communication. Finding a network's weakest points is essential when supporting mobility. As a result, in addition to using FDE or full device encryption, screen locks, and application whitelisting to harden the device, network communication must also be protected. Both Bluetooth use and Wi-Fi access should be limited to reputable wireless LANs. Next is a physical reconnaissance. Here. So intelligence can be gathered using mobile devices. If we permit the use of the camera, video and audio and GPS features on mobile devices, an attacker user could gather precise information about a website that could be used in an attack later. The data may have been stolen from an unsecured mobile device or may have belonged to an insider threat actor using this device. Third is personal data theft. Although protecting business data is MDM's primary goal, user privacy should also be protected. Protected held information or PHI, right? Let me put it here. PHI, PII, right? Or personally identifiable information, and other kinds of private data are examples of personal data. Next is health privacy. Numerous devices will support fitness programs that can store users' medical histories. Applications for tracking public health services are also widely used as a result of the COVID-19 pandemic. The COVID-19 status and immunization history of a citizen can both be stored in NHS or National Health Service applications in the United Kingdom. In the US, PHI would be the term used to describe this information. This kind of information must be stored securely. Now, let's talk about implications of wearable devices. Wearable technology may be capable of GPS tracking and frequently stores extensive personal data, such as blood pressure and heart rate readings. Another potential weakness is the data synchronization between the wearable device and an application running on a different operating system. NFC or low powered Bluetooth may be used by many wearable devices to transfer data. Secure data transmission can lead to the exposure of sensitive data. Now let's talk about digital forensics of collected data. As new technologies like wearable technology may be the target of attacks, it is crucial to keep forensic toolkits and techniques up to date. It is important that we have access to mobile devices' memory and storage in order to look for signs of compromise or IOC. Next is unauthorized application stores. So most mobile operating systems restrict access to sideloading applications by default. Sideloading refers to the acquisition of an installation package from unapproved sources. For instance, iOS IPA and Android APK files can be installed directly without first needing to be downloaded from an authorized online retailer. So here, an iOS device can be jailbroken, and an Android device can be rooted to get around this restriction. When you jailbreak or root a device, you are changing the vendor operating system to bypass the default, secure, and limited settings. For instance, installing apps from sources other than the Apple App Store is not possible in iOS, so installing jailbreaking software will enable users to install apps and themes that Apple has not formally endorsed. On iOS devices, sideloading is also possible with the help of developer licenses from Apple, which is currently available for $99 per year. So when you have access to the unapproved application source code, you can sideload using free Apple Store program called Xcode. Next is containerization. So segmentation must be used, right, when allowing personal use of mobile devices that will also access or store business data. On mobile devices, segmenting applications and data is known as containerization. There's a vendor-made folder called Secure Folder on Samsung devices. Both the Samsung Knox security tools and third-party MDM tools can be used to manage these. Currently, VMware AirWatch, Ivanti Mobile Iron, Microsoft Endpoint Manager, and many other applications support Knox. On Samsung 9.0 device, it's also supported. So as you will see, this figure, right, depicts the Secure Folder application. Any business-related applications and data are stored entirely apart from the user's personal space on the device. As you will see, this is the view for an Android Samsung 9.0 device. Next is the OEM, or what we call as original equipment manufacturer. So numerous cellular service provider offer their clients specialized editions of well-known operating systems and lock the mobile device to their network options. The user has more freedom to switch cellular providers by simply providing or switching the SIM card when they buy a device that isn't locked to one. The user now has the option to use any cellular operator, including those in other nations. For instance, if a business purchases a cell phone from T-Mobile, it will only permit the phones to function on T-Cellular Mobile's network. Next is a supply chain issue. So due to vendors installing default software that turned out to be malicious, there have been numerous instances of security breaches. On numerous devices running the Android operating systems, ADUPS was pre-installed. Through this software, call logs, contact lists, SMS messages, and location tracking could all be accessed secretly. And the last one is the use of an eFuse. So when preserving the integrity of a mobile device, an eFuse can be helpful. Certain circumstances will cause an eFuse to trip. An unsigned bootloader, kernel, or potentially active unsigned scripts are typically the main cause of an eFuse trip. The eFuse will stop allowing access to the secure container under these circumstances. Additionally, this changes the device security status from official to untrusted. Similar to a standard electrical fuse, an eFuse guards electronic equipment, and in this instance, it is built right into the firmware. All right, that's the end of the lesson. In this lesson, we spoke about managed configuration, deployment scenarios, and security considerations for mobility management. Thank you very much for watching the video. Hello, welcome to Module 3, Lesson 2 of our CASP Plus course. This lesson in Security Engineering and Cryptography covers the following topics such as hardening techniques, processes, mandatory access control, trustworthy computing, and compensating controls. So, hardening techniques. It is important to understand that there are numerous ways to improve a device's security posture. So, in this specific section, we're going to look into a few different hardening methods as shown here. First is removing unneeded services. Running unnecessary services on the computer systems give malicious actors such as malwares, rats, and worms more opportunities to connect. Based on the system's business requirement, we should disable these services in order to reduce the system's overall security footprint. For instance, running file and print sharing services is not necessary for a public web server that is accessible to the internet, even though it may be necessary if the server is used as an internal server for a department. Disabling unused accounts. It's also important to recognize systems or user accounts that are already installed but could pose a security risk. Guest accounts and support accounts made by vendors are two examples of potential risks. A security policy should be in place to guarantee that this process is automated. On a Windows 10 host computer, we can see which default local accounts have been disabled in this specific figure. An account should be disabled if it is no longer required for use in an information system. Next is images and templates. A customized, hardened operating system image is a good security building block that can help with the objective of putting in place a strong security posture for end devices. The Windows Secure Host baseline build image of the Windows operating system is present on networks used by the US Department of Defense. This makes sure that the deployment is secured by design. There are more than 20 or 200 specific security requirements in this case that must be turned on by default. The GitHub repository as shown here, right, contains all the tools required to build an operating system build image and verify it. Next is removing end-of-life devices. A device should be decommissioned when it is deemed unusable or when it poses an unreasonable risk to the company. Now, when moving a device, it's important to ensure that this doesn't compromise the network security posture. If it's a security device, it needs to be changed. Removing end-of-support devices. A device becomes vulnerable when it can no longer be secured by vendor support and patching. For instance, in January 2020, Microsoft stopped providing support for the Windows 7 operating system. There were 135 vulnerabilities affecting Windows 7 as of July 2021, and that's according to the CVE database, or the Common Vulnerabilities and Exposure Database. Vulnerabilities frequently go unpatched because end-of-support devices and operating systems do not offer automated patching. Next is local drive encryption. Managed FDE will offer protection for important business data in the event that mobile devices are lost or stolen. The built-in FDE option for Windows operating system is BitLocker. Next is enabling no execute, execute never bit. It is also important to check that built-in security is turned on to provide defense against this attack vector for any system hosting applications that could be susceptible to attacks against the system memory. While 64-bit Intel CPUs support execute never XN, 64-bit AMD CPUs support no execute as a security feature. These features are intended to stop code from running in memory spaces designated for data storage. Given the design, it would be challenging for an attacker to use the memory location for the execution of arbitrary commands in order to cause a buffer overflow. As you will see in this figure, it shows how data execution protection, right, security feature on Windows has this setting activated by default. All Windows services and applications on Windows servers have these settings turned on. Chips with RISC or RISC ARM processor can support the XN bit. You can visit this specific website, right, for more details about this one. Next is disabling the CPU virtualization support. The endpoint device's firmware settings are typically where you can find the setting for virtualization support. Virtual images may be launched in hypervisor if it's enabled. For the vast majority of user desktop, this is not typically necessary. If it's enabled, a user might be able to run unauthorized software on a virtual machine. Next is secured, encrypted enclaves and AMD secure memory encryption. Nowadays, a lot of processors come with built-in support for memory encryption. As a result, both the RAM's data and the CPU memory itself can be protected. Secure memory encryption, or SME, is a feature that AMD CPUs are compatible with. This generates an ephemeral key at boot time and employs AES 128-bit encryption. Most operating systems can run the feature transparently when support is enabled in the system firmware or BIOS. This support can be used by software programs to encrypt and decrypt memory pages. Next is shell restrictions. It is common to block access to the shell itself or to restrict the commands that can be accessed within the shell in order to restrict a user's access to command shell tools and utilities. It is standard procedure on Windows operating systems to restrict standard users' access to the command prompt or CMD and PowerShell interfaces. Since most of the functionality of Linux and Unix systems is accessed outside of the graphical user interface, this is not really an option for those systems. Bash and Corn Shell are two frequently used shells on Linux. So here on this figure, right, we have created a new user account with a restricted shell by using the -s switch command. The restricted shell only supports a small set of commands. The user is unable to execute any commands found in other directories or access robust administrator tools. And the last one is address space layout randomization or ASLR. Right? ASLR. So the ASLR technique is intended to defend computer systems from memory-related attacks. By turning on this feature, it stops an attacker from being able to anticipate where applications will be located using memory addressing. An attacker might, for instance, try to use a buffer overflow attack and then make a call to a memory location where they believe a shell is running. The kind of attack is mitigated by ASLR because it always assigns random memory locations to the running applications. Here on this figure, right, you can see the default setting for a Windows 10 client here, right, for ASLR. The majority of operating systems include Linux, Windows, and Mac OS support this specific feature. Okay. Now let's go to processes. So there are two types, right? Patching and firmware that we have to discuss. And actually, the third one is logging and monitoring, but it's behind this image. But let's focus on patching first. So all of our assets must be identified, right? And we must make sure that automated device patching is enabled. We run the risk of vulnerabilities resulting in data loss or possible availability issues if we can't deploy vendor patches. Now, to prevent the possibility of these disruptions and availability problems, patching should be planned. Before implementing operating system or software application patches in a live environment, it is ideal to thoroughly test their effects in a test staging environment. And it is important to select patch management tools that support diverse environments. You can visit this specific link for more information about the Manage Engine product. Next is firmware. So the embedded operating system code must be updated because if it is not if it is not, it may be open to attacks. For instance, SIP or the Session Initiation Protocol of Cisco iOS has a number of vulnerabilities that could be exploited to cause a denial of service condition. the SIP. A cybersecurity flaw described in CVE 2008-3799 allows an attack to result in a memory leak which eventually causes resource depletion. SIP is a calling protocol that is used with VoIP to connect to another subscriber. Due to the widespread adoption of this technology in business-based telephony solution, it is important to protect this important functionality. Next is logging and monitoring endpoint devices. Security professionals can be informed of any anomalous activities involving endpoint devices and any discrepancies in configuration changes, and thanks to the ongoing monitoring of endpoint devices. The Managed Engine MDM platform, as shown in this figure, displays the health status of the endpoint devices it is monitoring, right? So it is important to receive notifications when malware has been installed on a device when security regulations are not followed. Now let's talk about mandatory access control. Our first topic is SE Linux. SE Linux was initially created as a collection of patches for the Linux operating systems that added security modules. It was initially created by the NSA, or the National Security Agency of the United States, but it is now open source. The majority of Linux distributions include it, due to discretionary access control, or DAC, which is used by the majority of operating systems. The owner of a file or folder has the ability to set or modify its permissions. The root account typically has the ability to alter permissions on other user files and folders, but SE Linux enforces MAC. So doing so will not be effective as the system will override these changes. Next is Android Security Enhanced Linux. By integrating SE Linux into the Android mobile operating system, the Android operating system adds security extensions, which is sometimes referred to as SE Android. It uses the same security model as SE Linux and was incorporated into Android version 4.4. There are actually many security controls available, and one of which is preventing unauthorized use of privileged services and daemons. Applications must be run in a sandbox, and a policy extension is available to impose further limitations. Although the kernel provides most of the security, middleware mandatory access control enables the assignment of application privileges both during installation and during runtime. The enforcing mode is the default setting for SE Android. In order to securely store measurements or certificates, many additional security upgrades for SE Android rely on hardware support. Now let's talk about trustworthy computing. So the first one is Trusted Platform Module Technology, or TPM, the TPM module. A specific hardware security module, or HSM, known as the Trusted Platform Module, is built into many system boards. This secure module offers secure measurement or value storage in addition to having the ability to process cryptography. The TPM standard is supported by a large number of hardware and software vendors and is recognized, it's actually a recognized standard. A TPM is frequently used to guarantee the platform integrity of an operating system. If the recorded values for Microsoft BitLocker are inconsistent at boot time, the boot process will halt, right? So, platform configuration registers, or PCRs, are the names given to the values that are stored, and about 6 of these PCRs are typically used to confirm that the platform has not been tampered with. Some of the typical values that can be stored are shown on this specific figure. So a cryptographic hash of these values is kept on file. Other value types that can be stored include software application versions. Now let's talk about secure boot. So here, checking the integrity of the bootloader required to run the installed operating system has become standard practice to ensure the integrity of operating systems. This feature has been supported by Windows operating systems starting with Windows 8.0. It is necessary for this to have a supported firmware interface that has a preloaded security key. The boot files are validated during the boot process after being signed with the preloaded key. Secure boot is turned on by default in computers that come pre-installed with Windows 10. This figure shows the components required for a secure boot. To add support for Linux Secure Boot, we would need to ensure there is a signed Linux bootloader. To do this, we could add the operating system's vendor public key into the UEFI. And then let's talk about what UEFI is. So since 2008 release of Windows 8.0, UEFI has been accepted firmware to support PISA systems. In comparison to the BIOS, right, or the basic input-output system, it has a number of benefits such as a mouse-driven graphical environment. System evaluations and security processing can be done before the operating system is launched thanks to UEFI. When operating systems are installed on SSDs or solid-state drives, they launch quickly, making it challenging to press the right function key quickly enough to access the menu. The Windows Advanced Recovery Options menu in the operating system is a common way to access the UEFI settings. The Windows menu used to access the UEFI settings is displayed on this figure. Next is BIOS protection. So since the 80s, right, the BIOS component has been a requirement for computer systems. It permits the CMOS, or the complementary metal oxide semiconductor, which requires a power source or battery to retain settings to be configured and to perform a series of power-on self-tests or posts. Apart from allowing for password protection of the BIOS setting, it doesn't offer much in the way of security. Next is attestation services. Secure values can be transmitted from a hardware device to an attestation service using attestation services. Within the Azure Cloud Services, Microsoft offers a service known as Host Attestation Service. The host DPM can be used to store values that cannot be altered after a device has been registered. Making sure that debugging tools are not being used by host operating systems as part of the host operating system is one example of how to use this service. This is due to the possibility that debugging tools could give hackers access to the local system's memory and consequently to private information. Next is HSM, or hardware security modules. So an independent hardware device that supports crypto processing capabilities and the safe storage of encryption keys is known as HSM, or the hardware security module. When hosting applications that require access to priceless private keys, this can be a useful security requirement. Websites for banks and e-commerce will typically need to use HSMs. The majority of implementations allow for the safe storage of server keys inside the data center and are rack-mounted applications. Next is measured boot. So PCR results from the TPM can be verified with measured boot, right? Cryptographic hashes of the values themselves are kept on file. A number of values can be combined into a single hash value because the hashes are organized into a blockchain. As you will see, this figure shows the hash chaining function. So when unlocking BitLocker encrypted hard drives, hash chain measurements can be used both locally and forwarded to server-based attestation services. Next is self-encrypting drives. Performance may also be a goal when thinking about using FDE, or full device encryption. Self-encrypting drives use integrated hardware to provide encryption outperforming software encryption in terms of performance. So included in portable computing devices, this is going to be very helpful. All right, now let's talk about compensating controls. So for Windows operating system, antivirus software should be implemented as a centrally managed solution. Malware primarily targets Windows. Instances of infections on Unix and Linux systems are extremely rare. Linux email and file servers, however, run the risk of spreading infected files to Windows users. Using signature definition files, conventional antivirus software detects malware. However, a virus might be designed to change its signature, making the signature definition strategy useless. Therefore, more recent antivirus programs can search a suspicious file for common strings. Microsoft Windows Defender is a built-in security feature of Windows, but there are also additional malware protection application suites available to supplement this. Next is a HIDS or HIPS, or host-based intrusion detection system, intrusion prevention system. So here it's critical when the defense in depth can be useful when implementing security for your end devices. Any network-based protection measures put in place will be complemented by a HIDS or HIPS. Host systems will generally block any malicious actions and assist in stopping any attempts to replace system files, as well as anomalous administrator actions. A HIDS or HIPS will cooperate with additional anti-malware tools. Next is host-based firewalls. So by preventing unauthorized connections on an internal network segment, all known east-west traffic, a local firewall will support network firewalls. Host-based firewalls are frequently installed on the most widely used operating systems to accomplish this. Windows Defender Firewall is a feature of Microsoft Windows that can be controlled visually or through PowerShell commands. And as you will see here, right, this figure shows a screenshot of the Windows Firewall. All right, now let's talk about EDRs, or Endpoint Detection Response Software. So EDR software enables the installation of an agent on endpoint gadgets. Although it does not rely on definition files or known malware hashes, it will coexist with conventional anti-malware solutions. Endpoint monitoring should be continuous with logs being sent to the EDR provider in order to be best prepared for potential threats. With databases of APT actors or advanced persistent threat actors, TPPs, and gathered baseline data from typical activity, actions can be processed in real time, enabling the detection of IOCs or the indicators of compromise. For businesses without spare SOC personnel, many security providers often offered as a managed security service or MSSPs and offer fully managed solutions. EDR software will better safeguard businesses from ransomware, fileless malware, and zero-day exploit as the new attacks are launched on a regular basis. Microsoft Defender for Endpoint and CrowdStrike are popular alternatives for these. You may want to see the following URLs for more details. Um, Next is through the use of redundant hardware. So we must find ways to make important systems more resilient when hosting them because their failure could have a disproportionately negative effect. Reliable network interface cards, storage, and power supplies are frequently used on servers in data centers. In these circumstances, it is crucial to pinpoint the areas where single points of failure can adversely affect the workload. Next topic is self-healing hardware. So we should put in place systems that can recognize problematic events and where necessary make adjustments wherever it is possible to increase resilience. Using hardware clusters as an illustration, a workload might be hosted on another node if a heartbeat signal is not sent in time. In today's hard drives, bad blocks are automatically marked out and replaced with reserved blocks kept in a server pool or reserve pool. The Resilient File System, or REFS, is a feature that is available on Microsoft operating system as of Windows Server 2012 and allows for this. The hosted drives are constantly scanned by an integrity scanner that the REFS deploys, and if necessary, it starts a repair process. And the last one is the User and Entity Behavior Analytics, or UEBA. It is becoming more and more common to use analytics to identify patterns of behavior in order to protect valuable company data. When a user account is suddenly used inappropriately, the system has the option of notifying administrators or stopping the behavior. Imagine that on December 25, a user named Joe, who is based in the UK, logs into his work email from a place that is known to be North Korea. He then starts deleting significant amounts of crucial manufacturing data from the engineering team shared drive. If had been in use, this would have immediately alerted his line manager and the SOC team, right, or the Security Operations Center team. Okay, that's the end of the lesson. Here we spoke about hardening techniques, processes, mandatory access control, trustworthy computing, and compensating protocols, or compensating controls, rather. All right, again, thank you very much for watching the video. Hello, welcome to Module 3, Lesson 3 of our CASP Plus course. This lesson in Security Engineering and Cryptography covers the following topics, such as embedded systems, ICS SCADA, OT protocols, and types of sectors. Understanding embedded systems. OT, or operational technology environments, make use of embedded systems. They are a hybrid of software and hardware created to run a specific operational process. Embedded systems can be found almost anywhere industrial controls are used, but a good example would be machine tools used in environments related to mechanical engineering. They will be employed in transportation systems, water treatment facilities, and in power plants, among many other places. The hardware that is used by embedded systems might have been created more than 50 years ago, and the software might have been created in low-level machine code. There are frequently no affordable ways to upgrade an old embedded systems. It might be running a coal-fired power plant that is soon to be decommissioned or a nuclear facility. Often, the only way to reduce risk when supporting these environments is through network segmentation. Now let's talk about each of these four components of components of embedded systems, right? So first is IoT. So the term IoT, or Internet of Things, refers to a wide range of technologies, including home automation, building control systems, and numerous other fields where hardware automation is necessary. Since many IoT devices are wireless, if we do not fortify our wireless networks, they could become targets. Light bulbs, smart speakers, televisions, refrigerators, and many other items fall under the category of consumer goods. IoT doesn't create its own standards. Instead, it depends on those offered by other protocols. Next is a SoC, or what we call as a system on a chip. So an input-output port, or I/O port, memory, storage, and central processing unit, or CPU, are all found on a single silicon chip known as SoC, or system on a chip. Smartphones and tablets are two devices that effectively use the SoC technology. Power consumption is greatly decreased by integrating all necessary components on a compute node. SoCs include, for instance, the Qualcomm Snapdragon, ARM, Apple's M1, and Intel Core Consumer Ultra Low Voltage, or CULV. Next are ASICs, or Application Specific Integrated Circuits. So ASICs, also known as Application Specific Integrated Circuits, right, are created for a particular use case, such as Bitcoin mining or managing a complex repetitive task on an ICS. A vulnerability found within an ASIC chip cannot be fixed because ASICs cannot be reprogrammed. And the last one is FPGA, or Field Programmable Gate Array. FPGAs can be customized by the end user or the customer after leaving the fabrication facility, right? It's a programmable circuit board made of reprogrammable logic blocks. This design allows for new procedure modifications. Reprogrammable devices can be targeted and attacked. This chip right here, right, has been attacked, and chips are used in enterprise networks and ICS. There's a specific CVE called 2019-1649, and it describes a logic flaw affecting Cisco Secure Boot hardware and multiple networking products. Local attackers can disrupt secure boot verification. This exploit could boot a malicious image. A vendor firmware update fixes it, while 70% of ICS and embedded system attacks can be launched remotely without authentication. Last 2019, we have what we call as the Star Blade, right, which is a bug affecting Selink 7 series FPGA chips. So the vulnerability allows attackers to insert a backdoor and modify chip functionality or damage it directly. And there's no fix, so the system must be isolated, monitored, or replaced. Now let's talk about ICS and SCADA. So many OTs, right, automate industrial processes and critical infrastructure. Manufacturing and process control use ICS. They let production lines run and chemicals flow at the right rates. Management systems must display telemetry data, and complex processing environments need many parts. So as you will see, right, this figure shows the components of a SCADA system. HMIs, or human machine interface, let supervisors control complex ICS from a control room or data center. Supervisory computing systems communicate with PLCs, or programmable logic controllers, which receive telemetry from pumps, actuators, and sensors. The PLC controls the plant and equipment, and HMIs in the data center manage the plant. So let's talk about some of the known technologies and components, right, or which is being used in ICS and SCADA. First is PLC, right, or programmable logical controller. OT uses ICS designed for hostile environments. So PLCs are designed for factories and other industrial settings. PLCs automate physical processes like airport luggage, conveyor belts, or mine traffic light systems. PLCs don't use commercial operating systems, unlike business IT, right? And specialized embedded OSs will control industrial equipment. General Motors use the first PLC, which is called the Modicon 084. So in 1968, at their car assembly plant, PLCs need real-time instructions to control or adjust critical processes. So as you will see right here, this screenshot shows an array of available PLCs used in the industrial environments. A PLC essentially is a dedicated computer that is also able to operate in hazardous environment. Next is a historian. So industrial control environments use a database logging system known as operational historian. The data collected will be gathered from process controls such as sensors, instrumentation, and other types of controls. This allows for the capture of data that can be interpreted to show trends and allow engineers to analyze the data and adjust processes where necessary. A historian is composed of three main components. First is data collectors for interfacing with the data sources such as PLC and network devices. Server software that processes and stores the data from the data collectors. And the client applications that allow for analysis, reporting, and visualizations. Next is what we call as the ladder logic. So this is actually a straightforward programming language that is based on the relay-based logic that was first applied to electromechanical relays. If all of the anticipated inputs are received while processing the logic, the program will process multiple inputs or signals and be able to perform a function. Originally, engineers used ladder logic to create circuit boards that would turn on mechanical relays. And today, a visual programming language employs a similar strategy. Ladder logic interprets instructions by processing them from top to bottom and left to right using rungs or like a ladder. So here it shows an illustration of a ladder logic, right? And the reasoning follows a top to bottom and left to right direction. The output will also be true if all of the inputs are reporting that they are true, right? So here in this illustration, right, we demonstrated a logical procedure for injecting hot plastic into a mold on an automated assembly line. The output will also produce a false value if any of the inputs are false. So if you want to learn more about this one, you can visit this specific website here, right? Next is safety instrumented systems. So a safety instrumented system, or SIS, so we call it, is primarily designed to act as a failsafe in critical industrial environments when threatening conditions are found. When a critical condition is identified, SISs are used to shut off the process independently of a process control network, or PCN. Nuclear power plants, petrochemical refineries, gas production, mining, and many other industrial settings would commonly use this type of control. For operators of plants and equipments that are deemed hazardous, there's an international standard covering protocols. Both the US and Europe recognize the International Society of Automation, or ISA-84, and International Electrotechnical Commission standards. In addition to standard process control system, the SIS will operate. Its sole objective is to restore a system to a safe state after it has disregarded predetermined conditions. It will be made up of sensors and controls under a PLC's control. Our relief valve may be opened, or fire suppression system may be turned on as a result. And the last one is HVAC, or heating, ventilation, and air conditioning. So HVAC are frequently managed by building automation systems in large, complex industrial settings. Monitoring and adjusting humidity and temperature are crucial for safeguarding delicate equipment. Hospitals, data centers, manufacturing facilities for silicon chips, chemical processing facilities, power plants, and many more environments may be protected by HVAC. Digital controls for contemporary HVAC systems will be made using specialized networks. All right, now let's go to OT protocols. So the ICS and OT environments contain a wide variety of supported protocols. Some protocols, some of which date back more than 50 years ago and lack integrity or encryption controls. Modern protocols come with strong security features as of the moment. We'll look at some instances of these protocols. First is the Controller Area Network Bus, or the CAN bus. This protocol was initially created for the automotive industry with the goal of reducing the amount of deployed cabling inside a vehicle. It is capable of enabling bus service or bus devices to communicate without the need for a centralized host computer. Multiple signals can be transmitted on a single shared bus, thanks to multiplexing, right, which is the foundation of the design. Each design may be given a priority in order to share the bus. So when two nodes transmit simultaneously on a bus, the device with the highest priority will take precedence. So the collector area network specification is designed as a specification for dependable transmission of data frames across a shared bus, and it does not support any native security or encryption. The OSI models, data link, and physical layer are defined by the CAN standard, which is included in a specific ISO standard called ISO 11898-1. Security features can be included in vendor implementations, but they're not specified in the CAN standard. So as you will see, this figure depicts a CAN bus model used in a vehicle. As a result, the nature of this technology, right, it is now used in a variety of environments, including ICS, agricultural machinery, lighting systems, building automation, medical devices, and many more. When using it, the risk of MIM, or man-in-the-middle attacks, and other types of tampering could have significant security ramifications. Next is the Modbus. So with the help of a messaging protocol called Modbus, serial communication over various cable types, including Ethernet, is made possible in the ICS. It is well liked because it is royalty free and has established itself as the norm in OT settings. Modbus is typically used on SCADA networks where it can transmit data from remote terminal units or RTUs in an industrial setting back to monitoring computers. Now, in order to meet the needs of industrial communication, Modbus was created in the 1970s. The de facto standard in industrial settings is now Modbus. Modbus is susceptible to MITM attacks if an attacker gains access to the network because it provides no protection against tampering with message integrity. There's actually numerous instances of Modbus protocol vulnerabilities posted online. So for more information on the current known Modbus protocol vulnerabilities, you can visit um, a specific URL as seen here, right, on the PowerPoint that we have. Next is Distributed Network Protocol tree. So this protocol is actually designed to support ICS, which includes companies that distribute power and treat water. It was created in the early 90s and quickly became popular. It is intended to relay messages between supervisory and management systems and PLC's RTUs, similar to some of the technologies mentioned above. Large sets of tags are typically transferred and kept in sync from one location to another using DNP tree or the Distributed Network Protocol tree. So its resistance to EMI or electromagnetic inference interference distortion is one of the key advantages, making it particularly helpful when managing electrical machinery and equipment. IEEE standard 1815-2012 now recognizes this protocol. Then for organizations that manage any communications for electric power systems or EPS, the standard or this specific standard is now advised. So using public key infrastructure, PKI, and transport layer security TLS, DNP3 completely supports encrypted communications. Next is SIGBee. So it refers to a wireless protocol which is primarily designed for home automation. It is an excellent candidate for personal area networks because it enables communication with low power devices over distances varying between 10 to 100 meters, and it utilizes a radio frequency range of 2.4 gigahertz and is covered by a certain IEEE standard called 802.15.4. Next is a common industrial protocol, CIP, right? It's a protocol specification for message transmission on industrial networks. In order to manage objects used to control machinery and plants, it is used to transport messages. Sensors, switches, valves, and actuators are common items. Manufacturers of industrial automation controls are members of the Open DeviceNet Vendors or Association or ODVA, which oversees its administration. UDP, which uses TCP to deliver larger messages and UDP to deliver smaller messages, is supported by CIP for message transmission. UDP increases network efficiency and speed as well. The protocol is based on a producer-consumer model where the producer sends a multicast message to be processed by nodes matching a network identifier. And the last one is data distribution service. So here, networking middleware known as DDS is used to publish messages to subscribers. A publisher subscriber model is what this is, right? The Object Management Group, or OMG, comprised of businesses and academic institution that defines and publishes this specification. Many different industries, including the aerospace, military, medical, government, and many more, uses DDS. So, middleware or DDS is a layer of software that stands between the operating system and the applications. It makes it easier for different parts of a system to communicate and share data. By letting programmers concentrate on the functionality of their applications rather than the difficulties of passing information between applications and systems, it is intended to make the development of distributed systems simpler. As you will see here, right, this figure shows the layers that are very important for DDS. The middleware layers are covered by the DDS specification. Now let's talk about the types of sectors. So first is the energy sector. So energy providers must follow national and international regulations. U.S. electric utility companies must follow laws governing industrial waste, greenhouse gas emissions, and air pollution. Noncompliance can result in fines for these providers. The U.S. Environmental Protection Agency, or EPA, has successfully prosecuted businesses for noncompliance through civil enforcement. In the UK, the Office of for Nuclear Regulation, or ONR, enforces security and safety laws for around 36 nuclear facilities. Noncompliance with the ONR can result in hefty fines and retroactive provisions. Next are manufacturing. Manufacturers must demonstrate to their clients that they can be relied upon to deliver high caliber goods and follow ethical business practices. One can obtain accreditation, such as from the ISO 9001, to show a certain level of competency. These specifications cover quality control, or QC, for businesses that manufacture goods. When a business wants to produce specific goods, there may be many other standards that need to be taken into account. To ensure that products comply with standards, some regulations may be enforced both domestically and abroad. When operating facilities and machinery in a manufacturing environment in the UK, specific standards must be followed. Next is healthcare. So there's actually numerous regulatory requirements for healthcare providers, and these will vary between nations. PHI, or Protected Health Information Records, that are stored and transmitted electronically must adhere to strict controls mandated by the Health Insurance Portability and Accountability Act in the US, or HIPAA. The Department of Health and Human Services is in charge of enforcing HIPAA compliance. A healthcare provider may face legal action and financial penalties for violations if the proper due diligence and care are not taken. Next are public utilities. So the Public Utility Regulatory Policies Act governs public utilities in the U.S. This law was passed in the wake of the 1973 energy crisis, which was brought on by an oil embargo after the Yom Kippur War, which caused the price of oil to rise by more than 300%. Its goal is to encourage production of clean energy for domestic use and renewable energy. In the US, individual states are responsible for managing enforcement and regulatory requirements. Public utility companies must not discriminate when setting their rates. The Office of Gas and Electricity Markets oversees the regulation of gas and electricity providers in the UK. Controls are in place to guarantee that price increases are limited to the current inflation rate. Operators of public utilities are primarily concerned about cyber attacks on their services and data breaches involving customer records. All right, next are public services. Public service providers, or PSPs, offer things like social services, emergency medical care, housing, waste removal, and education. There are services that the government offers, and their purpose is not to make money for the provider. They're made available for the community's benefit. Cybercriminals target public services. Ransomware attacks have particularly hard on healthcare organizations. A group known as CompTIA targeted the Irish Department of Health in May 2021, forcing it to cancel many patient services and switch to using pen and paper instead of their usual information systems. An estimated 35% of ransomware victims pay criminals to unlock their systems and access their data. And the last type of sector um, is facility services. So here, cleaning, maintenance, security, waste management, catering, and a lot more are all examples of facility services. It may be flexible and less expensive to hire outside parties to handle facility services. When contracting out any aspect of your daily operations, it is crucial to take downstream liability into account. OT is required in a lot of regulated industries. Now, outside of carpeted areas, this environment is sometimes referred to as IT. This criterion would be met by a metropolitan transportation service provider operating a subway transit system. They need to send urgent messages across these non-business networks while also keeping an eye on system, subway trains, crucial signaling, and passenger movements. All right, that's the end of the lesson. On this lesson, we spoke about embedded systems, ICS and SCADA, OT protocols, and the type of sectors where all of these topics will be critical, right? Again, thank you very much for watching the video.
Hello, welcome to Module 3, Lesson 4 of our CASP Plus course. This lesson in Security Engineering and Cryptography covers the following topics: automation and orchestration, backup and recovery methods, infrastructure versus serverless computing, collaboration tools, storage configurations, and CASPs. So in order to determine an enterprise's computing requirements, capacity planning is crucial. Workloads must be able to be deployed as needed to meet the needs of the business and the customer. To support the needs of the business in a modern cloud environment, a high-level automation will be necessary. First concept is autoscaling. Workloads must be able to be deployed on demand when an enterprise supports critical services. With the help of autoscaling, the customer can define their anticipated daily compute requirements. The customer can then select a plan that automatically adds more compute resources during periods of high demand. As you will see here, this illustration shows how autoscaling works. By utilizing autoscaling, a customer can collaborate with a cloud service provider or CSP to provide highly scalable solutions to satisfy customer demand. Next is SOAR, or what we call a security orchestration, automation, and response. Playbooks can help staff respond more quickly to security incidents, while runbooks can automate routine tasks and security-related responses. Helping the Security Operations Center, or SOC, manage and monitor security-related events while dealing with rising demands. Next concept is bootstrapping. So bootstrapping enables the creation of configuration files to facilitate the deployment of these virtual computers or appliances when automating the creation and deployment of virtual machines to support workloads. Bootstrapping supports autoscaling and allows for the quick deployment of virtualized infrastructure. When a computer node or cluster boots up from a standard image, it's typical to apply the configuration to those nodes or clusters, such as in Linux, Unix, or Windows. Now let's talk about backup and recovery methods. One option a company should take into account when hosting a failover site for business operations is a cloud-based provider. The business can select a solution that satisfies its requirements for data sovereignty or regulatory compliance. The first concept here is BCDR, or Cloud as Business Continuity and Disaster Recovery. Given that many businesses use the cloud to host crucial workloads and services, it is important to evaluate the provider's capacity to offer redundancy and be resilient to geographic disruptions. A multi-cloud solution where data and services may be available from more than one cloud provider may be something an enterprise should take into consideration.
As a result, the business can maintain core services with multiple providers, increasing its resilience. Next is a primary BCDR provider. The primary CSP or cloud service provider that the enterprise selects should be able to show that it can continue to operate under challenging circumstances. The primary provider should be able to continue operating in the event of a major natural or man-made disasters and should made geographically dispersed data centers. There have been numerous instances of CSPs experiencing serious outages that affected their clients. And the last one is an alternative BCDR provider. So the ability to activate workloads with different cloud providers is helpful for ensuring that the enterprise can deliver critical services. Numerous cloud service providers offer their client solutions that are built based on the amount of processing done. As a result, the business can use services as needed and only pay for them when the workloads are active. The US federal government has given Amazon and Microsoft large multi-billion dollar contracts for their respective Amazon Web Services and Azure Cloud Services, respectively. Now let's talk about infrastructure versus serverless computing. If a company wants to host applications and data in the cloud, one decision to make is whether to host their own infrastructure there or pay for serverless computing. The business can pay for IaaS or infrastructure as a service and provision a number of compute nodes to meet its needs in conventional cloud-based models. Now, when using serverless models, the business only concentrates on the applications. You can simply deploy the applications to the cloud if the customer needs to host e-commerce applications, leaving the backend to the CSP. The customer only needs to pay for computing time. Server upkeep or network bandwidth reservations are taken care of for them automatically. Since the customer only pays for what they use, serverless computing makes better use of the cloud's resources. Now let's talk about collaboration tools. Team collaboration can be greatly facilitated by cloud-based collaboration tools. Common cloud-based solution tools enable businesses to engage with their customers and work productively with partners and remote employees. Web-based conferencing, chat, voice over IP or VoIP, and many other things are typical tools. Where businesses have had to adjust to a remote working model, these tools have proven to be very helpful. Security and resilience should be taken into account when planning on using online collaboration tools. Tools for collaboration can be helpful as a failover when a primary service is down. We can use tools like Microsoft Teams or Zoom conferencing to communicate with partners, team members, or customers if a cellular network is down due to disruption of outages or other outages. Now let's talk about storage configurations. The security of the data is of the utmost importance when organization uses CSP to host crucial services or to provide redundancy in the event that the enterprise must use CSP for BCDR. There are techniques for data security that offer redundancy as well as data security. Now let's talk about these two concepts in storage configuration. The first one is bit splitting. Bit splitting is used to secure data kept by cloud service providers. The AES 256-bit symmetric algorithm, let me put it here, sorry, yep, is used to first encrypt data blocks which are then divided and distributed across various data stores. In order to accurately retrieve the data using data maps, the split blocks that contain the stored information are hashed before being written into the file system. Next is data dispersion. Data dispersion is designed to function similarly to parity-based RAID solutions. The data blocks are scattered among various cloud service providers or storage systems. We can still access data because the algorithm is similar to RAID 5 or RAID 6 even if one provider is down. And the last topic is about CASBs, or Cloud Access Security Broker. So a sufficient level of security must be in place when an organization uses CSPs to store data in order to protect the organization. Data may also contain intellectual property or sensitive information and may be subject to regulatory or legal compliance. Customers, partners, and employees may have access to the data. This implies that the internal security controls won't work. Security becomes challenging to monitor and enforce when an organization uses multiple cloud providers. A CASB can offer authentication services like single sign-on, authorization, credential mapping, device management, DLP or data loss prevention, malware detection prevention, logging, alerting, and numerous other security services. A CASB is frequently referred to as a gatekeeper because it guards enterprise data against outbound threats like data exfiltration and inbound threats like threats entering the cloud. By labeling the overseeing the use of the data to ensure compliance, CASB also helps to ensure regulatory compliance. So as you will see on this illustration, right, this shows the services provided by a CASB, such as visibility, data security, threat protection, and SOC services. There's also what we call as SWGs or secure web gateways and next-gen firewalls, which are two common security measures are insufficient to safeguard data hosted with a CSP. There are times when connections to the cloud do not go through the corporate network. Numerous connections will be made directly from distant users into the cloud. All right, that's the end of the lesson. On this lesson, we spoke about automation and orchestration, backup and recovery methods, infrastructure versus serverless computing, collaboration tools, storage configuration, and CASPs. Again, thank you very much for watching the video. Hello, welcome to Module 3, Lesson 5 of our CASP Plus course. This lesson in Security Engineering and Cryptography covers the following topics, such as PKI hierarchy and certificate types. So understanding the PKI hierarchy, the key elements required to handle certificate signing requests or CSRs, right? CSR, authorized request, and carry out the signing process are described in a PKI hierarchy. Each PKI component contributes significantly. An overview of the PKI hierarchy is shown in this specific figure, and we're now going to discover more about these elements. The first concept or component or element is the certificate authority or the CA. So an application server that is running the certificate services service, right? Or it could be a Linux, Unix equivalent daemon, right? Makes up a certificate authority. There may be several levels of CAs, but a root CA always exists. There will typically be at least one more layer on top of that. The intermediate or subordinate CA is this. Normally, the root CA will be kept in a safe place, which is often isolated or air-gapped. And for the purpose of designing requests from intermediate CAs, the root CA only need to be operational and accessible. An organization may have multiple issuing CAs for redundancy. To sign the client CSR, the issuing CA must be activated, accessible, and highly available. Certificates adhere to a set of rules. The format and information that must be included on a digital certificate must comply with the current standard X509.v3. Next is the registration authority. This one, right? So there are policies that determine whether a request will be approved when it is submitted by a client entity. Verification checks must be carried out before issuing a certificate that verifies a domain name or another identity. The role of a registration authority, or RA, can be compared to that of an auditor. Identity verification would be necessary if you wanted to apply for a passport because it would prevent identity theft. The passport would be the digital certificate in the PKI hierarchy, and the RA would be the department or agency of government in charge of passport issuance. Next is the certificate revocation list, or what we call as a CRL. Okay. So the CA publishes a certificate revocation list, or CRL, as a way to revoke certificates that are no longer valid or trustworthy. The CA can revoke a certificate and post the status on a list that is open to the public if a certificate has a validity date of 1 year and there's a key compromised during that time. As you will see here in the figure, this shows a typical uh, copy or snapshot of a certificate revocation list, or a CRL. Now, for a number of reasons, including ceasing operations, changing affiliations, or key compromise, certificates may be revoked. And the last one is what we call as OCSP, or the Online Certificate Status Protocol. OCSP is now the accepted method for delivering a quick response in order to support a quicker response to a client request for revoked certificates. A client must connect to the CA's CRL server and download the most recent CRL entries when using only a CRL. A client cannot verify the status of the public key certificate if the CRL network is experiencing an issue with availability or a brief outage. But with OCSP, even when the CRL is momentarily unavailable, the OCSP service can cache results and respond to client requests. Since only the public key certificate's serial number needs to be verified, the OCSP protocol is also much simpler. We will need to offer certificates for a wide range of uses once the PKI hierarchy is established. Now let's talk about certificate types. So when registering for certificates, large businesses have very specific requirements. In some cases, the objective may be to make administration simple or to have the flexibility to add more sites to an e-commerce operation. Customers might occasionally require the assurance offered by highly regarded certificates. Here are a few popular certificate types. First is a wildcard certificate. With the aid of a single certificate and a wildcard certificate, an organization is able to host numerous websites using a single key pair. Depending on the quantity of sites hosted, there might be limitations or extra charges. The wildcard certificate mandates the use of the same DNS or domain name system domain name across all sites covered by the certificate. Each site's hostname is the only thing that can vary. As you will see, this shows a sample of a wildcard certificate. Hosting multiple websites while only changing the DNS hostname for each one is possible. Next is extended validation. So banks and other financial institutions are the main users of extended validation certificates, which have high level of assurance. Customers who use their web browser will notice a visual cue that the site has an extended validation certificate. This figure shows a Microsoft Internet Explorer connected to a site with an extended validation certificate. The CA offers extra security services and support to websites that have extended validation certificates, such as recurring vulnerability scans. Next is a multi-domain. A multi-domain certificate would be appropriate if an organization needed to support multiple domains with a single certificate. As opposed to a wildcard certificate, this kind of certificate allows for a variety of names or host names, domains, and subdomains for a website. This figure, right, shows the subject alternative name or SAN extension on a banking website here. So when hosting multiple domain names, SAN offers a high degree of flexibility, but it necessitates advanced planning because you must be aware of every domain that needs to be added to the certificate. A primary, or formerly known as a common name, will always be displayed by the multi-domain certificate. To see other names connected to the certificate, it is necessary to look at the SAN. As you will see, this um, figure shows the CN extension. Next is a general purpose certificate. So a user might receive a general purpose certificate, right, that can be used for several purposes. A user might be required to use secure VPN access, sign and encrypt email, and authenticate to their Active Directory services account. By giving the user a single certificate, we could reduce administrative tasks. And lastly, our certificate usage and templates. So here you got to make sure that the CA has the appropriate templates enabled to support user requests in order to support all the applications that are currently in use or that are anticipated. Typical templates will include the following types such as client authentication, server authentication, digital signatures, code signing, and general purpose. So as you will see in this figure, we can see Microsoft CA templates available for client enrollment. Either custom templates can be made or additional templates from a default pool can be added. When making plans for a PKI, it's crucial to support a wide range of users and entity requirements. Interoperability planning is also important. Okay, that's the end of the lesson. In this lesson, we spoke about PKI hierarchy and certificate types. Again, thank you very much for watching the video. Hello, welcome to Module 3, Lesson 6 of our CASP Plus course. This lesson in Security Engineering and Cryptography covers the following topics, such as trusted certificate providers, trust models, trust certification certificate, lifecycle management, certificate pinning, certificate stapling, CSRs, common PKI use cases, and key escrow. So it's critical to understand why third-party auditors must have confidence in and independently verify a CA. Hosted financial and e-commerce websites must follow security best practices to have reliable configurations. The ability of CAs to cooperate using trusted certificates is also important. Trusted certificate providers. Commercial CAs are governed by industry associations and are required to follow accepted standards. You must have been independently audited by a reputable auditor in order to provide CA services. The American Institute of Certified Public Accountants, or ICPA, and the Canadian Institute of Chartered Accountants, or CICA, are both recognized by Microsoft as CAs that adhere to their strict standards. To continue to be in compliance with Microsoft policies, an annual audit must be conducted. These requirements must be met for a CA's root certificates to be trusted. European Telecommunication Standards Institute, or ETSI, ETCI, SI, recognized body is a recognized body for auditing CAs in Europe. Outside of North America and Europe, many nations have their own certificate requirements. Now, in order for a commercial CA to be compliant in India, the government mandated Root Certificate Authority of India, or RCAI, must sign the root public key certificate. You may visit the following link if you want to learn more details. Next concept is trust models. There are numerous commercial CAs who operate independently, but there are also times when two or more CAs must collaborate. Examples include situations where contracting business and government agencies must enable trust but do not make use of commercial CAs. The signing of a CSR from a dependable partner is a typical strategy. Next is a cross-certification certificate. So a type of certificate known as a cross-certification certificate can be created when two or more CAs must collaborate. The private key of one CA will be used to sign a certificate that contains the trusted partner's public key. So as you will see in this figure, we can see Acme CA signing the public key of Wingtip's CA. In this case, every user who has confidence in Acme will also have faith in the certificates issued by Wingtip's CA hierarchy. Next concept is certificate or lifecycle management. So it's critical to be aware of the dangers associated with using long-term keys, both for the signing procedure and for offering encryption services. The algorithms that must be used and the key strength that must be met may be determined by regulatory requirements. Rekeying is the process of changing the keys along with the public key certification on an annual basis, as may be required in many situations. Certificate pinning. Now, to safeguard users or clients of an organization from man-in-the-middle attacks, organizations use HTTP public key pinning, or HPKP, right? HTTP public key pinning headers. In order for a client application or browser to block the website or server if the certificate has changed, we can embed the server public key into the code on the web application server. To ensure that customers will only trust the site if the server certificate has been issued by a specific CA, such as GoDaddy or DigiCert, the site may be in some circumstances also pin the CA public key certificate into the code. When connecting to an application for the first time, the technology stores a trusted certificate value. The application provider can set a maximum age field there. The range for the maximum age value is from a few hours to several months. Now, by using a different certificate with the same CN field, this is a very effective way to prevent attackers from building farming sites that look exactly like yours. If you use this method, you might also need to prepare for a scenario in which your server certificate is revoked and a new one is issued. Now, there won't be a problem if the HPKP is based on the issuing CA public key certificate. However, your clients won't be able to access the web application server if the public key from the web server is embedded in the code and later revoked. When a mobile application is downloaded from the App Store, the public key is frequently embedded, and as a result, the app must be updated whenever the keys need to be changed. All right, that's certificate pinning. Now let's talk about certificate stapling. By stapling the server certificate and the status of the certificate revocation, a trusted web application server can start a secure session with a client. To do this, requests for the digital certificate's current status for the application server are sent to the CA OCSP service. The end user will experience a quicker process as a result. Okay? The process of stabling certificates is shown in this specific figure. Now, without having to independently get in touch with the CA for the most recent CRL, certificate stapling enables the client to trust the server certificate. Now let's talk about CSRs, right? So here, the information needed to create a certificate will be included in a CSR. The requester's public key will also be necessary along with some other details. As you will see in this figure, we can see a typical template that must be completed to generate a CSR. When a request is generated, a file is created and stored in what we call as a privacy enhancement or enhanced email format or mail format or the PEM file or PEM format with base 64 encoding. Okay, so here on this figure, it shows a CSR file. Sorry, here, it's in here, CSR file. Now, once the CSR has been approved, it can be sent to the CA who will use its private key to create and sign a digital certificate containing the requester's public key. When creating a CSR, it's critical to select the appropriate certificate template. Now, if a certificate is assigned for a specific purpose, the enhanced key usage extension will make this clear. As you will see, this figure provides an illustration of this kind of extension. The client will reject the certificate if it is presented for a different reason. Now, in order to support routine business operations, certificates are an essential part of an enterprise. Here are some examples, right? Or these are the common PKI use cases. It's web servers, email, code signing, federation, VPN, um, client authentication, and enterprise and security automation and orchestration. It may occasionally be necessary to capture a copy of the private key during the certificate enrollment process. Although not the default setting, this might be necessary for specific kinds of certificate requests. Governmental organizations may have a policy of keeping a user's private key on a file so that the data can be recovered in the event that the original private key is lost or damaged. In some nations, it might even be a mandated requirement. Now let's talk about the last topic, which is key escrow. So key escrow enables a CA to store copies of private keys for entities that have generated a CSR. Escrow is an agreement where something of value is stored securely and can only be released under strict conditions. A CA can keep copies of the private keys for the entities that have generated CSRs by using key escrow. Escrow is a contract in which valuable items are safely held and can only be released under predetermined strict conditions. The sale of a property is a real-world example where conveyancers are involved. The escrow account for the conveyancers will be distinct from their personal checking account. Following the execution of contracts, the buyer releases funds into an escrow account, which is then used to pay the seller. Key escrow enables an organization to give the account holder access to a copy of the private key in the event that their common access card or CAC or smart card is lost or stolen along with it. To make sure that the private keys are only given out under predetermined agreed upon condition, key escrow calls for strict security management. Okay, that's the end of the lesson. In this lesson, we spoke about trusted certificate providers, trust models, cross-certification certificate, lifecycle management, certificate pinning, certificate stapling, CSRs, common PKI use cases, and key escrow. Thank you very much for watching the video. Welcome to Module 3, Lesson 7 of our CASP Plus course. This lesson in Security Engineering and Cryptography covers the following topics, such as key rotation, mismatched keys, improper key handling, embedded keys, exposed private keys, crypto shredding, cryptographic obfuscation, and compromised keys. Troubleshooting issues with cryptographic implementations. We can anticipate encountering issues with compatibility, configuration, and operational issues that disrupt communication or lead to insecure execution in an enterprise supporting PKI implementation. It is critical to identify potential hotspots for these issues and look for ways to address them through efficient policies and procedures. The first concept is key rotation. To maintain data confidentiality, it is crucial to understand the advantages of key rotation. Depending on the organization's policies or as required by regulatory compliance, keys may be rotated automatically or manually. A key must be immediately revoked if it has been compromised. Depending on how many records or transactions have been encrypted, the PCI DSS mandates that keys be changed periodically. An organization should also take other factors into account, such as staff turnover, the security of the encryption keys in the use, and the importance of the data. On appropriate key rotation timelines, the National Institute of Science and Technology, or NIST, provides the advice for this one. So NIST Special Publication 800-57, Part 1, Revision 5, is available on this specific URL here. Next is mismatched keys. Now, to properly consider key rotation, all dependencies must be recorded. A key mismatch may happen, for instance, if the public key is hard-coded into software of hardware devices and a key is rotated on a crucial independent module. To prevent this, documented policies and procedures should be used. Next is improper key handling. Strong policies and procedures must be in place for the handling of encryption keys. The function of key generation and assignment ought to be given to particular administrators. Separation of duties should be taken into consideration when there is a chance of fraud. Now, limiting the amount of time a private or secret key is in plain text form, limiting who can view plain text keys, and storing keys in secure containers are just a few of the recommendations made by NIST to increase the security of key handling. Let's talk about embedded keys. So, when it's necessary to ship computers or other hardware with default secure configurations, vendor may choose to use embedded keys. Windows operating system set up for a secure boot could serve as an illustration. The Unified Extensible Firmware Interface, or UEFI, firmware includes the Microsoft Public Key. This enables secure booting from the very beginning of use. Now, due to the computer's intended use, the embedded key may occasionally need to be updated or modified. The embedded key, which is the public key for the Linux distribution, needs to be changed if we want to install Linux on the system and take advantage of a secure boot. Exposed private keys. Private keys must be kept safe because an attacker can use them to decrypt sensitive information. A secure option for storing private keys is a crypto module. Private key security is handled by a specialized device called a hardware security module, or HSM. When sensitive keys are needed for secure transactions, an HSM can be a secured appliance in the data center. Private keys can be kept in escrow where there is a business need or compliance requirement. Next is what we call as crypto shredding. Cryptographic shredding may be a good option when it's necessary to make sensitive or confidential data unreadable. This would entail using specific encryption keys to encrypt the data while it is at rest. The sensitive data could then be destroyed by deleting the encryption key that was used. When a storage device cannot be physically accessed, such as when data is stored by a third-party cloud provider, this may be helpful. Access to the data won't be possible after the key has been destroyed. This technique is used to make the data unrecoverable, much like physically shredding a hard drive. On Apple iPhones, a method known as crypto shredding is employed. If the PIN number is entered incorrectly 10 times, the advanced encryption standard or AES encryption key is deleted, rendering the device storage inaccessible. Next is cryptographic obfuscation. Modern encryption ciphers use intricate mathematical techniques to safeguard the cipher's keys. The purpose of multiple levels of confusion and diffusion is to make cryptojob analysts extremely challenging. Regulatory organizations frequently demand new security protocols, as well as the use of longer encryption keys and more complicated cipher block modes in existing ciphers. In the event that the plaintext needs to be accessed without the encryption key, it is difficult to reverse a cipher given these conditions. And the last concept is compromised keys. So once a key has been compromised, it needs to be removed from use and added to the CRL. This must be completed as soon as possible as well. This may need to be done right away or at the very least within a few hours, depending on the value of the data and the potential for exposure. Private keys that have been stolen are an example of a compromised key. All right, that's the end of the lesson. In this lesson, we spoke about key rotation, mismatched keys, improper key handling, embedded keys, exposed private keys, crypto shredding, cryptographic obfuscation, and compromise keys. That's the end of the lesson and the end of the module. Thank you very much for watching the video.
Hello, welcome to Module 4, Lesson 1 of our CASP Plus course. This lesson in Governance Risk Compliance will cover the following topics about risk strategies, covering risk assessments, risk handling techniques, risk types, risk management lifecycle, risk controls, risk tracking, and policies and security practices. All right, some sort of introduction. The effects of enterprise risk in businesses can be devastating, right? Both long-term and the short-term success require a thorough grasp of the risks involved. Security experts who are able to perform risk assessments are an asset to any company. Having a plan in place to deal with identified risks is essential for any company, whether those risks are driven by business imperatives or by the need to comply with regulations. Now, the management of risk is an ongoing process for any company. We can tell if our controls are working and if we're staying within the boundaries of the company's risk tolerance thresholds by keeping tabs on things and reporting on them. Management of business risk is facilitated by robust security measures. Secure day-to-day operations can be ensured with the help of well-established cybersecurity policies and practices. Now, lack of visibility into who handles or processes data increases the risk to an organization due to the supply chain's complexity. The responsibility of managing and evaluating vendors falls on the risk team. All right, let us talk about risk assessment. There are typically two approaches to risk assessment, one of which uses what we call as qualitative technique. The metrics employed in this strategy will be likelihood, the impact, and the possibly additional metrics like speed of onset. This is regarded as a fundamental kind of risk assessment and will incorporate the assessor's prior knowledge. A qualitative risk assessment is frequently thought of as a subjective method, which means that two different risk assessors may not always agree. Breaking the process down into steps or phases is a common risk management strategy. As you will see here, right, on this illustration, it shows the five-step process in risk management, which includes identify the business assets, identification of known vulnerabilities, identify the threats, what's going to be the business impact, and identification of the risk response. Now, we must be able to quantify a level of risk as a measurement in order to understand the risk.
Since we always need to protect our assets, we must determine the level of risk by factoring in likelihood and the impact. So, utilizing a qualitative method is one of the approved methods for risk assessment. Now, next slide, we're going to examine this kind of assessment. Right. So here, we must take a step-by-step approach, right? Using likelihood versus the impact to perform a qualitative assessment. So as you will see here, the risk matrix can be quite straightforward, right, as shown here. So to prioritize the risk responses, it is critical to highlight the biggest risks. And when we evaluate risk in relation to particular assets, there are more detailed qualitative risk assessment systems. We can use the CIA or the Canadian Institute of Actuaries aggregate matrix when it is necessary to host various data types on a shared information system, which often is requiring different classification labels, right? It's here. So on this one, right? It shows an illustration of the CIA's aggregate method of risk assessment. Now, using this method, we can ensure or we can make sure to identify the biggest systemic risks and use those as a starting point for applying controls. We can keep track of the peak value for each column when calculating the total values. The impact value for admin information is low in the previous screenshot, right? As you see here. So, however, we need to make sure that the appropriate controls are in place to minimize any potential effects on the OD alerts, right? And we might decide to put it in place with a high availability failover solution because this is a shared information system. Now, the fact that a qualitative method may be a simpler to execute is one of its advantages. However, it does not generate outputs that reflect the degree of financial risks. It might be necessary to use a quantitative approach, right, in order to present monetary values to decision makers in order to present the risk. Now, let's gonna examine the quantitative approach in terms of risk assessment. So we have a couple here that we're gonna cover, right? Like asset value, exposure factor, single loss expectancy, and so on and so forth until the mean time between failure. On the next few slides, we're gonna talk about each of them, right? So as you may know, it is very crucial to present these risks in a way that is simple to understand when communicating risk to company leadership. It is helpful to show decision makers the financial effects of risks when presenting them. So here, utilizing the quantitative risk assessment can help with these. Let's talk about the first one, which is the asset value. So knowing an asset's value is crucial when using a quantitative approach. So this could be the cost of purchasing the goods or perhaps the expenses incurred in building a customer marketing database. That's what we call as the asset value. Next is the exposure factor. So when evaluating risk, it is rare for there to be a complete 100% monetary loss in the event of an occurrence. It's likely that the costs to repair the damage if my building, is flooded will be higher than the building's total initial cost. And typically a percentage is used to represent this specific value. Next is a single loss expectancy or SLE. So this is so the asset value when multiply it with the exposure factor formula is used to determine the amount of loss during a single event. So you just have to multiply these two together for you to get this number. Next is the annualized loss expectancy or ALE. So if there are several incidents, we must determine how many events will take place in a calendar year. That's the ALE. The annualized rate of occurrence, ARO. So when you have SLE and you multiply it with ARO, it is being used to determine the total loss for the entire year, right? The risk management team must evaluate all risks that could result in a loss for the company, because it has a production facility. Next is the gap analysis. So a gap analysis is carried out to determine where um, where potential missing controls may exist. We must be able to evaluate the current state of controls and so next is a gap analysis. So a gap analysis is carried out to determine where potential missing controls may exist. We must be able to evaluate the current state of controls and contrast it with where we want the organization to be in order to perform this analysis. So as you see here, right, this diagram illustrates the procedures needed to carry out a gap analysis. So it starts with the identification of the current state, identify the desired state or the target state, what's going to be the solution to bridge the gap, and and the last one is the deployment of the solution to bridge the gap. All right, so senior management can be informed of the findings to help with the response. Next is a TCO, or the total cost of ownership. So it's critical to take into account all costs, not just the one associated with the initial purchase, when evaluating solutions to manage or reduce risks. Numerous solutions could necessitate upkeep, software licensing, additional personnel, or other costs that could or that would need to be estimated over the course of the solution's lifetime. Next is ROI, or return on investment. An ROI is a crucial metric, right? Because it can be used to quantify the financial advantages of a suggested control. A strong return on investment for a suggested risk mitigation solution is a good way to convince senior management of your recommendations. Although it can also be presented as a percentage, it is typical to present an ROI as a pure monetary value. Next is MTTR, or mean time to recovery. So, researching the effectiveness of the proposed solution is crucial when security professionals are evaluating multiple solutions that have been put forth. When choosing a mitigation solution, MTTR might be an important metric to consider. The NAS could serve, or the network attached storage, right, could serve as an illustration of how to safeguard our data from ransomware attacks. It might take 2 hours to restore backed up data from a NAS to a server, compared to 4 hours for a restore from a tape based media. So, with this metric, a lower value is the desired result. This mean time to failure metric would would be used for systems that could not be recovered. And the last metric is the MTBF, or the mean time between failure. MTBF, or mean time between failure, is a metric that can be used to determine a system's reliability. The ideal value is higher, right? And therefore, if my server is like infected with a crypto malware twice in a 24-hour period and requires data restoration from the NAS, the server will be offline for 4 hours, or 20 hours divided by 2 equals 10, right? The MTBF would therefore be 10 hours. Now, we can look at methods to control these risks once we have chosen appropriate metrics to assess the risk. All right. Now, let's talk about the next topic, which is risk handling techniques. So, Once risks have been identified, right, it is important to plan a course of action. Various factors such as the organization's risk appetite and regulatory requirements will influence how approaches are taken. Now, the four primary risk response categories are depicted in this figure. An organization should think about the following risk response strategies, which is transfer, accept, avoid, and mitigate. Now let's go. All right. Now let's talk about implementing risk handling techniques. So once risks have been identified, it is important to plan a course of action. There's actually various factors, right, such as the organization's risk appetite and regulatory requirements, which will influence how approaches are taken. The four primary risk response categories are depicted on this figure, right, which is transfer, accept, avoid, and mitigate. So an organization should think about the following risk response strategies. So let's talk about the first one, which is transfer. So transference may be a suitable strategy when an organization wants to control or mitigate risk but lacks the personnel or financial resources to do so. In the event of a fire, the company should think about purchasing fire insurance if it cannot afford to rebuild the warehouse. The company may think about hiring a third party to handle this payment if it lacks the staff or infrastructure to support secure card payments. Next is accept. So when the risk is accepted, it typically means that the organization has decided it is acceptable given its risk appetite and tolerance. A low probability event, such as an earthquake or flood, in a dry area with no prior record of earthquakes or flood, would serve as an illustration of risk acceptance. Next is avoid. So the organization should stop the activity that has been determined to be outside of the acceptable risk tolerance in order to avoid the risk. Risk avoidance will be justified if the risk is deemed to be extremely high, such as the possibility of losing one's life. And the fourth one is mitigate. Risk mitigation through controls is frequently the response to risk. This safeguards could be administrative, technical, or physical. While risk mitigation won't completely eliminate it, it should reduce it into a manageable level. An acceptable user use policy or AUP, right? AUP for mobile devices could be implemented as a mitigation measure. Additionally, mobile device management or MDM would enable the organization to encrypt corporate data. Recognizing risks that will need to be absorbed in some way is important, in addition to developing efficient risk responses. Now let's talk about risk types. It is important to realize that risk cannot be completely eliminated unless we choose to avoid it when conducting risk assessment. And there will always be some types of risk, like inherent risk, residual risk, and risk exceptions. So, what is an inherent risk? This is the risk that exists in the absence of any controls. A financial institution hiring staff without conducting background checks or formal interviews could serve as an example. However, the bank vault is not secured by any locks or barriers, and when deciding on a specific area of operation or industry, some organizations will have to accept a much higher level of inherent risk. Now, when considering conducting business in a hostile region, there's a risk that is inherently present on both an environmental and a political level. Now, let's talk about residual risk. This risk still exists after controls have been implemented. There will always be some risk, but it will be decreased to a level that is acceptable to the corporation. background checks for employees, biometric locks, and closed circuit television or CCTV for the vault may be solutions for banks. And a third one is risk exception. An exception is when a corporation is unable to follow corporate policy or regulatory requirement. A risk exemption may be necessary due to circumstances that are out of the organization's control or a technical limitation. Legacy applications or equipment may be a common requirement for a risk exemption. Exemptions ought to be formally stated in writing and approved by the relevant stakeholders or business owners. Frameworks, controls, and efficient management are important, right? For an enterprise because risk management is a continuous process. Now let's talk about the risk management life cycle. So the process of risk management is cyclical, and risk must be continuously identified. Security professionals may face new demands as a result of changing business practices and regulatory compliance. Due to these evolving practices, the organizations will need to regularly evaluate its security posture to ensure that the controls and best practices are implemented. The stages of the risk assessment life cycle are depicted in this specific figure, which starts with identify, right? So among the many factors that could, this refers to the many factors that could contribute to enterprise risks are the business process, personal technology, and intellectual property or IP. Next is assess, right? So during this phase, we must pinpoint potential threats, weaknesses, and the degree of risk they pose to the business. And the third is control. So in this phase, we identify the controls that will satisfy the needs of the enterprise in terms of the levels that are they're willing to accept. Then we have review. At this stage, it is important to recognize that the industry, the law, and the threat environment will all change. The business must evaluate these new risks when things change. Like, are the controls still sufficient in light of the evolving threat environment? Right? There are also many frameworks used by organizations, and a particular model typically receives wide acceptance depending on the industry or operational needs. Now let's examine a few risk management frameworks. The first one is the NIST CSF, right, or the Cybersecurity Framework. So here, this was developed to offer organizations advice on how to stop, recognize, and react to cyber attacks. It serves as a general guideline for cybersecurity for various business sectors. So the figure depicts a typical life cycle divided into five different stages. The first one is identify. So here, the organization needs to identify all assets that could be at risk from cybersecurity at this stage, like people, systems, data, and business operational capabilities. In other words, any element of risk can all be considered as assets. Now, we cannot effectively concentrate efforts on the important aspects of the business without this identification stage. Next is protect, right? So the next step is to protect once we have determined all of the critical assets and will reduce and mitigate any harm that could result from a cybersecurity incident. Third is detect. So here, the ability of the organization to recognize when a cybersecurity incident is occurring is also important. We will need a combination of security experts, properly trained personnel, and automated detection to be successful during this phase. Next is respond. In order to respond to cybersecurity incidents, it is important to have appropriate plans in place. We must be able to stop cybersecurity incidents and keep running our business. It is important to concentrate on communication, response planning, and tools and methods for analysis, mitigation, and ongoing improvement. And the last one is recover. So here, an enterprise should maintain plans during the recovery phase that allows the organization to recover from major events such as business continuity, planning, or incident response plans. At this point, it's critical to concentrate on resilience. All right. Now let's talk about risk controls. Okay. So when all the potential risks that an enterprise needs to manage are taken into account, there are numerous challenges involved here, like with employees, business processes, and technology all intertwined. It's quite a delicate balancing act. The relationship between people, procedures, and technology is depicted in this specific figure. And to make sure that they will work well together, it is important to take into account all of these factors. So first, let's talk about people, right? People. So the controls we select must be reliable and well liked by our team. They might try to get around the obstacle if they are overly complicated or poorly executed. Users may find ways to get around strict password policies by reusing passwords or writing down complex passwords. Right? Next are processes. So within the enterprise, it is important to formalize the processes that will be used. A business process should guarantee that objectives are accomplished in a secure and safe manner. The organization's standards and policies will aid in ensuring that processes are carried out securely but effectively. Processes with the potential for fraudulent activity should be changed, and any SPOFs or single points of failure should be located and eliminated. And the third one is technology. So, when thinking about risk controls, technology can be helpful. There are many ways that innovation can be a significant business driver. Automation can assist in resolving or accelerating complex processing issues. Machine learning and AI, or artificial intelligence, are assisting in defending our information systems against increasingly sophisticated threats. However, we must use this technology to ensure that it makes the right choices because many systems still involve humans in the decision making process. We must keep an eye on risk activities to determine whether the controls are working as intended. Okay, now in the next section, we're going to look at the methods used for risk tracking or risk monitoring. So it is critical that the appropriate organizational stakeholders understand and manage the enterprise risk. Every risks, the steps taken to mitigate it, and the business owner who was affected by the risk should be recorded. A risk register should be used to record this, right? So as you will see here, this is a typical risk register template, right? Here you will see the date when it's raised, what's the description, what's going to be the likelihood, is it low, medium, high, impact if the risk occurs, what's the severity, who will be the owner, right? That's very important, right? That we have to ensure that there's always an owner on a specific task or a specific entry in the risk register. Otherwise, it cannot be closed. And the last column is the mitigating action to be able to resolve that risk. So here, um, we need to ensure we have a reliable way to monitor risk if we want to make sure that the organization can adhere to regulatory requirements. By keeping an eye on risk, we can see reports on potential threats and identify any areas where the company may be overexposed. We require efficient metrics that enable an enterprise to track performance with regard to risk in order to monitor and address risks. All right. Now let's talk about KPIs, right, or key performance indicator. A KPI is a quantifiable value that enables a business to pinpoint crucial internal processes that support a strong security posture. KPIs can be used to track the performance of various tasks, such as the proportion of endpoints that have received security updates to date and quantity of unresolved security incidents, the mean time to repair after a security event, or the proportion of employees who have finished security awareness training. Next important topic is key risk indicators, or KRI. So KPIs and KRIs have a direct relationship. They're created in tandem in order to pinpoint the procedures that support strategic goals. We need a way to measure the performance of the key business processes we can pinpoint as a potential risk contributor, where we can set thresholds to indicate where an activity poses a risk to the enterprise. KRI should provide early warnings with proper reporting to ensure that the risk does not balloon and go beyond our risk tolerance. Now, when the risk to the business is quantified by a KPI that the company has identified, there must be an agreement. Like if patching workstation is important, a KPI showing that less than 90% of them are patched could indicate a serious risk to the company's operations. One of the biggest cybersecurity risks is ransomware, right? Which preys on unpatched, vulnerable systems. Next is risk appetite. Risk appetite is the measure of how much risk a company is willing to take in order to achieve its goals. This will vary between the various business sectors and industries and be strongly influenced by the company's culture, rivals, goals, and financial health. It is challenging to pin down a precise number when discussing risk appetite. The three levels of risk appetite are typically low, medium, and high. So in many industries, there's typically a sweet spot where things are acceptable. A large customer base may allow an energy provider to be content with running gas-fired power plants. It is well-established technology, and if it is mature and the general secure, there's no reason to alter the business model or focus on different clientele. They just don't take a lot of risk. Next is our risk tolerance. So this is the departure from the risk appetite that a company will tolerate. The metric can be written as a numerical value or a percentage. The energy provider bargains with international suppliers for upcoming gas deliveries. Since the company has set this as its risk tolerance, we must act if gas reserves for unexpectedly cold weather fall to less than 5%. And the last concept is trade-off analysis. There may be numerous risk and response strategies to consider when evaluating enterprise risk for a large organization. Now, according to stakeholder priorities, there might be conflicting opinions, and it might be necessary to take the enterprise's strategic goals into account. An organization may decide to divert personnel from the sales team in order to devote more resources to customer facing support teams if it determines that customer satisfaction is its top priority. In the short term, this might result in fewer sales, but the long term plan might result in more clients. All right, now let's talk about the policies and the security practices. There's numerous strategies that can be used to reduce risk. One efficient way to achieve organizational goals is through policies. Although they do not ensure that all security objectives are met, they are a crucial layer when we use the DID or the defense in depth concept. Now, by putting in more layers of security, we have backup controls in case one control fails. One of the best practice is the separation of duties or SOD. So here, we lack the necessary checks and balances when an employee has access to high-level decisions without the need for the approval of another employee. Think about a CFO or Chief Financial Officer who approves new suppliers, approves service provider invoices, and signs paychecks. In this case, setting up accounts receivable and accounts payable business function would help to prevent fraudulent activities. Next is job rotation. Employees who work in the same position for an extended period of time are more likely to burn out and become complacent. A shift in job responsibilities indicates that the company has redundant skill sets and motivated employees. Another advantage is that fraud will be less likely to occur because employees will be able to set up long term hidden practices and because a new employee may spot fraud. Next is mandatory vacation. It's standard practice in some industries for employees to take an annual leave of absence from work. Although the length may vary, in finance, a 2-week mandatory vacation is advised. Their position can be audited while they are on vacation, and thanks to this time off. Mandatory vacation also acts as a deterrent, which is another advantage. If the employee is not present to address potential issues, it might be challenging to conceal an unauthorized activity from the company. Next is a list of privilege. This is actually a good practice that entails identifying business functions and having strong account management rules to guarantee the user has the privileges they require for their position. Although it might seem obvious, it is simple to forget about this fundamental control. It is standard procedure to add a worker to a role group with privileges far in excess of what they actually require. Now consider the administrator group on a Windows server, which gives the user access to all administrative tasks on the machine. If a technician is added to the administrator group, they will receive additional privileges that go beyond what they need to install software and hardware drivers. Next is employment and termination procedures. So, without the adoption of policies for new hires and employees who leave the organization, many risks could be disregarded. Background checks and employee vetting should be done for new hires. Now, when onboarding new employees, required security training, equipment assignment, the execution of an AUP, and where necessary, non-disclosure agreements are all required. Employees should be offboarded when they leave the company. Exit interviews are a part of offboarding and will help the company understand potential employee reasons for leaving and improve future employee retention. Whistleblowers may be encouraged to come forward by exit interviews. An employee may be quitting due to the unprofessional behavior and attitudes of their coworkers. It is important to recover all company assets during offboarding and to disable user account credentials. Next is training and awareness of users. Since users are an organization's most valuable resource, security awareness training is an essential procedure. Since insider threats account for over 50% of data breaches, users can also be seen as the weakest link. Now, one of the most important things to take into account when dealing with data breaches is poorly trained users. All employees should receive basic security training along with more specialized instructions specific to their job duties. All right, and the last one is auditing requirements and frequency. So the enterprise must conduct routine audits to ensure it complies with legal requirements and reduces the risk of fraudulent or nefarious behavior. The Federal Information Security Management Act, or FISMA, mandates annual audits of government contractors and suppliers. Hello, welcome to Module 4, Lesson 2 of our CASP Plus course. This lesson in Governance, Risk, and Compliance will cover the following topics about managing and mitigating vendor risks, covering vendor lock-in, merger acquisition risk, meeting the client requirements, and ongoing vendor assessment tools. So, explaining the importance of managing and mitigating vendor risk. An enterprise will need to assess risk whenever significant business changes are undertaken. There are many activities that will require an enterprise risk to be evaluated. A large enterprise may be engaged in outsourcing services to third-party vendors, often cloud-based. Maybe the enterprise will consider a merger or acquisition with a company operating within a different regulated industry. There are many examples of attacks that have been launched, like exploiting supply chains, often relying on a lack of visibility on the part of the enterprise. It is important to assess all risks that may be present when we work with third parties. When performing vendor assessments, we need to ensure they meet the expected levels of compliance required by the enterprise. Now, to ensure a vendor meets the expectations of the business, we may audit the vendor or use third party assessments. Now, the following topics should be considered during an assessment. First is we need to talk about vendor lock in. It is important to assess all available options when bringing in external providers or technology solutions. CSPs or cloud service providers would be a good example of potential lock-in, where the provider can impose strict financial penalties if the customer decides to switch CSP before the end of a specific contracted period. Now, if the service is not adequate and cannot be improved due to a lack of defined service level agreements, then the customer may have to accept an inferior service. So technology may also be a contributor to lock-in when bleeding-edge technologies may be adopted. Later, the customer realizes the solution locks them into an incompatible database format. This could result in a solution that would be very difficult to migrate to another platform. Vendor lockout could also be considered, and this is when the vendor makes it difficult to work with third parties as their service may be incompatible. Now let's talk about merger and acquisition risk. So when an enterprise is considering a merger or acquisition, it is important to consider all risks that may transpire. Merging with a company in another geographical region may introduce practical problems such as language barriers, cultural differences, and different working practices. Now, when considering mergers, it is important to assess the risks of co-joining networks, as there may be different regulatory requirements. And when moving into a new industry or business sector, regulatory compliance or legal requirements should be considered. Data may need to be segmented and classified to ensure correct data handling is observed. And when considering the mergers, it is also imperative to plan for correct handling and access of business data. Meeting client requirements. The enterprise may have very strict requirements, right, when engaging with third-party vendors. The enterprise may have strict legal requirements that must be addressed. Major changes that may impact the customers should be agreed upon in advance using an effective change management process. Now, if there are any significant changes in staffing levels that may impact the business, then there should be a clear communication channel for this event. When the vendor supplies staff directly to the business, then it is important that any staff changes are communicated to the business. Staff changes will require an onboarding and offboarding process. The client may also have very strict requirements concerning technology and the security configuration of information systems. Support availability. It is important to agree upon levels of service, right? And these agreements must be realistic and will be negotiated between both parties. Clear reporting metrics and agreed response times must be set. There should be a legally binding document generated, and this is known as our SLA or Service Level Agreement. Next is a geographical consideration. So data sovereignty is an important consideration for many organizations, including government agencies, critical infrastructure, and regulated industries. There is a legal requirement in some areas of operation that may require strict adherence to the storage and transmission of certain data types. It is important that the vendor service is compatible with these requirements. Supply chain visibility. So, when working with third party vendors, it is important to identify all potential risks that may be within the supply chain. Regulatory authorities have strict rules concerning data processors, such as in GDPR, right? Or General Data Protection Regulation, which is a very good example of this. A data processor is an entity that would handle customer records or other sensitive data on behalf of the data controller. A data controller can expose an enterprise to additional risks, and this is often referred to as a downstream liability. Next is incident reporting. If the vendor suffers an incident such as a data breach, then we must be informed in a timely manner. As the business will be the data controller, then the business is liable for subsequent actions. A large company, such as a bank, may work with a vendor to offer additional services to its customers. If the vendor processes the customer records data, then any breach that happened, right, whilst they process the data will impact the bank. Next is source code escrows. So here, when external development teams are engaged to write applications for the business, it is important to address risks associated with the potential failure of that external supplier. If time and money are invested in the development of tools and systems, it is imperative that the source code can be retrieved by the customer. In normal circumstances, source code would remain the property of the external developer. The customer may have paid for the development of functioning code only. Future bug fixes and security patches will be difficult without future proofing the availability of the original uncompiled source code. A third party would hold a copy of their source code, only releasing it to the customer in the event of the developers going out of business. Now let's talk about the ongoing vendor assessment tools. When third-party vendor is offering services to government agencies or commercial customers, then it is important that they meet the legal and regulatory requirements of their intended customer. Common examples of third-party assessments are discussed on the next slides. So here, the U.S. government FedRAMP program, right? That's the first one. So cloud providers offering services to the U.S. government must be accredited through what we call as the FedRAMP, or the Federal Risk and Authorization Management Program, before they can be given the authority to operate, right? So for more information, you can get more information from this website, https www.fedramp.gov. Next is the Cloud Security Alliance. So to prove compliance to commercial customers, organizations can be audited to meet the CSA Cloud Control Matrix. This is a cybersecurity control framework for cloud computing, cover 197 measured controls. Vendors who meet these standards can offer their services through the Cloud Security Alliance. Libing ko na. Nilibing ko na. May record lang ako. Now let's talk about ongoing vendor assessment tools. It is important for third-party vendors to adhere to their intended customers' legal and regulatory requirements when providing services to government organizations or commercial clients. The discussion of typical third-party assessment example are as follows. First is the U.S. government FedRAMP program. So before being authorized to operate, cloud service providers offering their services to the U.S. government must be accredited by the Federal Risk and Authorization Management, or FedRAMP, before they will be provided with an authority to operate, or ATO. So to find more information, you can go to www.fedramp.gov. Next is a Cloud Security Alliance. Organizations can be audited to ensure they meet the CSA Cloud Control Matrix in order to demonstrate compliance to commercial customers. This cloud computing cybersecurity control framework includes 197 measured controls. Vendors can offer their services through the Cloud Security Alliance if they meet these requirements. So the following links, right, will provide you additional details about the Cloud Security Alliance, or CSA. Next is the International Organization for Standardization, or what we call as ISO. So the ISO has defined a number of security standards. The following standards, right, would be of particular interest to vendors seeking to reassure clients for their adherence to security, right, which is this one. So this standard covers every important control that needs to be used when hosting information systems to guarantee secure operations. This standard does not grant accreditation or certification to any organization and is only intended as guidance. It enables a company to adhere to regulations, resulting in the adoption of the ISO 27001 compliance. So this specific URL will take you to for more information about ISO 27001, sorry. Next is technical testing. It is important that the vendor offers the required technology to satisfy the customer needs. The supplier might be a subcontractor in a manufacturing setting where quality assurance, or QA, is important and necessitates frequent on-site inspections. Next is network segmentation. Network segregation, right, is frequently needed for businesses in order to comply with regulatory bodies. As a result, the vendor must adhere to these specifications. Like, for example, the networks for industrial control systems, or ICS, SCADA, and OT, or operational technology, should not be connected to the same network as the user in the business world. Air gaps may be necessary for some vectors or some sector segmentation, while VLAN should suffice in other cases. Next is transmission control. Every effort must be made to maintain confidentiality when data must be sent between the customer and the vendor. Where the vendor will act on the client's behalf and share data with third parties, confidentiality is also important. The vendor might be in charge of maintaining and monitoring the SCADA network for the client. In this situation, they should use an IPsec tunnel and take the deployment of jump servers into considerations. Shared credentials. Now, since individual accounts are necessary for an effective audit trail, the use of shared credentials should be avoided. A user can gain full access to a system using the default credentials, such as the administrator account on Windows or the root account on Linux. It is common practice to grant users access by including them in a role group so that the accurate audit trail can be created. All right, that's the last part of the lesson. Here we spoke about vendor lock-in, merger acquisition risk, meeting client requirements, and the ongoing vendor assessment tools. Again, thank you very much for watching the video. Hello, welcome to Module 4, Lesson 3 of our CASP Plus course. This lesson in governance, risk, and compliance will cover the following topics about compliance frameworks, legal considerations, and organizational impact, covering the following: security concerns with integrating diverse industries, regulations, accreditations, and standards, legal considerations, and application of contract and agreement types. So, when an organization conducts business operations, it is important to take into account a number of success-related factors. Operating in a variety of industries may require compliance with legal or regulatory requirements as well as the adoption of standards. Regulations may be stringent, and in order to be given permission to operate and to demonstrate compliance controls, and policy must be implemented. Legal compliance is frequently a complicated topic that varies from nation to nation, and in some cases even between states or regions of the same nation. An organization needs to maintain a variety of connections for it to run smoothly. Now, formal agreements are needed in these relationships, usually legal agreements to protect the business. On the next slide, we're going to talk about each of these topics here. Security concerns associated with integrating diverse industries. Underestimating operational risk when supporting various business sectors and geographical locations presents a challenge for large multinational organizations. Both cultural differences between nations and country-specific laws and regulations can be complicated. A single company may operate in a number of different business sectors, including manufacturing, construction, oil exploration, and medical services. This graph illustrates some of the difficulties businesses face when diversifying. We will examine some of the difficulties posed by working in various industries in this section. First is data considerations. There are many responsibilities that an enterprise must be aware of when thinking about data protection, and these are the following that we have to be concerned of. First one is data sovereignty, right? So when a business considers hosting data that might be governed by laws and regulations pertaining to the storage of specific data types, data sovereignty is important. The strict regulation of the nation where the processed digital data was collected must be met. If a business stores and processes data from residents of another country, there are frequently strict regulations to take into account. Global service providers must be careful not to violate local laws when gathering or processing specific data types. Next is data ownership. By virtue of ownership, any data produced, acquired, and subsequently stored by the enterprise must now be handled securely and safely. Data ownership entails responsibility for data security on the part of the business. It is important that the business recognizes the value of the data and puts the controls in place necessary to comply with legal regulatory requirements. Third is data classifications. Data should be classified to reflect the value to the business and to ensure that the proper legal and regulatory controls are put in place in order to ensure proper data handling. Data may not be secured in accordance with regulatory requirements if it's not accurately labeled. Next is data retention. Data retention, right? Here, when deciding on data retention policies, it is crucial to make sure that the legal and regulatory requirements are met. Data must be labeled and stored in accordance with applicable laws, including local, state, and sometimes even federal laws. To comply with regulatory requirements, different data types may have different retention requirements. Like accounts payables and receivable ledgers must be kept for 7 years per the Sarbanes-Oxley Act of 2002 or SOX, but customer purchase orders and invoices only need to be kept for 5 years. Now let's talk about the data types. So this is still under the data considerations. So an organization that operates in various variety or in a variety of industries is likely to store and manage data that must adhere to various legal and regulatory requirements. It's also critical to recognize the various data types in order to implement the appropriate controls. The first one is health, right, or health data. Strict privacy laws and guidelines will apply to all protected health information, or what we call as the PHI. Okay. Patient records will be kept by hospitals, clinics, physicians, and healthcare insurance companies, and the handling of this kind of data is subject to strict regulations. Next is financial data. So, accounts receivable, accounts payable, purchase ledgers, and corporation tax records are some examples of financial records. Because this data is sensitive, it needs to be marked and handled carefully, as there will be strict requirements for legal and regulatory compliance. Data retention must be strictly complied with. Next is IP, or the intellectual property. Data that belongs to the organization is known as IP, or intellectual property, and it typically has a high value because it may also include research data, design blueprints, software source code, patented ideas, and products that the organization may manufacture. Now, to prevent being harmed by having these priceless assets exposed, a company needs to have strong security measures, along with strict protection via patents, copyrights, and legal recourse. Strict data handling and storage are necessary as well. And the fourth one is PII, or the personally identifiable information. PII is information that is electronically stored about people who are customers, students, employees, or citizens of a nation. In general, we can state that it is the information connected to a person who can be identified. Different regulatory bodies and nations may have different definitions of PII. PII is defined as data that can be linked to a specific person. Therefore, obvious PII would consist of the date of birth, passport number, health information, employment information, and academic information. Okay, so the implications of privacy across various industries, regulatory bodies, and national laws must be understood by organizations that control or process data. Now let's talk about geographical considerations. So when a data controller is hosting the data, they need to make sure that the laws governing the kinds of data and the locations where the data will be stored and processed are followed. When data may be processed and stored abroad, the business must be aware of all applicable legal and regulatory requirements. The data subject's location is another important consideration because it may affect how far regulations must be followed. Here are the three considerations here. First is the location of data. The location of the data will be important because it might be necessary to establish legal jurisdiction, and for some types of data, sovereignty laws or regulations might be relevant. Location of the data subject. No matter where the data is stored or processed, many laws and regulations apply to data subjects. This can get very complicated because there are different data processing and privacy laws in over 100 different countries. State regulations exist in the US in addition to federal regulations. The CCPA, or the California Consumer Private Act, which gives people the right to know what personal information businesses collect about them and how it is used and shared, is an illustration of such regulation. And the third one is the location of the cloud provider. The cloud provider's location could be important. In general, processing requirements for government data are very strict. The location of this hosted service could be crucial if the cloud provider is offering services like SaaS or software as a service, because the regulatory requirements are frequently very complex. The enterprise may think about using outside audits or consultants to confirm that the controls put in place by the company are adequate. Let's talk about the third one, which is third party attestation of compliance. Third-party attestation is frequently required for business reasons. It might occasionally also be a legal requirement. And when providing a service to a customer, attestation provided by a third-party audit is typically more trusted. A company might claim, for instance, that they adhere to the ISO 27001 standards best practice. Potential customers will value them more if they are independently audited to ensure that they meet all objectives. Now let's talk about regulations, accreditations, and standards. All right, so an organization must show clients and collaborators that it has adopted tried and true methods for conducting business. This communicates to the partner or customer that the goods or service meets their needs. In many instances, failing to implement the proper controls will prevent you from receiving the proper accreditation. If controls and standards are not upheld, the company runs the risk of having its accreditation revoked. We're going to look at some instances of rules, certifications, and requirements. First one is the PCI DSS, or the Payment Card Industry Data Security Standard. So here, if a company wants to process data or debit card or credit card transactions and store cardholder data, PCI compliance is required. So the PCI DSS regulates these actions. This council was established primarily to oversee and regulate the security of cardholder data and to reduce the possibility of fraudulent use of payment card information. The council was established in 2006 and is made up of JCB, International, MasterCard, Visa, Amex, and Discover. An organization must fulfill important requirements as shown in this right in order to receive the council's accreditation. Assessments are pertinent to the business must be carried out in order to comply with the PCI DSS. You may also visit this specific website if you want to learn more about the PCI DSS requirements. Next is GDPR, or General Data Protection Regulations. GDPR is intended to protect the personal data of European Union citizens stored in information systems both within and outside the EU. If an entity intends to collect and store information, it is regulated and overseen by GDPR, and the collecting entities must ensure they are compliant. GDPR has strict regulations that apply to the classification, storage, and processing of the data. So in this figure, right here, we can see an example of the roles that are used within the GDPR compliance, which includes the data controller, data processor, data protection officer, and the supervisory authority. Next is ISO. The ISO was founded in 1947 and is committed to developing standards that enable interoperability across a wide range of international diverse industries. The ISO is a group of independent standard bodies that numbers about 165 at the moment. It is a good practice to adopt standards in order to operate effectively and cooperate with third-party entities. An organization's marketability will increase if it can show that it is accredited or that it supports the accepted standards. Any size of organization can use the ISO 31000 standard, which is made up to help with risk management. If it is a framework that can be used by a company to identify risk and allocate resources to manage them. However, the standard does not grant accreditation to an organization. It only provides advice. Now you can click on this link to learn more about the ISO standards at iso.org. All right, now let's talk about CMMI, or the Capability Maturity Model Integration. So CMMI is primarily a methodology for enhancing the software development processes, and it enables an organization to create procedures that reduce risks that are frequently present in the creation of software and services. It was initially created by the Carnegie Mellon University, or CMU, and the CMMI Institute now oversees its administration. So CMMI is quite important for business seeking U.S. government contracts because it frequently serves as a requirement for this kind of engagement. Although accreditation is not possible, a company can be evaluated and given a maturity level rating between 1 and 5. So the 5 maturity levels are depicted in this figure, which starts from initial, managed, defined, quantitatively managed, and optimized. Now, to ensure that customers can be confident in the provider's commitment to maintaining and improving standards during service and software development, the organization's objective is to reach level 5. Next is NIST, or National Institute of Standards and Technology. NIST receiving funding from the government because it is an agency of the U.S. Department of Commerce. NIST was founded in 1901 and offers advice to a wide range of industries. Next is COPA, or the Children's Online Privacy Protection Act. So in an effort to limit the collection of PII from children without parental consent, COPA was enacted in the US in 1998. This is an important factor for online content providers and services to take into account given the abundance of websites and content geared toward young people. Companies hosting content in the US are subject to it, and children outside of the US are also covered by the jurisdiction. Next is the CC, or the Common Criteria. Members of the CC come from various participating nations. ID services and controls must be evaluated and certified by 17 nations. The assessments and accreditation that the CC offers are also used in 14 other countries. The ISO IEC 15408 standard governs certification of security measures and information systems. Also, an example certificate of compliance given to an approved operating system is shown in this specific table. The CC currently lists more than 1,500 certified products, and this figure provides some examples of the categories and products. You may also click on this link below if you want to get a complete list of products that have been certified by CC. And the last one is STAR, or the Security Trust Assurance and Risk. Now, by joining the CSA, CSPs or cloud service providers can highlight their offerings and adherence to accepted best practices. Members include SaaS providers, solution providers, and cloud consumers. The CSA also has a sizable contributor community that advances in um, industry best practices and secure cloud security. There's support for personal certification for security professionals who want to prove their proficiency in cloud computing, and in addition to certification and accreditation for providers. You may visit the following website for more information on personal certification here. Now let's talk about legal consideration. The risk of failing to comply with laws and regulatory authorities is one of the biggest threats on enterprise. Legal staff that has been trained in these areas may be necessary as legal regulations that can be complicated. Litigation and penalties are two possible outcomes. Additionally, there's a chance that regulatory body will revoke the company's authority to operate, or ATO, which is definitely a possibility in industries like nuclear power or finance. Now we're going to look at this few important elements. First is due diligence. When operating within the strict regulatory frameworks, an organization must be aware of all legal and regulatory requirements. Making sure that the company takes action to determine what controls and mitigation should be put in place to safeguard information systems is part of the responsibility. Now, to keep in mind the importance of diligence, ask yourself, what are my responsibilities? The risks involved with storing sensitive data should be carefully considered. Due care. So after the organization has evaluated all the needs to safeguard the information systems, it is in charge of mitigation, and controls must be put into place and kept up with. After evaluating all the risks, an organization would take the necessary precautions to safeguard the sensitive data. Next is export controls. Regarding the export of delicate technology, including hardware and software, many nations have strict regulations. Without obtaining the necessary export licenses or confirming that the technology is on the government's restricted list, it is often illegal to export sensitive technologies. Military hardware or the sale of weapons are obvious restricted items, but technology integrated into a mobile smartphone is another possibility. You may visit this website, right, for the most recent list of export regulations affecting the US organizations. You may also visit this specific website, right, to get more information on UK export restrictions. Next is legal holds. So a business should be equipped to respond to a valid legal hold. A court order or a request from the law enforcement or a government organization may be used to obtain this. Data must be kept safe, otherwise the business will be in violation of the order. Electronic records, paper records, and mobile data sources will all be subject to a legal hold. Since the legal hold take precedence and could last for years, it is crucial to halt all routine activities such as data retention policies. Next is e-discovery. So after the data has been frozen, we can start looking for the pertinent device. Um, the dates of the required electronic documentation and the extent of the data must be specified in a clear set of instructions. So here, there needs to be a consensus regarding the data formats, including whether or not metadata might also be necessary. When a legal notice is delivered, a company must be able to react quickly, and due to the complexity of the law, it is frequently necessary to seek legal counsel for specific advice. All right, now let's talk about the application of contract and agreement types. So it is important to record interactions with third-party entities and, where necessary, make sure that the proper legal terms are agreed upon and approved in order to maintain regulatory or legal compliance. Now let's take a look at these few common documents. First is SLA or Service Level Agreement. So here, a customer and a service provider must negotiate an SLA, which is significantly a legally binding document. Typically, the conditions will include metrics to ascertain the performance standards required by the customer and the strict penalties to account for subpar service levels. Next is OLA, Operational Level Agreement, right? So there could be a lot of internal dependencies for a service provider, which could have an impact on how successfully services are delivered to a client. A sizable cloud provider may have agreed to a strict SLA in exchange for delivering a full range of information systems. Now, in the event of an unplanned outage, the internal storage system's SAN recovery time objective is 2 hours, but the customer has agreed to only accept downtime of 30 minutes. The service provider must match these expectations. An OLA will guarantee that all reliant internal services can assist the client. The storage team should consider an RTO of less than 30 minutes in these situations. OLAs are only used internally and are non-negotiated with external clients. Next is MSA. If an organization plans to use a third-party service provider for a variety of services, this kind of agreement would then be beneficial. It enables an agreement between the business where the majority of the terms are decided upon beforehand. Payments, schedules, dispute resolution procedures, intellectual property ownership rights, and operational locations are examples of typical terms. Next is NDA. Here, it is also important to have employees and service providers sign this agreement in cases where data privacy is a requirement. They should be made aware of the strict conditions of this agreement and the potential consequences if they don't comply. Next is MOU, or the Memorandum of Understanding. An MOU may be helpful when there is a need for a formal process to define roles and responsibilities between two or more parties. When something more formal than a handshake or gentleman's agreement is required, it is a good option. It will not, however, provide the same level of protection as a document prepared by attorneys because is not a legal requirement. Next is ISA, or Interconnection Security Agreement. When it's necessary to specify stringent guidelines for managing an interconnection between two or more parties, an ISA can be used. The agreement may specify the sites that will actually participate in the data interchange, the data types that will be exchanged, security requirements, and a time frame for when the business information will be supported. When businesses need to share training materials, coordinate projects, or specify criteria for secure data storage, it can be helpful. The NIST SP 800-47 provides some helpful advice on this kind of agreement. And if you want to look for more details, you can go to this specific link. All right, and the last one is the PLA, or the Privacy Level Agreement. So here, customers must be able to trust cloud providers to protect their data while it is being hosted by them. A PLA guarantees that the service provider will help the customer data and that the agreed upon procedures are in place in the event of data breaches or other unfavorable actions. For instance, CSPs that are allied with the CSA can carry out an evaluation and demonstration to clients that they are in compliance with the EU GDPR. You may visit the following website, right? Which is put it here, tinyurl dot CSA compliance. Now you can look at this one on the PPT, right? So this is used to protect businesses, and it is important to identify and implement the appropriate business agreements. All right, that's the end of the lesson. Here we spoke about security concerns with integrating diverse industries, regulations, accreditation and standards, legal considerations, and application of contract and agreement types. All right, thank you very much for watching the video. Hello, welcome to Module 4, Lesson 4 of our CASP Plus course. This lesson in governance and risk and compliance will cover the following topics about business continuity and disaster recovery, covering business impact analysis or BIA, DRP and BCP planning, and testing planning. Just to give an introduction, high-level planning and mitigation controls should be implemented to ensure the enterprise is resilient so that an organization can conduct business operations in difficult and diverse environments. Plans for business continuity must be created when the company offers high-value services. Plans should be made to enable the business to continue operating in the event that a significant disruption could have an impact on the services that are delivered. Plans should be created to guarantee that in the event of a disaster, business operations can be quickly and effectively resumed. For services to be available, factors like high availability, redundancy, and fault tolerance are crucial. To ensure business continuity, it might be necessary to identify alternative locations. Let's talk about conducting a business impact analysis. So, making sure that there are contingency plans in place to safeguard the company from unfavorable situations and events is one of the most important things of an organization to do. Business leaders must make sure that a business impact analysis or BIA, right, is carried out to identify important systems and services that, if unavailable, will have a disproportionately negative impact on the enterprise. Involving stakeholders helps the business and identify important business processes. The purpose of the assessment ought to come first. Three steps can be taken to complete this, right? So first is determine the mission or business processes and recovery criticality. Identify the resource requirements. and the identification of recovery priorities for system resources. All right. So the initial purpose of the document can be used as the foundation for a DRP, as well as to build a contingency plan. This information can also be used to create a cybersecurity response plan once key systems have been identified. A BIA's goal is to pinpoint the essential services that company provides and comprehend the possible effects of service interruption. This exercise aims to build enterprise resilience through the development of our backup plans. Using the following metrics, business leaders must decide on acceptable downtime and identify the critical resources the company needs. So here are some important concepts. First one is MTD, or the maximum tolerable downtime. So with the help of this metric, right, planners and stakeholders can determine when a critical resource would be seriously affected by its absence. For instance, if an airline is unable to fly planes for 6 months, it will deplete its cash reserves and possibly go out of business. Therefore, the MTD becomes the boundary that cannot be crossed. So as you will see here, this is actually the an example of the maximum tolerable downtime, right? So once the disaster strikes, then well, this is the time taken, right, for it to be able to run on the normal business processes, right? So this is the what we call as the MTD. That's before the actual business is running. Next concept is RTO, or the recovery time objective. The planning team will decide on the RTO metric, which is a target set by the enterprise. Based on its criticality, a critical service with a high value to the business will be given a value. An e-commerce site, right, for example, that allows users to reserve airline seats for customers may be considered an important service. The company will lose a lot of money if the site is inaccessible. It is important to refer to the MTD value when using this planning objective because the RTO must be less than the MTD, which is actually being showed here, right? So this is the RTO, and you have here the MTD, right? Which is the time it takes for the normal business to resume. But for the RTO, that's until this area testing the critical apps. Next is RPO. So when the restoration of a critical service necessitates the restoration of data, the RPO metric is employed. This will always be pertinent when taking the prompt restoration of services into account. We must also make sure that the necessary data is available for the reservation system if the customer reservation site needs to be operational in less than 4 hours. We might not be able to live without this data because it might include information about reservations and tickets that have already been purchased. Although some customers will be inconvenienced because of they lost their seat reservation, an RPO of 60 minutes may be acceptable. The RPO shows how much time passed between the disruption and the most recent backup. Business leaders will identify critical services, and the metrics they define will reflect how important the service is. Next concept is RSL, or the recovery service level. First, it is necessary to recover the essential services, right, needed to carry out a business function. It is also critical that revenue can be generated by bringing the service back online right away, in the case of the airline booking system. Once the critical services are restored, other functional aspects like printing customer tickets might be addressed. Next is MEF, Mission Essential Functions. So here the planning team must determine which tasks are important to achieve the mission. This plan needs to input or needs input from important stakeholders and the senior business leaders. A single point of failure for the business would typically be a mission essential function. To highlight these features and agreed upon goals to reduce these single points of failure, documentation would be made. As you will see, this figure shows an example of a mission essential planning, right? So let's say you have a booking system, you have a payment system, you have a specific set of a number of hours in terms of MTD, RTO, and RPO, which is in here. So the ability to achieve objectives is ensured by setting appropriate planning objectives for mission critical functions, which are potential single points of failure. Next and last one is a PIA, right, or the Privacy Impact Assessment. So here, any organization that stores, transmits, or processes data that contains personal information should conduct a PIA, or Privacy Impact Assessment. Documents, database records, media like CCTV footage, and voice recordings are some examples of the various types of data that can be used. Any project that might expose subjects' private information must undergo a DPIA, or a Data Protection Impact Assessment, which is a required procedure under GDPR. A typical method for evaluating risks when handling personal data is depicted here on this specific illustration. So for use in this type of assessment, a helpful planning document is available for download on this specific site, right? So you can actually see it on the script, tiny url.com dot gdpr dash dpia. That's it. So here, an organization needs to set up procedures, right, to make sure the enterprise doesn't stray from its alignment, because regulatory compliance is frequently a difficult process. The risk to the company could be high, and the fines by themselves could be sizable. Right? Now let's talk about DRP and BCP. So the BIA, right, or business impact analysis or assessment, right? All right, now let's talk about DRP and BCP planning. So the BIA should enable the company to identify mitigation strategies and make plans for the return of business operations in the event of significant disruptions. Organizations in need of direction on how to effectively create and manage BCP should consult ISO number 2222301 for a summary of standard. The 7 stages of the NIST contingency plan are depicted on this figure, right? So starts with the develop the contingency planning policy, conduct the business impact analysis, identify controls or preventive controls, creative contingency strategies, develop an information system contingency plan, ensure plan testing, training, and exercise, and ensure plan maintenance. Okay, so planning for mission essential functions is covered by what we call as a COOP, which is called the Continuity of Operations Plan and is not included in the contingency plan. So, the establishment of COOP is a significant result for us government organizations. A COOP uses alternative sites to focus on establishing the organization's mission essential functions. For up to 30 days, the COOP must support operations. So here, this list shows a few of the COOP components, like the program plans procedures, risk management, budgeting and acquisition of resources, essential functions, order of succession, delegation of authority, continuity facilities, continuity communications, test, training, and exercise. Because COOP is made of to address mission critical functions, it will not cover interruptions caused by small threats. Where the company will run from if the primary site is unavailable is a crucial factor. It is also necessary to locate facilities that will satisfy the needs of the organization. All right, so let's talk about some additional components, right? So, which is included in the DRP and BCP. So we have what we call as a cold site. So this is actually the least expensive option when considering alternative locations to operate the business. If the business needs to be operational quickly, it is, however, the least effective. Leased office space and facilities for computing equipment are two examples of cold sites. The organization might be experience a sizable delay due to the time it will take to move personnel and systems and get them operational. Next is a warm site, right? So a warm site might be a good option if the company needs to move operations to a new location in a matter of hours rather than days. A warm site has facilities and equipment that are ready for use by the business. To make the location operational, people and data must be moved together. Third is a hot site. A hot site typically contains all the hardware and information required for the business to carry on with its operation. The location might or the location must enable the organization to quickly switch operations. If the company uses an e-commerce or critical infrastructure, the site would be completely replicated with all the necessary data and information systems. In a matter of seconds, many solutions are built to fail over to the hot site. If your company promises customers an SLA of 99.9999, that's four nines, right, on the decimal value, then your website cannot be down for more than 31.56 seconds annually. Okay? Last is a mobile site. Hello, welcome to our CompTIA Security Plus course. In this lesson, we're going to talk about control categories, control types, and compensating controls. So to compare controls, it is helpful to understand the general taxonomy of controls. A control is simply a defense or countermeasure put in place to manage what we call as risk, right? Risk. So if a risk cannot be completely avoided and transferred, but the organization is not willing to completely accept the risk, the most appropriate action is to mitigate the risk. Okay, put it here. So controls can be classified in several ways, and some controls can apply across various types. At a high level, controls are classified as technical, managerial or management, and operational. Controls can be further classified by their functional use or according to the time period during which they are acted upon. For example, functionally they can be classified as deterrent, preventive, detective, or corrective controls. Now you can apply this general classification of controls to mitigate risk, typically layering defensive controls to protect data with multiple control types. This technique is called a layered defensive strategy or defense in depth, right? Like DID, as we discussed from the previous chapters or section, right? Defense in depth. Now, let's dig deep on the three types of control. The first one is technical, of course. So here, the technical controls are security mechanisms that the specific systems run, either manually or more often automated and orchestrated. These controls deliver confidentiality, integrity, authenticity, and availability protections. They defend against unauthorized access or misuse. They also facilitate detection of security violations and support security requirements for applications and data. Now, some common technical controls would be infrastructure security, right, and device hardening, like for example, your firewalls and your IDS and IPS systems, right? And we also have identity and access management or IAM, cryptographic key management and HSM, right? HSM is hardware security modules, right? And we also can implement web application firewalls or WAF and threat modeling tools and next generation endpoint protection and response. So in Cisco, they have what we call as AMP, right? That's their endpoint detection software. Now let's talk about managerial, right? So managerial controls are often referred to as administrative controls, right? Admin. And it's very important that these types of controls are published or printed or documented in some definition of policies. And of course, policies are driven by governance, right? Whether you have a board of directors or a steering committee or your executive management, that's what's going to drive down the policies. So this would be things like how your company does risk assessment, right? And risk management, your best practices and guidelines, your password policies, and the procedures you go through for screening, right? Background checks, hiring, and termination. So it could be things like dual operator principles or mandatory vacations and training and awareness programs. Okay. Now, the third one is operational. This one. So operational controls include organizational culture and physical controls that form the outer line of defense against direct access to data, such as protecting backup media or securing output and mobile file storage devices, and paying attention to facility design, right? And details, including layout, guards, locks, and surveillance system, right? All of this talks about physical controls. Now, next is this could also be a change of configuration management database that stores all of your CIs, right, or your configuration items. You can also conduct security awareness and training of your acceptable use policy and implementing physical and environmental controls, like for example, for heat and cold and humidity, fire detection and suppression, contingency planning, incident response, testing, and drills, right? This could also include the system and data integrity mechanisms, like mobile device and application management, and disaster recovery plan testing and disaster recovery drills or exercises. Now let's talk about control types. The categories of controls that we just described earlier, right, is classified whether functional use or whether on the time when they are in use. So the following sections describe these controls and will provide examples of each of them, right? So the list of control types here are deterrent, right? Preventive, detective, and corrective. Now consider the importance of having both detection controls and prevention controls. In a perfect world, right, we would need only prevention controls. Unfortunately, that not all malicious activity can be prevented. As a result, it is important to make detection controls as part of a layered security approach. For example, the best protected banks use both detective controls and preventive controls. In addition to the locks, bars, and security signs, the bank probably has various detective controls such as motion detectors and cash register audits. Now, controls work together as a security system and provide layered defense mechanisms for defense in depth or DID. Now, let's dig deep on each of this one, right? So, again, the first one is deterrent. So, deterrent controls are intended to discourage individuals from intentionally violating information security policies or procedures. Now, deterrents do not necessarily have to be designed to stop unauthorized access. And as the name implies, these controls need to help deter access. They usually take the form of a punishment or consequence that makes performing unauthorized activities desirable. Deterrence involves detecting violations that are attached to some form of punishment that the intruder fears. Examples of deterrent controls are warnings indicating that systems are being monitored. Perhaps you have seen or know someone who has a beware of dog sign but doesn't actually have a dog. Next is preventive. Preventive controls attempt to prevent unwanted events by inhibiting the free use of computing resources. Preventive controls are often hard for users to accept because they restrict free use of resources. Examples of preventive administrative controls include security awareness, separation of duties, access controls, security policies and procedures, intrusion prevention system, firewalls, and anti-malware. Next are detective controls. Detective controls attempt to identify unwanted events after they have occurred. Common technical detective controls include audit trails, intrusion detection systems, system monitoring, checksums, and anti-malware. Common physical detective controls include motion detectors, CCTV monitors, and alarms, right? Administrative detective controls are used to determine compliance with security policies and procedures. They can include security reviews and audits, mandatory vacations, and rotation of duties. And the last type is corrective. So, corrective controls are reactive, right, and provide measures to reduce harmful effects or restore the system that is being affected. So, examples of corrective controls include operating system upgrades, data backup restoration, vulnerability mitigation, and anti-malware. Now, let's talk about compensating controls. Compensating controls are alternative controls that are intended to reduce the risk of an existing or potential control weakness. Compensating controls are not a shortcut to compliance or security. They come into play when a business or technological constraint exists and an effective alternate control is used in the current security threat landscape. For example, if a separation of duties is required but duties cannot be separated because of company size, compensating control should be in place. They can include audit trails and transaction logs that someone in a higher position reviews. Now we need to look no further than our daily lives to find examples and analyses of the various types of controls and compensating controls that we encounter every day. In your digital life, you might have met someone who doesn't want to incur the cost, right, like monetary or perceived technical, of running anti-malware software. Now, that person might compensate, like for example, by being extra careful and navigating to only well known trusted websites. Also, consider the following examples here. So, in order to prevent unwanted network access, right, in the wired network, the compensating control is to simply disable the unused switchboards. To also segregate or to ensure the segregation of duties is followed, a video surveillance can be the compensating control here. Now, to be able to ensure multi-factor authentication for each application, we can implement network access control with multi-factor authentication, right? That's the end of the lesson. In this lesson, we spoke about control categories, control types, and the compensating controls. Thank you for watching the video.
And the next one is what we call as a mobile site, right? So typically a trailer's back is used to deliver a mobile recovery site. It might appear as a cool, cold, warm, or hot site. It can be delivered close to the staff's location, eliminating a significant logistical obstacle. A mobile site is not a good option if the company needs a solution that can be used immediately. Military solutions are an example of a mobile site, and organizational resilience is important. The US military is capable of deploying mobile data centers with enough infrastructure to house 90 or around 90 computing units. There's also room for 20 people in the pop-out tents, including the unit. As you will see, this figure depicts a portable data center, and within 15 minutes, the device can be operational and secure communications can be set up. Let's talk about testing plans. So, thorough testing will be required to ensure that enterprise BCP and DRP will be effective. There's no assurance that the plan will work without testing. So, the first part, or the first part that we're going to discuss about testing plans is a checklist. A checklist test is an independent review of the BCP DRP documentation by stakeholders and team members. This calls for disseminating the plan to the appropriate parties and setting up a channel for feedback. This particular test aims to identify any inaccuracies or mistakes in the documents. Next is tabletop exercises. So, to determine whether a proposed plan might have any potential issues, it is crucial to gather input from the company representatives. Participation of stakeholders is important when evaluating the effectiveness of the plan. Now, discussions of scenarios and evaluations of necessary actions are both possible. The DRT, or the Disaster Recovery Team, or the CSIR, the Cybersecurity Incident Response Team, won't need to conduct extensive testing before the plans are polished, and that is thanks to tabletop exercises. Next is a walkthrough. So examining specific components of a plan is referred to as paper-based testing or a walkthrough. It enables the plan's creators to talk about a specific procedure within the larger scheme. Stakeholders who would be impacted by this aspect of the plan could also provide feedback during the walkthrough. Next is a parallel test, simulation test. When the plan is fully developed, parallel or simulation testing can be used to assess its efficacy. This test can be run on backup systems without affecting the production environment. And the last component is full interruption test. Full interruption test or cutover testing should be used when the enterprise must be certain that the BCPs or DRPs will be fully effective. It should only be used after all other types of tests have been successful completed because it can disrupt business operations. All right, that's the end of the lesson. In this lesson, we spoke about BIA, Business Impact Analysis, DRP and BCP planning, and testing plans. Thank you very much for watching the video.